In this video, we will talk about the named entity recognition. So, when we talk about named entity recognition, it's a task that we perform in natural language processing. So, as we proceed in this video, we will look into the concept of named entity recognition, how it actually works, and to get a better understanding about this named entity recognition, we'll take up a case study so that you'll understand what is the importance of this named entity recognition. So let's get started. Let's start by understanding named entity recognition. So when we talk about the named entity recognition, the term that you need to understand is an entity. So this entity, it can be generally defined as a part of text that is of the interest to the data scientist or to the business. That's what an entity is all about. And when we say named entity recognition, which is also known as entity identification or entity extraction, is a natural language processing technique which automatically identifies the named entities in a given text and classifies them into a predefined categories. That's the overall idea behind this named entity recognition. Now, this named entity recognition has various applications, and one commonly used application is the chatbot. In case of chatbot, we'll be using a lot of this named entity recognition, and generally when the user gives the input, then at that time I want to identify the important parts of the user's input, and that's where the terminology of entity comes into picture in chatbot as well, and that's the application of named entity recognition. Now to give you an example, here let's say I've got a text that says as Rajesh works at Microsoft. Now let's assume this is a given text with me. This is the text document that I have got with me. Here I want to extract the word of Rajesh, and I also want to extract the word of Microsoft. Okay, and here I want to extract this information and I want to assign the tag like Rajesh as a person tag and Microsoft as an organization tag. So what I have done is, for the given text document, I have identified the important entities, and that is the words, and I have assigned the respective entities. The entities are person and organization. So these are the predefined entities. So this is what we call it as a named entity recognition. Okay. Now the way this is going to work is, see, when we read any text, as a human being, it's very easy for us to recognize the named entities like people, values, location, and so on. For example, here when I've got a text that says as Narendra Modi is Prime Minister of India, here Narendra Modi is a person and India is actually a country. Now, in order to do the same with the help of text data, that's where we'll make use of machine learning and natural language processing. Now that you have understood what exactly is a named entity recognition, let's go ahead and perform this named entity recognition in an online manner. So I'll give you a demonstration of the same. So let's perform the named entity recognition. So I'll open up in my browser. See, this is one of the site that we have got where we can mention the text, and this will help me to perform the tagging and the respective value that has been identified. So I'll say Narendra Modi is Prime Minister of India. And if I click on the exact text, see, it has identified the person, that is the Narendra Modi, as a person. Okay, so in this way we can extract the important entities. So I think the India is not getting extracted. Let's say USA. Okay, I'll just mention it as USA. So maybe this default the named entity extractor. So this is actually a name extractor, hence it has extracted the name. So when we also have the named entity extractor, if we have any other entity apart from the name, we would have also done the same. So this is the overall idea behind this named entity extraction. Okay, so it will help me to get the input text data and perform some processing and help me to extract the important information from the text data. That's the overall idea behind this named entity extraction or the named entity recognizers. Now, let's consider a case study. The case study that we are going to consider is for the insurance company. Let's assume that you are working in an insurance company and the claims team receives thousands of emails from the customers regarding their claim. Now the claims operation team goes through each and every email and updates the online form with the details before acting upon them. So they have to extract the information from the email, and from that email they'll have to register those data somewhere in their database so that they can start working. Now in this scenario, if you want to automate this, then in such scenarios, you can automate this work by pre-populating the online form by creating the named entity recognizers. So what you can do is you can build a task which will be a custom named entity recognition algorithm, which will help us to extract the custom entities from the given domain dataset so that you can efficiently automate this task and automate this activity so that you can efficiently work and improve the productivity of the employees. So this is one of the case study where this named entity recognizer or the extractors can be used in real time. Now, in order to perform this named entity recognition, we've got various APIs that are available. So these are the publicly available APIs or the libraries. We've got Spacey library, we've got NLTK library, we've got Stanford named entity recognizers. This is also one of the public API that is available to us. So by making use of all these options, we can actually create the named entity recognizers. All right, so this was about the named entity recognition, and we have already done this in a hands-on manner in our previous section, that is the initial section of working with the text data. Now, as we progress in the next video, let's see how we can perform this named entity recognition using CRF, that is the conditional random fields. So we'll get a high-level understanding about the same as we proceed in our next video. So I'll see you next time. In this video, let's look into the activity of NER, that is named entity recognition using conditional random fields. So let's get started. Now, whenever we are working with the applications such as named entity recognition, so this is like working with the sequence data. So the expectation is we should be able to analyze the entire given text document. And once we analyze the entire text document, then we will find the various pattern according to the grammatical rules. Now in doing that, we've got regular expression approach, we've got hidden Markov model approach, and we have max ent Markov model approach, and the other approach that we have got is conditional random fields. So these are the various approaches that we have got when we talk about this finding the named entity recognition for the given data set. Now, out of all these approach, one most prominent approach is called as conditional random fields, which is also known as CRF. Now, this CRF belongs to the family of sequence modeling. And here, this CRF model assumes that the features are dependent on each other, which is one of the important assumptions that we have to consider. The reason is whenever we are working with the text data, each and every word in a given document are actually interrelated. So having this assumption will really help us in finding the entities from a given data set in a much more efficient way. And along with that, it also considers the future observation while learning the pattern. And this methodology of the CRF combines the best of both HMM as well as the MEMM model, which I've mentioned earlier, and it's also a best when it comes to the performance. Here, the conditional random fields basically has two components. One is a normalization component, and the other component is called as weights and features. So let's get a high level understanding as what it is and get a better picture about the conditional random field. So this is more of a mathematical perspective so that you can get the better understanding about this concept of conditional random fields. So I'll try to, wherever possible, I'll try to ensure that I'll be explaining it in a simple way. So ensure that you follow along with me. All right, so let's get started. Here, whenever we are working with the text data, especially for the task of named entity recognition, first thing that we have to do is we have to decide the feature functions. So here, when we are working and performing the activity of named entity recognition using this CRF, we have to extract multiple features per word of the sentence that will be helping us in recognizing a named entity. Now, in order to do this, we would require a function that is called as feature functions. Now, this feature function will assist in generating the unique features for the given text data. Now, these feature functions can consider any logic depending on what I'll be writing, but the output has to be either true or false. Okay, it's the output I would expect is either true or false for this feature function. Now, to give you an example, okay, let me just write it like this. So this feature function will have some kind of a rules. Let's suppose if I'm generating the embeddings for a word WI. Let's consider the embedding for the word WI. Now for the embeddings for the words of WI, for this I'll also consider the embeddings of the neighboring words and the part of speech of my neighboring words, the base phrase syntactic chunk label for this WI, and I will also consider the neighboring words of WI in a given data set. Okay, so in this scenario, it is also known as a gazetteer. So gazetteer is actually the list of places. It could be China or it could be USA with their geographical and political information, and it will definitely have the millions of entries. Now, what I'll do is I'll write some rules that says as, let's assume this particular word WI contains a particular prefix, or if it contains the particular suffix, or if it is present in uppercase, lowercase. So I'll be writing all these kinds of some conditions. Okay, we'll just come up with all these conditions, and as a result of this condition, for a given text document, I'm going to extract the overall entity. Okay, we'll just go ahead and extract the entity. And along with extraction of entity, so the overall idea is simplicity. So what we'll be doing is we'll be writing some function, and this function will have the set of rules. I'll look into the current word, and I'll also look into the neighboring words, and I'll also look into its shape, whether it is in uppercase, lowercase. I'll apply all these things, and based on that, I'll be extracting the entity. So this is the overall idea about the high level idea behind the feature functions. Now, when we talk about this CRF, as I mentioned earlier, this basically has this function or this equation. Okay, or this is the formula for CRF. Here, P of y given x refers to the probability of calculating a label sequence y given a word sequence x. And we have also written as exp. This exp refers to the exponentiation in the given formula. Okay, so that is what it currently says. And here, this each term that you see right here, especially on this exponentiation, the inner summation goes from k is equal to 1 to k. That is the length of the sentence that I have got. And here we are summating the value of any feature function for all the words in a given sentence. Now let's suppose if I've got a sentence that says as Rajesh is amazing. Okay, let's assume I've got a sentence that says as Rajesh is amazing. Let me just write it down. So if I have a sentence as Rajesh is amazing, the inner summation will add the values of the output of the jth feature function for all the three words in a given sentence. Okay, so we will apply this mathematical function, and once we apply the mathematical function, we will have the overall weights. Okay, so the value of weights that we would get will be corresponding to the each function to be set. Now once that is done, we will use the training data set, and we are going to perform the activity of training for our model, and we'll also make use of a loss function. There are various loss functions that we have got available, so we can make use of the loss function depending on our data set, and then we will perform the overall implementation of the same. All right, So this is the high level details of performing the named entity recognition for a given data set. Now that you have a basic idea about this named entity recognition of a given data set, now let's go ahead and perform this activity of named entity recognition in a hands-on manner. So in order to do that, I'll go back to my Google Colab. So this is a code which implements the named entity recognition using the Spacey library. So here, first thing that I'm going to do is I'm going to import the necessary libraries, and once it is loaded, we'll load those language model. Then we'll apply the NLP on top of this doc, that is my document. And then to access the entities that has been recognized on this given text document, so we will access the label. So this label refers to the label that has been assigned for the given text token. So this is the overall working of named entity recognition for a given data set. Okay, so apart from this, in order to apply the named entity recognition for a given data set, there are various other libraries that are available, which were available in the past, but the community has not seen much updates on the same. There is a library that's called as CRF Suite. You can check out this CRF suite, but the problem with this library, that is CRF suite, is we don't have the latest release over here. So this library do not work with the latest version of scikit-learn. So if someone, let's suppose if you're a researcher, you can definitely check out this library and get an intuitive behind what exactly is happening when we are implementing this CRF suite in a hands-on manner with the help of Python programming language by referring the various APIs that are created by the developers. Alright team, so with this we come to the end of this video. As you progress in your upcoming video journey, you're going to learn how to build a chatbot with the help of a service that is provided by Google that's called as Dialogflow. So I'll see you next time. Hey everyone, welcome back to your learning journey in this natural language processing. In this video, we are going to understand about the chatbot. So as we progress in this video, we will understand what exactly is this chatbot and the advantages of chatbot. And I'll also speak the history of the chatbot and the applications of chatbot. So that's the learning journey that we are going to have in this video. So let's get started. Let's start by understanding what exactly is this chatbot. Now, if I want to describe this chatbot, the interactive system, and this will allow the users to interact in natural language, which means here I'll be conversing with the chatbot in the language that we speak to my fellow human being, not a programming language. And here this overall journey and the revolution, it started in the year of 2016. So around that time we have actually seen the first wave of chatbots, so which soon became very popular and we started seeing everywhere. Now some of the examples that we have come across for the chatbot would include the Facebook Messenger, Google Assistant, Amazon Alexa, Apple Siri. So these are some of the examples of chatbot. And apart from these, so we have actually seen the rise of various tools and technologies which will actually help us to create our own chatbot. And one such tool that we have got is the RASA framework, which we'll be learning as part of this course learning journey. Now, this introduction of chatbot has actually brought a lot of changes into our society. First best thing is I can say this has created an era as a conversational interface. It's a beginning of new era in the technology itself. Here with this chatbot, we don't require a screen or we don't require a mouse in order to interact with this chatbot. Now just take an Alexa as an example. Now if you want to make Alexa do something, then you'll not be using any mobile screen or a touch, or you'll not be using any physical device. So you're going to make use of natural language and converse with the Alexa. Now, as a result of this, your voice is what will be used in order to do a conversation. Now, as a result of this, so you will be conversing with the chatbot in the same language which you will be interacting with your family and friends. And in the backend, it uses the text. Yes, it uses the text in the backend in order to understand our natural language, and that is one of the applications of natural language processing. Now that you have understood the what exactly is this chatbot and the advantages of this chatbot, let's have a look into the brief history of the chatbot. So the history of chatbots and the artificial intelligence in general are pretty intertwined, I could say. So in the year of 1950 and 60, during that time, the computer scientist Alan Turing and Joseph, so they contemplated the concept of computers communicating just like we humans do. Now, that's how it started. And later in the year of 1966, so Joseph, so he actually built something, a very first chatbot that's called as Eliza. So that's one of the very first chatbot that has been ever coded. And in order to code that chatbot, they have actually used just 200 lines of code. So just 200 lines of code were actually written for this chatbot of Eliza. Now, this Eliza imitated the language of Rogerian psychotherapist using the regular expression as well as some rules. Now, with this chatbot that is Eliza, so humans were actually interacting with this chatbot, and humans who are actually interacting with this computer program at that time, so even though they knew that they are interacting with the computer program, but through the emotional responses which Eliza that was actually giving to the users, so the users over the period of time they started growing emotionally attached to it. So that's one of the important thing that they have observed with that very first chatbot when they have created in the year of 1966. Now later, with the advent of powerful signal processing tools, so researchers what they started doing is they started focusing on building the spoken dialogue tools with the goal of improving the overall user interface. So many spoken dialogue systems were actually built between the year of 1980 and 2000s, and basically at that time it started as a military based project by DARPA. So they just started implementing it. So over the period of time, so the main focus that is between 1980 to 2000s, so their main focus in improving the automated communication with the soldiers. So these systems were actually used to provide instructions which later translated into chatbot. So as a result of this, so with this ideology, so it started turning into chatbot, which is capable of handling the users frequently asked questions for variety of services. And the bots were still handcrafted such that these responses, which were actually getting generated, they were actually fixed. And in the recent period, the chatbots became much more feasible, and even it has improved a lot thanks to the development in smartphone and the development in the machine learning and the deep learning domain. Now along with that, we also have seen the ability to, with the help of API, so to create the chatbot and connect it to the various messaging platform. So that's one of the key logic behind having the messenger based chatbot in Facebook or any such tools that you see out there. So the overall idea is when we talk about the chatbot, so here the conversation between the user and the computer will happen through the natural language and not through programming language. Now with this, we've got a variety of applications in chatbot. So we see the usage of chatbot in shopping and e-commerce domain. So here in the scenario of e-commerce, the chatbot is used for creating the order or modifying the order or helping the users in placing the order. So those are some of the applications in shopping and e-commerce domain. And coming to news and content delivery, so it can be used in news and content delivery as well as the discovery to the users. Here it's used in computer service, medical domain, legal operation. So these are some of the most commonly used applications of chatbot. All right, so with this, we come to the end of this video. Now, as we progress in the next video, we will see how we can create a very simple chatbot Now, this chatbot is a FAQ based chatbot. So, you will learn the intuition and the hands-on implementation of the same in the next video. So, I'll see you next time. Hey everyone, welcome back to your learning journey in this natural language processing. Now, in this video, we are going to learn how to build a simple FAQ chatbot. So, we will look into the steps to build a chatbot and what exactly it would mean by simple FAQ chatbot. So, let's get started. Now, when we talk about this simple FAQ chatbot, an FAQ chatbot is generally a search-based system where, given an input question, it looks for the correct answers and then it is going to provide the correct answer to the user. So it's essentially a bot which will allow a user to ask the question in various ways so that the user can get a correct response. Now, these bots are quite useful for providing the conversational interface to a complex set of questions. Now, as part of our learning journey, we'll take up an example that example chatbot that's called as a chatbot for AWS services. Here, I've got a pair of question and the answer. So the questions are about the AWS services and the relevant answers for the same. If you look into this example here, I've got a question that says as what is Amazon Elastic Compute Cloud? Then on the answer side, I have the answer for this question. So like this, I've got various questions and the respective answers next to it. Now when the user inputs an equation, I have to find okay to which question that my given input is actually nearest to. Now once I find it, then I'm going to get the relevant answer on the basis of the question that is found in the database. So the overall goal for this machine is to learn to provide the correct answer given a similar question. So that's the key thing when we talk about building a FAQ based chatbot. Now, while building any chatbot, there are some common steps that we follow. These are all some of the general steps which we follow in the production system as well. Starting with, while building the chatbot, we have to first define a goal. We'll start by finding the various use cases where the chatbot would work the most in solving the user's query, and then we will think about the product and we will see what are those use cases which can fit in where we can actually use the chatbot as an application. And the second step is personality and tonality. Once the goal is defined, you'll have to work on the personality and the tonality of the bot. So the tonality of the chatbot defines how the chatbot would respond to an end user. And the step 3 is creating a task flow. Here, you'll create a task flow and list out the specific tasks that my users can perform with the chatbot. And then you will convert the task flow to a chart. So generally it is recommended that you start by creating a script. Then the step 4 is about testing, that is start doing the interaction with the bot. Now once the bot is built, you will start interacting with the bot to identify where exactly the chat flow is actually breaking. Now once that is done, you'll go ahead and review the quality of the chatbot, and then you will start adding the casual talk to the chatbot so that it can sound more human. So these are the common steps that we follow whenever we are building a chatbot. Now that you have a basic idea about what exactly is a chatbot, in the next video, let's go ahead and build a FAQ chatbot in a hands-on manner. So I'll see you next time. In this video, we are going to learn how to build a simple FAQ bot in a hands-on manner. So as we proceed in this video, we'll look into the high level look into the implementation, and then we'll go ahead and we'll get started with the coding. So let's have a look into the implementation steps. Now, when we talk about this implementation steps for building this chatbot, first we are going to load the data set. Now, once we load the data set, we'll check for null values to see if we have any missing values in our data set. Then, once we have taken care of the missing values, we will then go ahead and perform the text processing. Now, this step is nothing but building the vocabulary and creating the data transformation. And once that is done, we are going to create a chatbot. And once the chatbot creation is complete, we are going to test the chatbot. It's a very simple activity, and yet it's powerful, and it is capable of providing some of the amazing results, provided that we have applied the data and provided we have the data which is quality in nature. So let's have a look into building this chatbot. So I'll start by initializing my Firefox, that is Google Colab interface. Now I'll start by importing the data set. Now the data set that we are going to use is from the GitHub repository. So I have already uploaded to my GitHub repository. I'll just go ahead and load the data from this GitHub repository. You can download the same data set by just clicking on this link or copy pasting the link in the browser. And once you copy paste the link in the browser, just like right click on this browser page and say as save page as, and now here you can save the page as file name and specify the format as text file and save the file, and in this way you can download the data set in your local system. Okay, so I'll just use this Linux command. This is going to download the dataset from the GitHub repository to my Google Colab file interface. You can clearly observe that I have already downloaded this file over here for me. Now, once I have downloaded the file, we will get started and we will read this file. See, in order to read this file, I'm going to make use of pandas library. And apart from pandas library, in this example, I'll be making use of TF-IDF vectorization. So that's a technique where I'll be using it to transform my text data into a numerical format. So from say sklearn.feature underscore extraction, I'm going to import TF-IDF vectorizer. Okay, next from sklearn.metrics, I'm going to import the cosine similarity. Okay, so this will go ahead and apply the formula of cosine similarity. Now the reason this cosine similarity is important, because whenever I get the input from the user for that given input, I'm going to create the TF-IDF vectorizer format. That is, I'll transform this data, then I'll convert and I'll use this vector representation of my given data and compare it with the vector representation of my existing question bank. Whichever is the question which is nearest to the input question, that's the question which is most similar question that have got in my given database. So that's the core idea over here. Along with that, I'm going to import my NumPy library as well. Now once it is imported, we'll just load this data as a data frame. So read underscore CSV AWS FAQ.csv, and then I'm going to display first few entries of this data frame. So this is how the first few entries of this data frame would look like. Now let's check whether we have any missing values in this data frame or not. Now in order to check the same, I'm going to call the info method. So clearly we've got some missing values in the column of the answer. There are just only 650 word rows for the answer column. And when we talk about the question column, we've got 670 rows. So let's apply df.isNull function to confirm the same. Here I'm going to apply this function, and this will return how many number of missing values that we have got on this data frame. Now once that is done, so what we are going to do is we are going to simply go ahead and drop those rows where we have got the missing values. So df.drop in place is equal to true. Now once that is done, let's revalidate it. So we can observe that now we do not have any missing values. Now that's great. Now the activity that I'm going to do right now is I'm going to initialize my TF-IDF vectorizer. Okay. Now once I initialize this TF-IDF vectorizer, the next thing that I'll be doing right now is it's very important, and I want you to observe very carefully. For getting the vector representation of my data set, I'll go ahead and concatenate my question and the answer, and on top of that I'm going to apply the TF-IDF vectorizer. Now there's a reason behind this. The reason that I'm doing this activity, because By doing it in this way, I'll be able to learn all the features that is present in the given input data, because there are some keywords which will be present as part of my answer, which may not be present as part of my question. Now, in order to ensure that I'm learning those features in an effective manner, I want to have my vocabulary which contains all the unique words which are present in my question as well as my answer. So I'm going to say vectorizer.fit. Here I'll say np.concatenate, and I'll be concatenating my df question as well as df answer. Okay, I'll perform the concatenation and I'll perform the fit. Now once this is done, we will go ahead and get the feature names. So if I want to get the feature names that I've got right here, I'll say dot get feature names out. Next, if I display this feature columns, so this is the feature columns that I've got. Now let's do one thing. Let me just go ahead and display its length. We'll get to know how many number of unique words that I've got in this vocabulary. So as we can clearly see, we've got 3421 words in this vocabulary. Now, in order to generate the vector representation of my given data set, I'll say df vector vec.transform, and I'll perform the transformation on the question. Okay, now what I'm going to do is, this is a chatbot where it will get an input from the user. I'm going to mention something like this. Hello, welcome to Manifold AI Learning chatbot. This is a simple bot which can answer the question. Now in the next line, I'm going to say, ask me anything related to AWS. Okay, so this is the print statement that I'm going to specify, and I'll add a while. Okay, I'll say while true. Okay, and I'm going to mention like this. I'll say input question is equal to, I'm going to say just input. Okay, I'll get an input from the user. Now whatever the input that I'll get from the user, so I'm going to check something. Okay, I'll say input underscore question is equal to stop. Okay, I'll say if input is equal to stop, I'm going to set it as break. Okay, so this is something as, since there is a while loop that is going on, if I get the input as stop from the user, I'm going to break this while loop, else it will keep on continuing. Next, I'm going to say input question vector representation is equal to vector representation dot transform, and here inside the parenthesis I'm going to specify my input question. So this will perform the transformation on my given input data. Next, similarity is equal to 1 my cosine similarity. Okay, and inside the parenthesis I'm going to mention my input question underscore vec, that's my vector representation of my input function, input question, as well as my df vectors. Okay, once I find the cosine similarity between them, I'm going to mention something like this. I'll say closest answer is equal to np dot argmax, and here I'm going to get the similarity comma axis is equal to 1. So I'll take the argmax with the axis is equal to 1. Then I'm going to mention something like this. So I'll say response from chatbot is, and I'm going to say df answer dot ilog. I'll say closest answer dot value, and I'll get this value like this. So this is going to get me a text data. All right, so let's go ahead and test this. So once I execute the same, it says, hello, welcome to Manifold AI Learning Chatbot. This is a simple bot which can answer the question, ask me anything related to AWS. I'll say, tell me about S3. Okay, so let me just fix it. Now it should work. I'll say, tell me about S3. It says response from the chatbot is cloud watch metrics, CPU utilization, and it is actually giving me the information about the chatbot. Okay, that's what it says. It is thinking about the, so I believe this is definitely not a right one. Maybe we'll have to improvise the question, or maybe we would require more data or more questions related to S3. Now I'm going to write something like this. I'll say, what is Elastic Search Service, and I'll press the enter key. It says a search instance is a single search engine in the cloud, and it is just working as per we would specify right here. Okay, next I'll say something like this. How can I get started with, like, say, with Amazon EC2? So it says to sign up for Amazon EC2, sign up for this web service, and it is giving me the answer, something like this. Now this is looking promising. So I'll say, do I run systems in Amazon EC2 environment? I'll just mention some questions. It says, okay, so it is actually saying how will I actually run the same. Now at the end of it, I can press as stop, and this is going to come out of this while loop. So what we have done right now is, as part of this video, we have simply implemented an FAQ chatbot. Now, as you have clearly observed, with the right amount of question and answer pace that I've got in the data set and the current amount of augmentation on the questions, we can actually build a powerful chatbot with this very simple process. All right, team. So with this, we come to the end of this video. Now, as we progress in the next video, we will learn the various types of chatbot. So I'll see you next time. Welcome back to your learning journey. Now in this video, let's learn about the types of chatbot and how we can have a pipeline to build a chatbot. Now when we talk about this chatbot, so we can classify the chatbots onto various types depending on its usage and how they actually interact with the user. The first type of chatbot that you have seen already is called as an FAQ chatbot. Now these chatbots are actually linked to a fixed set of responses, and they retrieve a correct response on the basis of understanding my user's question. For example, if I have built a chatbot which has been built around the Amazon FAQ on the services, then at that time, depending on the user's question, I'm going to generate the response which we have seen in the previous hands-on learning implementation. So here, the response from the user, okay, the response from the user is not going to have any more impact than the response that we get from the other user, which means the response that I give to my users is not specific to users. It is specific to the keywords that is being used in a given sentence. Now that's the core principle behind this FAQ based chatbot. Okay, so apart from this FAQ based chatbot, we have got the another type of chatbot which is called as the flow based bot. Now this flow based conversational bot are generally more complex than the FAQ based bots. Here, the user can gradually express their opinions or requests over the course of conversation. For example, when a user is ordering a cloth, so he's going to say that whether he's going to look for t-shirt or jeans. Now, based on the response, we can get the size of the t-shirt or the size of the jeans. Now, if it is the t-shirt, then we have set the flow whether the t-shirt size will be small, medium, large. And based on that, we can get the input from the user whether it will be a short sleeve or a full sleeve, or whether the neck type will be a polo type, round type, or a v-neck type, or do you have any specific brand in mind. So you can clearly observe that the user can actually express their opinion or the request over the course of conversation. So in all these scenarios, the bot should understand and track this information throughout the conversation to successfully generate a response every time. So the diagram over here is an example for the apparels chatbot. Okay. Next, the other type of chatbot that you would generally come across is an open-ended chatbot. Now, the open-ended chatbot are only intended mainly for the entertainment purpose. Here, the bot is supposed to converse with the user about the various topics. Now, the bot doesn't have to maintain the specific direction or the flows of the conversation. Now, in this example that you see right now, so this is an example where it says that good to know, the user says, and the bot is saying that I'm glad you found that bit of information interesting. What are your hobby? Then the response here says my hobby is chatting online. What are your goals? I plan to spread myself throughout the net. So you can clearly observe, okay, so the bot doesn't have to maintain any specific direction. So this is another kind of chatbot. Now that you have understood the various types of chatbot, now let's understand the general pipeline for building a dialogue system. Now, when we talk about the NLP task, that is the natural language processing task, so here when we have talked about it, we have talked about the various tasks like classification and the entity detection. Now, let's use those same and let's try to understand how we can build a dialogue system. Now, this is a pipeline for a dialogue system. We have got a speech recognition unit, and this speech recognition unit is connected to natural language understanding unit. And then we have got the text to speech synthesis, which is connected to natural language generation unit. And both of these are connected to a dialogue manager, and the dialogue manager is in turn is connected to a task manager. So I want to highlight one thing. The connection between dialogue manager to NLG, that is the natural language generation, is like this, and NLG to text to speech synthesis is like this. This is how the connection should look like for building the pipeline for dialogue system. Now that you have seen the pipeline of the dialogue system at a very high level, let's look into the three important elements that we see right here. That is speech recognition, NLU, NLG. So let's understand what are these components. Here, when we talk about this speech recognition unit, so speech recognition is like an interface between the human and the machine. So this dialogue system normally works as an interface between the humans and the machine. So the input into my dialogue system is actually my human speech, and the speech recognition algorithm transcribe the speech of the human being into a natural text. Okay, so in a general scenario, when we are building any dialogue based chatbot, we are going to have an industry standard or the state of the art modules which will be present, which will convert my speech module into a text data. Then we have got the NLU module. Now this NLU module is responsible for analyzing and understanding the transcribed text. Okay, that is the overall idea about this NLU. And we've got dialogue and task manager. The dialogue manager controls and guides the overall flow of conversation, and the task manager performs the external action like calling an external API and so on. Now, once the output from the task manager and the dialogue manager is received, this will be sent for my NLG, that is natural language understanding component. Now, this component is going to get the output from the dialogue manager and generates the text output. Now, on this text output, we'll be using the text to speech synthesis module to convert the text data back into a voice format. So this is the overall flow for creation of dialogue system. Now, if I'm thinking about building a text-based chatbot, then you can ignore the speech module and the text-to-speech synthesis. The input will be the text and the output will also be a text. So that's how a text-based chatbot pipeline would look like. All right. So you have seen the important components of a pipeline for creation of dialogue system, and you have looked into the various types of chatbot in this video. Now, as you progress in the next video, let's learn some of the commonly used jargons when we are talking about the concept of chatbot. So I'll see you next time. Welcome back to your learning journey. Now with this video, let's learn some of the key terminologies that you would come across whenever you are building the chatbot. So let's get started. Now coming to the key terminologies, the first and the commonly used terminology when we are building the chatbot is the intent. Now here, the intent is nothing but it's an aim of a user command. Suppose if I have a text message which says as reserve a table at Radisson tonight. Now, what is the overall aim? What is the end goal that this user is trying to say in this given message? See, as you can clearly observe, the end goal at a very high level that the user is trying to achieve is the user is interested in reserving a table or he has to book a table. So that is what is happening right now. So an intent is nothing but at a high level goal. What is the high level goal that this user is actually trying to achieve? And that's what we call it as an intent. And another thing, whenever we are building a chatbot that we would come across is entity or a slot. So here, the entity or a slot is nothing but an important element in a given input text. Now, this important element holds the information regarding the specific entities which are related to the intent. Now, let me just give you an example and it will become very clear to you. Suppose if I've got a text message that says as reserve a table at Radisson tonight. Now, this is the input from the user. So the intent is the user wants to book a table. Now, what he wants to book, I mean, where he has to book. So he wants to book at Radisson. And when he has to book, that is tonight. So here, in this example, the entities are place, that is Radisson, and time, that is tonight. So whenever the user provides an input, the chatbot has to understand what is the overall intent of this given text. And along with identifying the intent, it is going to check what are the important elements that it has to remember so that it can process the next command in an easier manner. So that's the relationship between this intent and the entity. And the another terminology which you would come across is the action. Now here action describes the activity or the operation that has to be performed by the bot by understanding the entity and the previous intent. And here action would mean it would integrate with other APIs, or sometimes it is going to query and save the data to a database. So these are all the examples of action. Suppose if the user provides the input as book a table at Radisson tonight. Here, by getting this information from the user, the chatbot is going to call the booking service or a reservation service in the backend with the information that it has received from the user. So in calling the other service, which is a third-party service, or it could be an integrated service, it can make use of this API as a mode of communication and sends this information to this particular system. Okay, or let's say if I get any information from the user, then I'm going to save that information into my database. So here my chatbot is interacting with the other system, and that is generally called as an action. And the other thing that we would generally come across while building the chatbot is the stories. Now here the story defines the interaction between the user and the chatbot in terms of intent and the action. Now when the user says hello, the user is actually greeting the chatbot. Now the chatbot has to greet back that by saying it as hello, good morning, how can I help you? Now, what should be the response and how does this overall conversation flow would happen? So that is decided by the stories that we would create whenever we are creating the chatbot. So the intent is understanding the high level goal of the user, entities describes the important elements that we have to remember from the given input, and the action is nothing but calling the third party services or performing an action where the chatbot is going to perform a specific action on the basis of user's input, and the stories describe the overall flow or the conversation between the human and the chatbot. So these are the important terminologies that we would generally come across whenever we are creating the chatbot. Now that you have a preliminary and a basic understanding of the chatbot, let's proceed ahead in our learning journey and let's learn about the service in Google that's called as Dialogflow service in Google Cloud. So I'll see you in the next video. Now in this video, we are going to learn one of the most widely used service for creating the chatbot, that is Dialogflow. So as we proceed in this video, we will understand what exactly is this Dialogflow and the reasons behind choosing this Dialogflow. So let's get started. Now here, when we talk about this Dialogflow, the Dialogflow is a Google service and this operates on a Google Cloud platform. And the best part is this Dialogflow is an intuitive and a user-friendly tool which includes the Google's machine learning expertise along with the Google products like the Google speech to text, which will help us in building an amazing chatbot. And this Dialogflow is an NLP platform, which is nothing but the natural language processing platform, and we can use it to develop an application related to the conversation and the experience for the customers of the company in various languages on a variety of platforms. So it is mainly known as the Dialogflow as a service, which will help us to have a lifelike conversational artificial intelligence with state-of-the-art virtual agents. And this Dialogflow is actually available in two editions. The first edition is Dialogflow ES, which is a standard version, and the another edition is called as Dialogflow CX, which is an advanced edition. Now this is mainly used to build the actions for most of the Google Assistant devices. So now that you have the overall idea about what exactly is this Dialogflow and the various edition, so let's proceed ahead and let's see what are the key features of this Dialogflow which makes it an go-to tool whenever we are building a chatbot. Here, one of the main feature of this Dialogflow is it will help us to develop the serverless apps in a quick and an easier manner. So here, whenever we are working with Dialogflow, there is a unified code editor which is actually provided by Google Dialogflow team. So using that, we can easily develop the natively serverless application which are connected to our conversational interface via Firebase Cloud Function. And the another feature is deliver automated phone service. So with the help of this Dialogflow phone gateway, within the matter of minutes, we can actually add the dedicated phone number into our Dialogflow agent, and the user who calls that agent with the new phone number will contact our Dialogflow agent directly. And this phone gateway is based on the cost invested by Google in various things such as speech recognition, phone connectivity, speech synthesis, NLP, and so on. And the another great feature about this Dialogflow is designed for voice first world. So with the help of a single API request, yes, with the help of this single API request, we'll be able to extend our conversational interface to identify the voice communication and produce even the voice reply as well. And the best part is this Dialogflow supports synchronous modes as well as the real-time streaming, which are actually powered by Google Cloud text to speech and Cloud text to speech services. And we can also rely on automatic spelling correction. So whenever we are working in the chat environment, most of the users will interact in a hurry, and sometimes there can be situations where the users do not emphasize on the accurate spelling or grammar whenever we are working with the chatbot. So in such scenarios, there is an important feature which is provided by Dialogflow, which is known as automatic spelling correction. And this will help to automatically correct the spelling mistakes with the help of the technology which is actually used by Google search. How cool, isn't it, guys? And the another feature that we have got in this Dialogflow is improving the experience with built-in analytics. So in this Dialogflow, the integrated analytics dashboard will actually help us with a vision for conversational communication. Now with this, we can customize the bot to have a better understanding and reply to the user's intentions. And the another cool feature that we have got in Dialogflow is ability to understand the user sentiment. So for the query of each user, the Dialogflow, it is going to perform the sentiment analysis which is powered by Cloud NLP. So the score of the sentiment analysis can be used to distribute the unfulfilled users to the live agents or to gain well knowledge about which it attempts lead to the highest client satisfaction. So in other words, you are able to understand what the users are feeling so that you can have a better connectivity with the users that you're working with. And the best part when it comes to usage of this chatbot in real life is its ability to deploy across multiple platforms. It supports more than 20 languages and 14 different platforms, and the team is continuously working to increase the number of platforms where we can actually deploy this Dialogflow. And the best part is we can bring our enterprise knowledge whenever we are creating the chatbot. So with the help of this Dialogflow, the knowledge connectors that we have got in this Dialogflow service, so we can easily augment the data in bulk from the enterprise to the agent, and this would contain the articles based on the knowledge and the FAQs. Now to extract the correct answer from the data corpus, the knowledge connectors of the Dialogflow use those technologies which are used by Google Assistant and the Google Search and help us to build a chatbot in a much better way in answering some of the cool and the easier questions from the user, and which is specifically for that enterprise. And last but not the least, this Dialogflow is powered by Google Machine Learning. So in Dialogflow, the understanding of natural language, that is identification of the intent of the user, extracting those entities, and understanding some of the important parts in those entities, by default, it is actually run by the machine learning models. So as a result of this, by simply providing a very small data set, we can train the agent to easily recognize the customer entity types in a better way. These are some of the main features of Dialogflow, which makes it a number one choice whenever we are trying to create a chatbot. Now, this Dialogflow has got variety of use cases. So it can be used in commerce domain, it can be used in enterprise productivity, IoT devices, and customer service. So we can use it in commerce domain, like in business. So you can actually, like with the help of the Dialogflow at any time, transactions can be made possible with the help of the users on any platform which the user would prefer. Maybe you can have the transactions to keep on going by getting the data from WhatsApp, which the users would prefer to. So you can purchase the goods and you can provide the updates on the platform which the users like. And you can increase the enterprise productivity, and you can also use it in the IoT devices as well. And with the help of this conversational interface, we can actually make our IoT devices much smarter. So this is going to add an intelligent layer to the smart devices, and it will allow the devices to understand and respond precisely to the context of the user's interaction. And lastly, customer service, which is a well-known use case of the chatbot. So we can create the conversational interface, which we using this, we are able to perform the various tasks such as scheduling the appointment, replying to the general queries, following up on the previous orders, and so on. So these are some of the use cases of using the Dialogflow in the real life. Now, by using this Dialogflow, we could gain an amazing set of advantages that comes along with it. One is a sentiment analysis. So as I mentioned earlier, the Dialogflow can perform the sentiment analysis for the queries of the user, And by understanding the sentiment, that is what users is feeling, your chatbot can help you to reach a better client satisfaction. And it's user friendly, so you're going to observe as we progress in the learning journey as well how friendly it is to the users whenever we want to build a chatbot with the help of this Dialogflow service from Google. And this has got an integrated code editor, and this Dialogflow incorporates the Google's feature. So it includes the various features of Google like speech to text and the machine learning. And the another advantage is swift and more efficient coding. So here, by creating a very simplified coding process, the overall Dialogflow helps us to save the time of the developers. Now, the developers can efficiently perform all the tasks related to the coding because the system contains the built-in inline code editor. Now, using this, the agents can be linked via cloud functions or on-premise to their given application. And this can express itself via natural conversation. So what it means is, with the help of the Dialogflow, we can create a chatbot, and the chatbots can make the conversation in a most natural possible manner. It simply means that although the customers will be speaking to a program, but here, when it is understanding the user, that is from the user's text, it is able to obtain the in context replies. And here, whenever you are communicating with a chatbot, you will actually not feel like that you're actually speaking to a robot or a application. You would feel like you are speaking to an actual human being. And last but not the least, this is powered by amazing team of Google's research on machine learning. So the machine learning technology which is used by Google is used in Dialogflow as well, and this has increased the capabilities of the Dialogflow. Now, the reason that we would prefer to work with Dialogflow is one is because of all the advantages that I mentioned earlier, and apart from that, this supports multi-channel integration. So with the single click, we can actually integrate the some of the most widely used platforms like Twitter, Skype, Kik, Viber, Facebook Messenger, Telegram, Slack, Twilio, and you can also use it for various voice assistants like Cortana, Alexa, Google Assistant. So it has got multi-channel integration. And coming to the price, so the free version of Dialogflow is also available in case if you want to try out, and the pricing is, I would say, it's little competitive in this given domain. And the another one reason that we want to choose Dialogflow is its ability to understand the human language, that is, it uses the NLP, natural language processing. So as a result of this, the users will get an amazing experience. Okay, so these are the reasons that we prefer to work with Dialogflow. So with this, we come to the end of this video. In the next video, let's learn about the basics of Dialogflow. So I'll see you next time. In this video, let's look into the basics of Dialogflow. Now here, when we talk about this Dialogflow, so Dialogflow is a service which will help us to create the chatbot. Now, when we talk about this Dialogflow, the reason that it became quite popular and the reason it is being used right now is, if you look into the traditional computer interface, that is the general interface that we have got, this traditional computer interface requires a structured and a predictable input in order to work in a required manner. That means the computer program expects the input in a certain manner, and as a user, we have to provide the input so that it can generate an output. So it will get an input, it will process it, and it will generate the output. Now, the question is, can your end user provide the input in a structured manner? Just think about it. So all the end users will not be aware of the programming language. Do you agree with me? Yes, isn't it? So not everyone will be aware of computer programming language. When they are not aware of computer programming language, how can we expect them to send the data in a structured manner? Now let me just give you a very simple example. Suppose if I've got a user request which says as book a table at Radisson tonight. So this is the request which is being sent by a user. Book a table at Radisson tonight. So this is the input that has been sent by the user. Now along with that, let's say we've got another user who simply says that book table Radisson. And another user will say book a reservation at Radisson for today. See, you can clearly observe that all the inputs would mean the same thing. All the inputs would mean that the user is interested in creating a reservation or booking a table at Radisson tonight. Now, these simple questions or these simple queries are easily understood by a human being, but when you think about it from the computer perspective, it's very difficult to implement. Here, we should be able to process these kinds of input, which is the text which is in the natural language, and we have to interpret it so that we will be able to understand what exactly is being conveyed, which means we would require a very robust language parser, and that is where the Dialogflow comes into picture. Now with this Dialogflow, it will help us to provide a high quality conversational end user experience. And in this Dialogflow, there are various components. So one important component that we have got is an agent. Now here, a Dialogflow agent is actually a virtual agent, and this is capable of handling the concurrent conversations with the end users. And the best part is it is a NLU module, that means natural language understanding module, which is capable of understanding the nuances of a human language. And here, this Dialogflow can translate the end user text or audio during a conversation to a structured data so that my application and the services can easily understand about what exactly my users are actually conveying to me. Now, along with that, we also have the ability to design and build a Dialogflow agent to handle the types of conversations which are required for our own capability and for our own system. And you can think of this Dialogflow agent is very similar to a human call center agent. Now, just like you will train a human call center agent to be able to understand the end user's input and the end user's request, in the same way, the Dialogflow agent can be trained. So you can actually train them, and you can actually train them with a set of most frequently occurring conversation scenarios. And just like we train the human call center agent at a very high level, even we are required to train the Dialogflow agent at a very high level. We don't have to be overly explicit. So this is about the Dialogflow agent. Moving on, we've got something called as an intents. An intent categorizes an end user's intention for one of the conversation turn. Now, whenever we are creating the agent, for each agent, we can actually define many intent where your combined intents can handle a complete conversation. Now, whenever end user writes or says something, now this is actually referred to as an end user expression. Now, this Dialogflow matches the end user expression to the best intent in your agent. For example, here, let's say the user says as what is the weather today or what is the forecast. Then in that scenario, the Dialogflow would match the end user expression to the forecast intent. And here, matching the intent is also known as intent classification. Okay, so this is an example that we have got right here. See, we've got an user expression which says as what is the forecast. And when this user expression is sent for my Dialogflow agent is classifying this user expression as, okay, this user expression belongs to the intent of forecast intent. So this is known as intent classification. Okay, so we've got the user expression, and this user expression goes to my agent, and this agent is going to classify the user expression to the given classes, that is the given intents. And this is known as intent classification, which is one of the important and a basic activity that my agent would perform. And along with classifying the intent, my agent is also going to extract the useful information from the given user information. For example, it is going to extract the information like time and location. So these are all called as an entities. So Dialogflow agent converts my user's expression into the forecast. That means it will classify it to the intents, and along with that it will extract the entities. It gets the user expression, performs the intent classification as well as entity extraction. Now whenever we are working and creating this chatbot using the Dialogflow, we'll be creating the intent. Now, while creating the intent, the basic intent contains the training phrases, action, parameters, and the responses. Here, the training phrases refers to the example phrases of what my end users might say. Now, when an end user expression resembles one of these phrases, the Dialogflow matches the intent. Now remember, as I mentioned earlier, this is the training phrases. We don't have to be overly explicit. That means we don't have to define every possible example, because whenever we are working with the Dialogflow's built-in machine learning expands on our list with other similar phrases. Okay, so that is the overall idea about this training phrases. And next we have got an action. So we can actually define an action for each intent. Whenever a specific intent is matched, then the Dialogflow provides the action to the system, and you can use the action to trigger certain actions or certain events which are defined in your system. And there is something called as parameters. So here, parameters is nothing but when an intent is matched at runtime, the Dialogflow provides the extracted values from the end user expression as parameters. And each parameter has a type, and we call it as an entity type. We call it as an entity type, and this dictates how exactly the data is extracted. Now, whenever we are working, so it will be a raw user text or the raw end user input. Now, here, when we say raw end user input, it's an unstructured in nature. So what we'll be doing is we'll be performing the entity extraction. So as a result, I can say that these parameters are the structured data which we can use it and we can use it to perform some logic, or we can also generate the responses as well. And lastly, we have got the responses. So responses is nothing but here we are going to define the text, speech, or visual responses so that we can return to the end user. And here these responses are very important because this is something which user gets as an output for the input that he has mentioned. So here in the responses, it can be direct answer, or we can ask for more information from the user, or it can be a terminating the entire conversation itself. So this diagram that you see right here, this diagram describes the basic flow for intent matching as well as giving the response to the user. Here we've got the agent. So the agent receives the end user expression, which is a raw text. And on the basis of the end user expression, we will perform the intent classification. And for training the each intent, we will have the training phrases, action and parameters, and the response. So based on the training phrases, so the intent has been learned, and on the basis of actions and parameters that we have defined, so we are going to trigger the action and we are going to perform the entity extraction with the help of these parameters. And once that is done, so we are going to perform the next activity of generating the response to the end user, which will be triggering to the end user. So this is what an every intent is made up of. Okay, now moving on here, each and every intent, as I mentioned earlier, so each and every intent has a type that is called as an entity type, and this would dictate how the data from the end user expression is actually extracted. Now, while working with Dialogflow provides a predefined system entities which can match any common types of data. For example, there are system entities for matching the dates, there are system entities for matching the color, email addresses, date, time, and so on. Now, not just these system entities, so we can also expand the entities by creating our own custom entities for our custom data set. For example, you can actually define a entity as a programming language which can match any types of programming language for the given user input, or you can define a fruit entity that can match the types of fruits which are available for purchase with a grocery store agent. So entities, these are called as the parameters which we extract from the given user raw input. So it can be system entities or the custom entities. Then we have got something called as a context. Now the Dialogflow context are very similar to our natural language context. For example, if a person says to you as they are orange, now here you need a context in order to understand what they is actually referring to. In the same way, here you can, like even when we are working with Dialogflow, in order to handle the end user expression like that, it needs to be provided with context in order to correctly match the intent. Now, using the context, we can control the overall flow of conversation. So you can configure the context for an intent by setting input and the output context, which are identified with the help of the string name. Now when a particular intent is matched, any configured output context for that intent becomes active. Now, any context which are active, the Dialogflow is more likely to match intents that are configured with the input context that correspond to the correctly active context. Now, to help you understand this, just observe the diagram. So this is the diagram which describes the context for a banking agent. So here, as a step one, the end user is going to ask for information about their checking account. So the end user is asking us, tell me about my checking account. So the Dialogflow matches this user expression into the checking info intent. And this intent has a checking output context. So it has got the checking output context so that this context becomes active. So as a result of this, the agent asks the end user for type of information that they want about their checking account. So the agent is asking us, what information do you need for your checking account? Now the end user responds by saying as my balance. Now the Dialogflow matches this end user's expression to the checking balance intent, and this intent has the checking input. This has got the checking input context which needs to be active in order to match this intent. Now, a saving balance intent may also exist for the matching the same end expression when a saving context is active. So that's the role of the context. Now here in this scenario, after the system performs the necessary database queries, the agent is now responding with the checking account balance. Now in this scenario, the Dialogflow is responding to the user as your balance is $1,000. So this is the role of a context. So the context will help the Dialogflow to handle the conversation in a much better way. Then there is something called as follow-up intents. Now, when we create the follow-up intent, an output context is automatically added to the parent intent, and an input context of the same name is added to the follow-up intent. Now, a follow-up intent is only matched when a parent intent is matched in the previous conversational turn. Now, in this way, you can actually create the multiple level of nested follow-up intents. Now, while working in Dialogflow, the Dialogflow provides many predefined follow-up intents for the common end-user replies like yes, no, or cancel. So you can also create your own follow-up intents to handle the custom replies. Okay, now moving on, while working with Dialogflow, so you'll be dealing with Dialogflow console. Now, this Dialogflow console is a web user interface which we generally use it as an end user. And we use it to create and build as well as testing the agents. Now, the Dialogflow console is different from the Google Cloud Platform console. So this Dialogflow console is used to manage the Dialogflow agents, while the GCP console is generally used to manage the GCP specific Dialogflow settings, for example, billing and others information for the GCP resources. Now, in majority of scenarios, so you will be using the Dialogflow console to build the agents, but you can also use the Dialogflow API to build the agents for advanced scenarios as well. Okay, so this is about the Dialogflow console. And here, while working, especially with the Dialogflow, we can also have an integration with other systems as well. So by default, whenever we are working with Dialogflow, the Dialogflow can generate a text response. Now, apart from generating the text response, the Dialogflow integrates with many popular conversation platforms like Google Assistant, Slack, and Facebook Messenger. Now, if you want to build an agent for one of these platforms, you should use one of the many integration options. So direct end user interactions are handled for us. So as a result, whenever we are building a chatbot, we just have to focus on building our agent. And each integration handles the end user interactions in a platform specific way. Here, in order to check which platforms are actually officially supported as of now, I highly recommend that you check out the official page of Dialogflow. Now, whenever we are working in order to fulfill these kinds of integration, here by default, the agent responds to a matched intent with a static response, which is a text response as I mentioned earlier. Now, let's suppose if you are using any interaction and if you are using any integration option, then in such scenarios, you can provide a more dynamic response with the help of fulfillment. Here, if you enable fulfillment for a given intent, the Dialogflow responds to that intent by calling a service which you actually define. For example, if an end user wants to schedule a haircut on a specific day, let's say on a Wednesday, your service can check the database and respond to the end user with the availability information for that specific day which the user has requested. And each intent has a setting to enable the fulfillment. If an intent requires some action by your system or the dynamic response, you have to enable the fulfillment for that specific intent. If an intent without fulfillment enabled is matched, then the Dialogflow uses the static response which you have defined for that intent. Now, when an intent with the fulfillment enabled is matched, then what happens is the Dialogflow sends a request to your webhook service with the information about the matched intent. And here, your system can perform any required action and respond Dialogflow with the information as how it has to proceed. And it will become clear to you when I explain with an example. Now, when this fulfillment is enabled, the static response which you have defined for that intent is only used if the webhook service fails.
Now just observe this diagram so that you will understand the overall processing flow of fulfillment. Now here the end user types or he's going to speak an expression. So it can be a type or it can be voice. So it can be anything. It can be through the telephone. Okay. The end user provides the user expression. Now here the Dialogflow matches the end user expression to an intent which extracts the parameter. Okay. So this is very similar to entity extraction and the intent classification. Now this Dialogflow sends a webhook request message to the webhook service. And this message contains the information about the matched intent, action, parameter, and the response defined for the intent. So intent matching and the webhook request. Now this service, that is the third party service or the integration service that you are calling, the service performs the actions as per our requirement like the database query or external API call. And this service is going to send a webhook response message to the Dialogflow. And this message contains the response that should be sent to the end user. Now, as per the configuration that we have set, the Dialogflow sends the response to the end user. And the end user sees or hearing the response depending on the interface that he or she is connected with. So this is the overall idea about the fulfillment. So here, this is the general way of fulfillment for the integration with the help of the action. Now, let's say if you're working with the system where we do not have an integration with the Dialogflow, that is, if the inbuilt integrations are not available, then at that time, one thing that you have to change is you have to write the code which directly interacts with the end user. So you must directly interact with the Dialogflow's API for each conversational turn to send the user input or the user expression and receive the intent from that specific third-party service. Okay, so it will be almost same. So you just have to ensure that your service is capable of interacting with the application. So this is about the basics of Dialogflow. Now that you are aware of the basics of Dialogflow, let's set up the Dialogflow project. So I'll see you in the next video.
In this video, we will look into the introduction to Google Cloud Platform and how we can set up the Dialogflow, which is a service provided inside this Google Cloud Platform. So as we progress in this video, we'll have an introduction to GCP and we will set up the Dialogflow so that it is ready for us to get started. Now, first and foremost, in order to understand this Google Cloud Platform, you need to understand about this cloud computing. Now, the reason that we are going through all these things because these are some of the prerequisites that are required so that you can progress in your learning journey and you can implement this Dialogflow in a hands-on manner. So in order to implement this Dialogflow, you need to have a Google Cloud account with billing enabled, and you can also make use of trial account as well and ensure that you have got the you clearly check out the prices and the requirement whenever you're building it at an hands-on manner at the production grade, because prices majorly makes a huge difference whenever you are working. All right, so with that being said, so let's get started and let's start by understanding what exactly is this cloud computing and why is it actually required. Now, if I want to talk about the cloud computing is the on-demand delivery of compute power, database storage, application, and other IT resources through a cloud service platform via the internet with a pay-as-you-go model. Now here what happens is it's the use of remote servers on the internet in order to store, manage and process the data rather than using a local server or on your personal computer. So this is the entire idea about this cloud computing. Here, when we talk about this cloud computing, let's first understand what we were actually doing in the pre-cloud era. Before this cloud computing came into picture, what we were actually doing. Let's take up a scenario. The scenario is I'm a business owner and I want to host a website. So this is a requirement as a business owner. Now, whenever, as a business owner, whenever I want to host a website or whenever I want to host an application, so there's a lot of things that I have to handle. So first and foremost, I have to purchase the server. So I have to first purchase the server. That's and the most important critical aspect. So I'll have to purchase the server. Once I purchase the server, I'll have to install it physically, and then I have to then maintain those server. So all these things I have to do it by myself. That means as a business owner, it was my responsibility to take care of the infrastructure along with the every cost that comes along with purchasing the server, maintaining the server and all those things. So here, managing the server is done by the business user and installing it is done by the business user. Maintaining those server is being done by the business owner. So all these things were being done by the business owner manually and he was responsible for all these things. Now let's say as a business owner, you have developed an application and currently the application server is able to handle 1000 requests per minute. Now let's assume that your company is doing well. Now you started receiving 2000 requests per minute. Now, in this scenario, when you're getting 2000 requests per minute, the current server is not able to serve those additional requests that is coming along. So what is happening in this scenario is the server is not able to give you a optimized experience which you would expect for the users. So this is the key challenge that you see right now. Now, if you want to expand this, if you want to ensure that you are able to process 2000 requests per minute, so what you have to do, again, you have to purchase the additional server and then you have to physically integrate these two servers, you have to install it, and then there will be a downtime because you have to connect both the servers and then you have to manually maintain those additional servers as well. So what is happening in this scenario is each time whenever you are releasing any product, so at that time it is increasing the cost. And as you can clearly see, when the request starts receiving 10,000 requests per minute, then in that scenario, you have to think about where you are going to set up this data center. Because in the current area, this much server might not fit when you are processing the 10,000 requests per minute. So you are going to have the scalability issue. And the other issue is maintenance and the upgrades and most importantly database security. So all these are the issues that we faced in the pre-cloud era. So the inability to scale the databases, cost optimization, incapable to scale and managing the server, and the issue with producing the fault tolerant devices. So these were some of the key challenges that we had faced in pre-cloud era. Now, what happened was an era came into picture that we generally call it as a cloud era or the post-cloud era. Now, in the post-cloud era, so all these things that I'm talking about, so all these things will be owned by a third-party vendor, and this third-party vendor is somewhere on the globe. So when it comes to the maintenance and usage, it is very similar as what you will do in the scenario of your telephone bill. See, when you talk about telephone or getting a new mobile, you'll not worry about fixing the towers around the world. So what you're going to do is you're just going to insert a SIM card, and once you insert the SIM card, you're going to subscribe to a plan. At the end of the month, you will be billed on the basis of your usage. So you'll not worry about setting up the complex server, having the technology. You'll not worry about anything. You'll just take a connection and at the end of the month, you will be paying basis of your usage. Do you agree with me? Yes. Now that's the same principle behind this cloud era. Here it goes on pay as you go model. So on the basis of your usage, you will be paying. And that's the best part in this cloud computing. So here with this cloud, it has taken care of a lot of things. One is it has taken care of data security. And the another advantage that we have got with cloud era is dynamically scalable server, and it has given us the faster computation and the remote access to the devices. And the best part is flexible pricing, ensuring high cost optimization. So these are some of the key advantages that we have got in the cloud era. Now here, when we talk about this cloud computing, now coming back to our slide, see, this cloud computing is the same thing. That's what I'm trying to say here. It's a on-demand delivery of compute power. What is compute power? It could be the computers or the servers that you would require, or it could be the database storage. When I say database storage, it could be an ability to store the data for your business, and or it could be the application that is running on the cloud, which you can access through the internet. And apart from that, you can also get multiple other IT resources which is required for you, so that you can have your application exposed to the entire world. And here, this works on pay as you go pricing. So here, what we'll be doing is we'll be using the remote server, which will be owned by third party. And what you will be doing is you'll be renting those servers, and on those servers, you will be storing, managing the data, and you will also process the data on those servers through the internet instead of working on the local system. Now, when I talk about vendors, there are multiple vendors that we have got right now who provides this cloud computing ability. We've got DigitalOcean, we've got VMware, we've got Microsoft Azure, we've got AWS, we've got Google Cloud Platform. So these are the various platforms who are currently available right now who provides the cloud computing ability for the business. Now, out of all these cloud computing providers, in this section, we'll be focusing on Google Cloud Platform because, as I mentioned earlier, the Dialogflow service which we are going to use, it's part of the offering from the Google Cloud Platform. So let's understand what exactly is this Google Cloud Platform. See, this Google Cloud Platform is a suite of cloud computing services which runs on the same infrastructure which Google uses internally for its end user amazing products like Google Search, Gmail, Google Photos, and the YouTube. So the state of the art applications that we use it on a day-to-day basis, the servers which is powering those state of the art application, that's the same kind of servers which will be having an access. So you can get to know the maturity of the servers that you will be using when you're accessing anything from the Google Cloud Platform. And here, when we talk about this Google Cloud Platform, it provides amazing set of features. To name a few, it provides the cost-effective pricing because this is the one which leaves all the competition behind, because Google Cloud Platform has highly flexible pricing and it is rightly a leader when it comes to the pricing. And it provides the highly scalable solutions. So while working with GCP, we can scale up or scale down as per our requirement with extreme ease of use. Now, to give you a perspective of highly scalable, what exactly it would mean is, let's say you've got a server which is capable of serving 1000 requests per minute. Now, let's assume you are being charged as $10 per hour for this server, which is capable of serving 1000 requests per minute. Now, you would observe that your real-time usage is actually 100 requests per minute. So what you will do is you're going to downgrade. Yes, you're going to downscale your system so that you're going to subscribe to a server which is capable of responding 500 requests per minute. And the cost, maybe this will be around $4 per hour. So what you have done in this example is you have downscaled your system to match your user requirement, and you can do it with a matter of few clicks, and it will be live in a matter of minutes itself with zero downtime. And this works in the opposite scenario as well. Let's say you have got the server which is capable of 1000 requests per minute, On the weekend, you would observe that there is a huge traffic. So what you can do is only for the weekend, you will say that I need a server which is going to help me to solve what 10,000 requests per minute only on the weekend, and on the weekdays you'll still be able to keep the 1,000 requests per minute. So it gives the complete flexibility in the hands of the business and the user. And this is possible with the various machine types that are provided by the Google. So with the custom machine type, we can create the machine type customized as per our requirement. And if you just focus and if you're aware of your custom requirement, there's also discount implications up to 50% is available when we are working with these custom machines, and it provides amazing integration. So it has various APIs, and we can actually practice the Internet of Things, including the cloud artificial intelligence as well. And with this Google Cloud Platform, we can use BigQuery and the big data analytics to carry out the amazing set of analytical practices with an extreme ease of use. And it also has the ability of serverless. Now, this serverless is actually a new paradigm of computing where this will help us to abstract away the complexity which are associated with managing the server for mobile and API backend. So what we can do is we can actually provide the application what it has to do. Now, this Google Cloud itself, it will take care of the servers, all those things. It will do the scaling up and scaling down. Everything will be managed by the Google Cloud itself. So this is called as a serverless service. So as you can clearly see, because of all these features, we generally prefer to work with cloud environment vendors. That is the vendor in this example, that is Google Cloud Platform. So this Google Cloud Platform, you can think of it as a collection of cloud services which are offered by Google. And here it provides the host of wide range of services, and these wide range of services include the compute service, storage service, and the application development service. So when I say compute service, so we've got Google Compute Engine, which helps us to deliver the virtual machine which runs on Google's innovative data centers with worldwide fiber network. And the best part is it will help us to scale from single instances to the global multiple instances as part of our requirement, and we can also have a load balanced cloud computing implemented with extreme ease of use. And it provides the App Engine, which is a platform as a service which will help us to access the Google's scalable hosting. And it also provides the cloud storage, which is an ability to store large unstructured data set, including it also provides the database services as well. And we've got the networking service which will help us to build our own networking requirement as part of our enterprise requirement, like having the VPN and all those stuff. It will help us with the developer tools, management tools to manage the various Google Cloud services, and the data transfer, which will help us in the data migration from on-premise to the GCP, cloud AI, IoT, and it also has an amazing set of securities which can be enabled through identity and security services. Okay, so that's the best part about this Google Cloud Platform. And here, in order to get started with Dialogflow, you have to first have an account with Google Cloud Platform. So let me just show you as how you can create an account with Google Cloud Platform. So to access the Google Cloud, you have to go to the website cloud.google.com. Now here, through this page, you can just click on the button which says as Get Started for Free. And here it will ask you to enter the information, and it will ask you to set up your account. Now, once you set up your account, you'll be able to access every service that are present right there. All right, so that's how you can get started. And I hope that you are going to complete this activity. And once that is done, then you can get started with Dialogflow. So here, when we talk about the Dialogflow, the version that we'll be using in our learning journey is the standard version, or which is also known as Essentials version. So let me just take you to the Dialogflow official documentation page. So this is the official page of Dialogflow. So here, when we talk about this Dialogflow, there are actually two products. One is Dialogflow Essentials and the another edition is called as Enterprise Edition. Okay, so in our learning journey, we'll be using the Dialogflow ES. So once you set up your account, you can just press this button which says as Go to Console, and this will take you directly to the Dialogflow Essentials console, which is what we'll be using whenever we are creating the chatbot in our learning journey. So this Dialogflow Essentials is also part of your free trial that you would get with Google Cloud. So you can actually access it and start creating the chatbot. All right, team. So I want you to set up your account, and with this, we come to the end of this video. So as part of a learning journey in this video, you have looked into the introduction to Google Cloud Platform and the importance of Google Cloud Platform and how you can access the Dialogflow Essentials. Now, as we proceed in our learning journey, in the next video, we will see how we can create a chatbot using the Dialogflow. So I'll see you next time. Now that you are aware of the basics of Dialogflow and created an account with Google Cloud Platform, now in this video, let's go ahead and create our very first chatbot using the Dialogflow. So as we proceed in this video, we will see how we can create an intent and how easy it is to create an intent, how we can create the entities, and at the end we'll also test our chatbot. So this is an end-to-end video where you will see the complete flow of creating the intent, entities, and testing the chatbot as well. So let's get started. So we'll do this in an hands-on manner. In order to do this in an hands-on manner, I'll go to my web page, that is dialogflow.google.com. So this is the page of this Dialogflow Essentials. Now by default, this is the view that you're going to get, and this is called as a Google Cloud Console or the Dialogflow console. Now this Dialogflow console is what you will be spending most of your time. So there's another console that's called as Google Cloud Console. Now that Google Cloud Console has a very limited use. You will only visit there only if you want to set up your project for the first time and you want to enable the billing. And for most of the time, you will be spending your time with the Dialogflow Essentials console itself. Okay. Now here on the left hand side on the sidebar, so currently it has selected an agent. Okay. So currently it has selected an agent. The agent is get started agent. So that's the get started agent. That is the default agent that has been created right now. Okay. Now along with this, yes, along with this, we also have the intents, entities, knowledge, fulfillment, and the integration. So these are the various options that we have got right now. Now here you can click on these various options in order to manage and build the various elements of a given agent. For example, if you click on intents, okay, you're going to see the list of intents for the selected agent in the middle panel. So in this middle panel, we've got the intents like default fallback intent, default welcome intent, get agent name, set language. So these are the default intents that are available right now for this get started agent. Okay, and here in the middle, so this is the main content area. So this panel actually shows the data and the editing controls for the option selected on the sidebar menu. For example, if you have selected the intents, you can see the editable list of intents that are available right now. Now if I click on entities, it will display the set of entities that we have got available right now. And on the right hand side, this is called as a simulator, also known as Dialogflow simulator. So once you have created your agent, you can have a conversation with your agent by speaking or by typing the messages in this Dialogflow simulator. So this is very useful tool whenever we have built our chatbot and we want to test our agent whether it is working as per the expectation. Okay, so now that you are aware of this basics of this Dialogflow console, so let's go ahead and let's start building a chatbot. Okay, so what I'm going to do right now is I'll just go ahead and import the agent. So in order to import an agent, so what we have to do is I'll just go over here on the settings. Okay, this will take me to the settings page of that particular agent, and here we've got an option called export and import. I'll click on this and I'm going to select the option that says as import from zip. Okay, I'll just select this option that says as import from zip, or we can also use this option which says as restore from zip. So when we say restore from zip, what it does is it is going to replace the current agent version with the new one, and when I say import from zip, it is going to upload new intents and the entities without deleting the current ones. So for the ease of working, I would recommend that you'll use the option called restore from zip. So here you have to upload the file which I have shared with you in the LMS along this video. So I'll click on restore from zip and I'm going to mention that attachment. So the zip file is learnagent.zip. So I'm going to drag and drop that file over here. So this is going to restore from this zip file. Okay, so currently it is getting uploaded. We'll wait for a while, and once that is done, we'll click on this restore button so that this is going to restore the chatbot. To confirm, we'll have to say it as restore over here and click on this button that says as restore. So now I've got a message that says as agent import successful. That's great. So we have imported the agent. Now I'll click on the intents. Now once I click on the intent, okay, so here, as you are aware, these intents are nothing but the categorization of the end user's intention for a specific conversation turn. Now for each agent, we can actually define as many intents as per our requirement. Okay, we can actually define many intents where the combined intents can actually handle the overall conversation between the agent and the end user. Now, whenever we create an agent, so two default intents will be created for us. One is a default welcome intent and the other intent is called as default fallback intent. So the default welcome intent is this intent is matched when the end user begins a conversation with the agent. Now this intent should return a response that lets the end user to know that what your agent can do and what they can actually perform the activity in order to start interacting with the agent or the given chatbot. And we've got the default fallback intent. Now this intent is matched when an agent cannot match the end user input to any of the other intents that we have listed. Okay, so in this example, we've got default fallback intent and default welcome intent. Now what I'll do is I'll just click on this button that says as default fallback intent. And if I press this button of default fallback intents, so here it says the text response. The text responses here says, I didn't get that. Can you say it again? Sorry, what was that? So here we have mentioned some of the example fallback intents. Okay, so when the system is unable to classify it, it will generate a response that is one of the response from these text responses that we have configured for this default fallback intent. Now to test this, I'll just mention as what is your hobby? And I'll press the enter key. Now once I press the enter key, here I've got a response. The response is saying as what was that? And the intent that has been identified is the default fallback intent. So here the reason that we have got this response because the agent was not able to classify our given user's input. And that was the reason that we have received one of the default replies from this default fallback intent. Okay, that is the general idea about this default fallback intent. Now I'll press this intents again and we'll say it as default welcome intent. Now here the event is welcome. So when a user says something similar to a training phrase, the Dialogflow matches it to the intent. So here I have created some training phrases. So the training phrases is nothing but the examples what my user would give. Now to give you a demonstration, here I'll write it as hello and I'll press the enter key. Once I press the enter key, this hello user input will be matched with this default welcome intent, and then it will generate the response from one of the response that I have mentioned right here. So I'll press the enter key. So once I press the enter key, here I've got a default response that says as hi, how are you doing, which is one of the response from this responses text. So what it has done is when a user mentioned as hello, this user input has been matched with the default welcome intent, and this default welcome intent has been matched on the basis of training, that is with the help of training phrases, and on that basis it has generated the response. So this is the high level idea about intents, user input and generation of response. Now that you have seen the high level idea, let's go ahead and let's create a new intent. So this time we'll create an intent, and this intent is able to answer the questions like what's your name. Okay, so that's what I'll be doing. Now in order to create a new intent, I'm going to click on this button which says as create intent. Now here, for each intent that we would create, we have to define many training phrases. So the training phrases is an example of what an user might type or say to our given agent, that is our conversational agent. Now this training phrase is also known as the end user expression. Now here, whenever you are creating an intent, it is recommended that you define as many training phrases that the Dialogflow can actually use with variety of expressions which should match an intent. So I have in the screen, so I'm actually going to create an intent. Now here, for the intent name, I'm going to mention as get agent name. That's the intent name that I'm going to create. And in the training phrases, see, if I click on this training phrases, so here under the training phrases we've got various options. One is action and parameters, the other one is training phrases. So I'll click on this add training phrases. Now for the add user expression, I'll mention as what is your name. Next I'll say, do you have a name? Tell me your name. Okay. May I know your name? So these are the user expressions or the examples that I'll be adding it for my training phrases. So like this, you can add as many training phrases as per your requirement. Generally, it is recommended that you mention at least 10 to 20 user expressions or the training phrases so that you will have a better intent matching. Okay, now once this training phrase has been matched, then I would expect my agent is going to generate a response. So in order to generate a response, I'll come under the responses section and I'll click this button that says as add response. Here I'm going to specify the text response. So for the text response section, I'll write it as my name is Dialogflow. Nice to meet you. Okay, so this is one response. Next I'll write it as I am Flow. So these are the two text responses that I would mention. So what happens is whenever I specify something, that means whenever a user mentions an input and if that input is matching any of these training phrases, then this intent get agent name will get activated. And once that is activated, the next thing that it is going to do is while generating the response, it's going to generate one of the text responses that I have mentioned inside this response section. Now, once we have created this, I'll click on the save button. This is going to automatically train my agent. Okay,
So currently it says intent has been saved. So once the intent has been saved, next let's go ahead and let's test our intent. So if I click on my intents again, see, we have got an intent that says as get agent name. That's what we have it right now. Now what I'll do is we'll go ahead and test the intent. I'll say, what is your name? So here, when I mention the input as what is your name, this time the intent that has been identified is get agent name. So when I mention an expression, the agent has identified that expression to the given intent, and from the given intent, it has generated a response. So you can clearly observe that here I have mentioned as what is your name, and if you look into the training example, so I have clearly mentioned as what is your name. Now let's do one thing. I'll write it as like this. What's your name? See, I've mentioned the user expression which is different than what I have mentioned in the training phrases, but still it is able to match to the correct intent. Now this is possible because of the machine learning model which is being used in the back end by the Dialogflow. So whenever I provide any input for this Dialogflow, the model is going to check the expression against every intent that we have defined for the agent, and then for each and every intent it's going to give a score. The highest score the agent that it is going to have, so that's the highest scoring intent is the one which the highest scoring intent is the one that will be the resulting output for us. Okay, that intent will be selected and the respective response will be generated from the intent. So this is the role of creation of intents. Now whenever an intent is matched at the runtime, we can also extract the values from the end user expression as parameters. Now each parameter has a type, and this type is also known as the entity type, which I have mentioned at the earlier parts of the section. Now this entity type describes and dictates exactly how my data will be extracted. So here, whenever we extract any input from the user expression, it will be in a structured data format. And this we can use it to perform some logic or even for generating the responses as well. Now, whenever we are building an agent, we can actually control how data is extracted by annotating the parts of the training phrases and configuring the associated parameters. So let's see how we can create the parameters. Now, in order to do that, this time we'll create a new intent with parameters so that you will understand how we can describe the training phrases. So I'll click on create intent. Next, here I'll set the intent name as set language. Okay, this is the intent name that I have mentioned. Now here I'm going to add some training phrases. I'll write it like this. I'll write as I know English, I know French, I know German, I am aware of Chinese. So if you look into this scenario, see, for each and every user expression that I have mentioned, for each and every user expression that I have mentioned, the system has identified the parameter and its respective type. So it has identified that this word Chinese belongs to the inbuilt entity, that is the system entity of sys.language. And if I select this French, it says it's the parameter name, it is set as language, and the entity is sys.language. So the same thing is for English as well. Now if you look into the scenario of German, German has been identified as sys.person. So that is how the system has identified it. Now if you are not happy with the how it has actually happened, so what we can do is we can just select on the text, and this time I'll say sys.language instead of sys.person. So in this way we can map the word for the given entity and the relevant type. Now let's say if you have other words which you want to map it to the entity, what you can do is you can just double click on the word and you can assign the various entities that are available, and at the rate sys dot whatever that you assign, these are all the inbuilt entities. If you want, you can also create your own custom entity as well. Okay, so for now we have automatically identified the entities from the given data, and currently we are using the system entities. Okay, so we have actually identified the system entities. So what happens is whenever we mention any user expression, the Dialogflow automatically detects the parameters in the training phrases which are recognized as the system entities. Now, if I want to give you some more information about this system entities, this is the official documentation page of the system entities. See, the Dialogflow provides many system entities to extract the common types. For example, sys.color type can be used for extracting the values like red, blue, and so on. So you can actually get the complete list of system entities by referring to the system entity reference. Currently, we have actually looked into the scenario of language. So let's go to that specifically. See, at the rate sys.language, it is referring to the language names. So you can check out the various system entities that are supported by the Dialogflow. Okay, so it clearly says for most of the application, the values provided by the system entities would work well. However, if you're creating an application and if you would require any additional values for the system entities, for example, if you want to add blue green to the list of values for sys.color, so you can also extend the existing available system entities, and you can also create your own custom entities as well. And it clearly says how we can specify the entities whenever we are working. Okay, so we can actually create those entities from the parameters. So this is the general idea. For now, what we'll be doing is we'll be using the system entities, and then we will see as we proceed in our learning journey. Now, let's do one thing. So let's go ahead and continue with this creation. So we have created the user expressions, and after that, here once we have specified the user expression, so next thing that we'll be doing is we are going to create the action and parameters. See, here we've got action and parameters. Now here you see something called as required. Now this checkbox is not checked. So what it means is this parameter is an optional parameter. Next, we have got the parameter name. So the parameter name is automatically named as language in this example because the parameter is recognized as a language. And entity is nothing but the entity type. Now this has been recognized as sys.language, which is a system entity. And the value. So here the value has been identified as $language. So this is the identifier which we have to use whenever we are referencing this particular value of the parameter. And there is a checkbox called list, is list. So the checkbox is not checked. So the parameter is not actually a list. Now what I'll do is whenever I extract any system.language, that is system entity of language, I want to use it while creating the response, that is whenever we are generating the response. So this time I'm going to add the responses. So under the responses section, I'm going to mention the text response like this. That's great that you are, that you knew $language. Okay, and the next one, I'll write it like this. Wow, you know language very well. So these are the two text responses that I would mention right now. So
I'll click on save. So this intent has been saved. Now let's go ahead and test it whether it would work or not. So I'll write it like this: I know Russian. So when I press the enter key, so observe very closely. So here I have mentioned the user text as I know Russian. But this Russian was not part of my training phrases. Even though it was not part of my training phrase, it was able to extract this entity, that is sys.language, and it was able to use it whenever it is generating the response. So I've got the response that says as, wow, you know Russian very well. And the parameter that has been identified is language, and the value that has been assigned for that parameter is Russian. So in this way, we can create our own parameter and reference it whenever we are generating the response. So for this example, we have made use of the inbuilt system entities. Now, if required, as I mentioned, we can also create our own custom entities as well. So what I'm going to do is I'm going to add some more entities. So this time I'll write it like this. See, on the left hand side, we have something called as entities. I'll click on the entities. So if I click on this entities, currently it says as there are no entities yet. So I'll click on this option that says as create the first one, or I click on this button that says as create entity. Now here it is asking me about the entity name. So for the entity name, I'm going to write it as programming language. Okay, that's the entity name that I would specify. Next, I'm going to add the following entries like this. So I'll write it as JavaScript. Okay, and I'll remove this inbuilt value, whatever it was present, and I'll ensure that define synonyms is selected, and I'll write it as JavaScript, JS, ECMAScript. Okay, then okay, let me just separate it. So this is how I have defined the entries for the JavaScript. I'll proceed ahead and I'll add further rows as well. For the reference value, I'll mention as Java, and I'll keep the synonym as Java. Similarly, Python, and I'll mention as Py along with Python. Okay, so in this way, I'll be adding the entity rows. Now, once this is done, so I'll click on the save button. So this is going to save the entity that we have created. Now what we will do is we'll just go ahead and use this new entity. So what I'll do is I'll go back to my intents, that is the set language intent. Now here we'll add further training phrases. So I'll write it like this: I know Python. I know JavaScript. I know how to code in Python. Okay, so this is how I would create the entry. So I have added some training phrases. So when I have added these training phrases, so this time the entities was not actually by default detected. You can clearly observe. See, in my training phrases, the entities is not identified automatically. Okay, so in case if it is automatically annotated, it's well and fine. If not, what we can do is we can just go ahead and set the same. So I'll write it as @programming language, and I'll do the same thing for the other values as well. So it is the programming language. Python is an example for programming language. So in this way, I have identified and I have annotated each and every word in my user expression to the respective entities. Okay, now what I'll do is I'll add it in my response section, and I'll mention it something like this. I'll say See, to access the programming language, we'll say as dollar programming language is an amazing programming language. So that's a response that I would text. I would mention right now. I'll click on save. So once the saving is done, this time I'll just go ahead and test the new entity. So I'll write it like this. I'll say, I know how to code in Py. So here, when I mention as I know how to code in Py, I've got a response that says as Python is an amazing programming language, which means this Py has been able to identify that this belongs to the entity of Python, which is a value. Okay, and it has been used in my response. And Py is a Python programming language parameters value, that is Python. And this has been inserted into my response. So in this way, we can also create our own custom entities and use it as per our requirement. Okay. Now the next part that we'll be doing and which we'll be discussing right now is the context. Now, in order to control the flow of the conversation, we can actually make use of context. So when we are creating a chatbot, we can create a follow-up intent to provide a simple way to control the conversation without having to create and manage the context manually. So when you create a follow-up intent, an output context is actually added to the parent intent and an input context of the same name is added to the child intent. So this would mean that the follow-up intent is matched only when the parent intent is matched in the previous conversational turn. Now what I'll be doing is I'll click on the intents, and in the intents page under this set language, I'll click on this option that says as add follow-up intent. So we are adding a follow-up intent. The type of follow-up intent that I'll be adding is custom follow-up intent for this set language intent. So I'll click on this custom. Okay. Now once this is done, the next thing that I'll do is I'll click on this intent right now. So what I'll do is under this response section, okay, under this response section, I'll mention like this. Wow, I didn't know you knew this language. How long have you known this? Okay, so we'll mention like this. So here what I've added is I have accessed the language. Okay, I have accessed the language, and once I've accessed the language, and I'm just asking, okay, from how long that you know this. So what it means is if a user says that I know Russian, then I'm accessing that language. Okay, and I'm asking a follow-up question by asking as from how long that you know this language. So I'll click on the save button. So once I click on the save button and if I click on the intents, so if I expand the set language, see, you can clearly look into the follow-up intent right now. So there's a custom intent that we have created under this set language. We are working, this follow-up intent of the set language custom will only be matched after the parent intent has been matched. Since the set language custom intent is only matched after this set language intent, we can assume that the user has been asked the question as how long have you known this language? So let's do one thing. Let me modify this. Okay. So last time I have actually mentioned this text, right? I didn't knew about this language. So let me just remove that and I'll mention it and I'll ask this as a response over here. Okay, that's great that you knew this language. And I'll ask this question, how long have you known this language? So This time, instead of generating the simple response, I'm asking the question. Now, after I have asked that question, in the previous scenario, I've already added a follow-up intent right now. Now, what I'll do is, okay, so once this intent has been asked, that means once this question has been asked, the next intent will be matched automatically. So in order to do that, here I'll be extracting the information. Okay, so I'm going to add some training phrases, something like this, with the help of user expression. I'll write it as 3 years, about 4 days, for 5 years. So this is how I would mention some example. Okay, I'm going to mention the examples like this. Now, once that is done, okay, I'm going to generate some responses. So I'll generate the response something like this. Okay, I'm going to write it like this. So instead of date time, okay, so we'll specify it as duration itself. Okay, so what I'll do is I'll write it as, that's great that you knew this from, I'll access the duration. Okay, that will be my response. So I'll click on the save button. So let's go ahead and let's test this follow-up intent. Now what I'll do is I'll write as, I know French. So here it says, wow, you know French very well. How long have you known this French? Now I'll write it like this. I'll say about 2 weeks and I'll press the enter key. So when I press the enter key, here it says, that's great that you knew this from 2 weeks. So here, see, this is generating the response from the follow-up intent that I have mentioned right here. So this expression has matched with the follow-up intent, that is set language follow-up intent, that is the set language custom intent, and the context is set language follow-up. Okay, so this confirms that this output context is preferred and this is the one that has been selected. All right, so what we have done as part of this video is we have seen how to create an intent, how to define the entities, how we can define our custom entities, and also create a follow-up intent as well. So with this, we come to the end of this video. Now, as we progress in the next video, we will look into the concept of fulfillment using Dialogflow. So I'll see you next time. So in this video, let's look into the fulfillment using Dialogflow. So here you'll be understanding how to integrate your agent with the services using the fulfillment. Now by integrating the services, this will help you to take the action on the basis of end user expression and send in the dynamic responses back into the end user. Okay, now whenever we are working with fulfillment, now these fulfillments actually use cloud functions, and in order to work with these cloud functions you need to have a basic Node.js knowledge. Okay, if you want to create the fulfillment using your own server or another language, I would highly recommend you to check out the overall Dialogflow fulfillment documentation. All right, team. Now to get started and to have a quick background and start working on this, what I'll do is, this is the intent, this is the Dialogflow agent that we have been working. I'm using the first agent itself, that is the get started agent. I'll click on the settings. This time I'll just go ahead and restore from the zip file. So I'll just upload the zip file which is present along with the attachment for this video, that is learn agent fulfillment. I'll restore it. I'll mention it as restore over here. Click on the restore button. So this is going to perform the overwrite from the zip file. Now once that is done, I'll click on the done button. Okay, so this will help me to have the chatbot set up. So when I click on the intents, these are the intents that we have got. Okay, and we've got a custom entity and everything is present right here. Okay, so this is the overall scenario and this is what we have till now.
Okay, now in order to create an intent, so we have got an inline editor. So the Dialogflow console has a built-in editor which is called as a inline editor, which we can use it to create a fulfillment code and also deploy the code to the cloud function. Okay, if I click on this fulfillment, see we have got the inline editor, so we can enable or disable this. So previously it was disabled, now I have enabled it. So this is a place where you can create the fulfillment code and deploy the overall code to the cloud function. So the cloud functions has associated charges. So remember that the cloud function is a paid function, but this service is available for no charge up to a specific number of monthly invocation. So if it is very limited and if you're learning purpose, then you have a free limit. Ensure you check out the pricing from the Google Cloud platform page. Okay, now here in order to enable this inline editor, ensure that you have a valid billing account. Now, when you initially enable this inline editor, the Node.js fulfillment code is pre-populated with default headers for default intents, which are included for all the agents. And this code also has some commented details. See, you can also see some commented instructions for adding the handlers for developer defined intents. So this inline editor is intended for simple fulfillment testing and the prototyping. Now, once you're ready to build a production application, you actually have to create a webhook that is a recommendation from the Google platform. So here we have enabled the inline editor. Now, once that is done, once you have enabled it, so we can click on this button that says as deploy. So we'll have to wait for a minute until the deployment is completed. Okay. Now, if you look into the code right now, so they have defined some constant and they have mentioned some HTTP on request, and there is an agent, that is welcome agent, which says as agent.add welcome to my agent, and there's a fallback that has been added, and there's a function that says as get name handler agent, and it says my name is Dialogflow. So and here they have mentioned as language programming, and everything is written over here in the Node.js. Okay, now once that is done, okay, once that is done, what we will be doing is we'll be testing our fulfillment in the simulator. So currently it is deploying, so let's wait for a minute. So here, once the inline editor and the Google Cloud function has been deployed, we can also validate it as well. So here in this scenario, what we can do is we can click on this button that says as view execution logs in Google Cloud Console. Now this will help us to validate that this has actually created a cloud function, and you can monitor the logs, entire thing in this Google Cloud interface itself, that is the Google Cloud Platforms, Google Cloud Platform scenario. Now, if you want to go over there, you can search for Cloud Functions. Okay, and when you click on the Cloud Functions, so you can see that, see, this is the Dialogflow fulfillment code that we have written over there, and this has been deployed. See, the function is active, and this is on the Node.js 10 runtime. Okay, so this is how we can actually have the fulfillment service which is running, and that will help us to do the task as part of our chatbot requirement. Okay, so if I want to help you read the code how it is written, so here generally what we do is we'll create a function. Okay, so for each and every intent, if I want to assign a function, custom function, I can first create a function. Okay, this will take the input as an agent, and here under the intent map dot set we will actually link the intent with the respective function. Okay, this is how we generally write it. Okay, so we'll perform the intent map call, and once everything is done, we'll click on deploy. So this will be deployed as a Google Cloud function. So in this way, we can go ahead and create an entire chatbot.
So with this, we come to the end of this video. In the next video, so let's go ahead and let's look into the Dialogflow integration and the deployment. So I'll see you next time. In this video, let's look into the Dialogflow integrations and the deployment aspect. So here, when we talk about this Dialogflow chatbot, with the help of the integration, we can have the end user interaction handled by Dialogflow itself. So as a result, we just have to build the agent, the implementing the fulfillment as well as configuring the integration. So the rest everything will be taken care by the Dialogflow itself. So in order to get the complete understanding of the same, let's go ahead and get started with this Dialogflow. Now here, there's an option called integration. I'll click on this integrations on the left sidebar menu. And here, what we can do is we can actually enable the integration with various options that we have got. See, under the one-click telephony, these are the various options that we have got available. We've got text-based, and there are various integrations that are available by default. So we've got web demo, Slack, Telegram, Line. So these are the various integrations options that are available to us. For now, to give you a demonstration, I'll click on the web demo. So once I click on this web demo, here it is going to tell me as where exactly that I can access the bot. So I'll just click on that link. If I click on that link, see, I'm able to chat with this overall chatbot that we have created with the help of this interface, that is with the help of this URL itself. See, I can actually access it, and I can work, and I can generate, I can send in the input, and my chatbot is working as per my expectation. So this is a simple way of deploying a Dialogflow chatbot. You can also check out the other options as well. There is a Dialogflow messenger, and you can also have the messenger that is with a Facebook. You can also integrate it with Telegram. So here, there you can check out the documentation page. To give you an example, let's suppose if you're integrating with Telegram. So what you have to do is you have to set up the Telegram. So you have to have a Telegram account. Then you have to create a bot in Telegram. So you just have to go to this website telegram.me/botfather. There you will click on the start button in the web interface, or you just type as start, and then you'll specify the new bot, and you will mention the username for the bot, which is ending with bot. Then this is going to generate an access token just like that you see right here. Okay, now once you have got this access token, you just come to this Dialogflow setup screen, that is the screen, and paste that Telegram token that you have got in the previous screen. Then you just have to click on the start. Then what happens is during the testing, the bot father will provide you a link for your bot. Once you have completed the setup, you just have to go to that link in order to test your agent. Okay, so in this way you can integrate the bot on the Telegram. How cool is it? You just have to just use this integration that is available by default from Dialogflow, and the complexities are taken care by the Dialogflow itself. You just have to take care of building the chatbot, providing the training phrases, entities, and all those stuff. All right, you can also check out the various options that we have got, how to integrate it with Google Chat, how to integrate it with Google Assistant, Dialogflow. So you can actually check out the various options that are provided from the official documentation page. All right, team. So this was a short video on the integration part of this Dialogflow chatbot. So with this, we come to the end of this video. In the next video, we'll look into the miscellaneous concepts of Dialogflow and the components which will help us to make the chatbot much more productive and a useful one. So I'll see you in the next video. In this video, let's explore the other options that we have got in Dialogflow. See, when we are working with Dialogflow, there's a concept called knowledge base. We can define a knowledge base as a set of knowledge document that we actually offer to the Dialogflow. And the knowledge document comprises of the information which can be useful in the end user conversation. Now, there are few of the features of Dialogflow use the concept of knowledge bases when it is searching for end user response. So let's see how we can work with the same. Now in the Dialogflow console, so what you are going to do is ensure that you have selected an agent. Now once the agent has been selected, you have to click on something called as an knowledge. This is an option that we have got with us. Now here on the screen, okay, you can actually create a knowledge base. Here it says knowledge connector is a beta feature. Please enable beta features and APIs in the agent setting page first. So let's go to the agent setting page. So in the general settings page, ensure that you switch on the enable beta features and API. Now once that is done, click on the save. Okay, now you can come back to the knowledge page, and here we'll be able to access the knowledge feature, that is the knowledge base feature for the chatbot that we are working. Now here we'll click on create knowledge base. Okay, so once we click this button of create knowledge base, first we have to specify the knowledge base name. Okay, so for the example purpose, I'll mention as knowledge underscore base and I'll click on the save button. So I've created a new knowledge base. Next, what we'll be doing is we have to provide a knowledge document which will be used to auto-generate the chatbot of the FAQ. So what I'll be doing is I'll be using a sample FAQ for now for this demonstration purpose. So what I'll do is I'll click on the create first one. Okay, so this is where we can actually create our knowledge document. Now for the name over here, I'll mention the document name as FAQ Facebook. That's the example FAQ document that I'll mention right now. And for the knowledge type, it is actually an FAQ1. And for the MIME type, it is text/HTML. So here I have added the URL of the FAQ document. So this is the URL of Facebook message and platforms FAQ. Okay, so I've just copied this FAQ page over here and I have mentioned that URL over here. Now once everything is done, here we'll also select this button which says as enable automatic reload. So by enabling this auto reload, the Dialogflow, what it is going to do is it will automatically reload the document every day at that time picked up by the system. So this is currently available for a specific documents which is sourced from public URL. So I'll ensure that this is selected and I'll click on the create button. Okay, so this is going to create a knowledge document. Now when we are working with this knowledge document, so the knowledge document contains two essential points. One is managing, so the other one is the creation part. Now when it comes to the knowledge document, you have seen as how we can create a knowledge document. Now let's see how we can manage it. Now when it comes to managing, we've got updating the knowledge document, deleting the knowledge document, and as well as listing the knowledge document. Now let's say if you want to update a knowledge document content, then you cannot automatically refresh your knowledge document. You have to call the method which is called as reload on the document type in order to refresh the content on the public URI document or the cloud storage. Okay, now if you want to refresh upload raw content, so then in such scenarios, so upload raw content, I repeat, practical natural language processing. Now if you want to refresh upload raw content, rebuild your document using the methods delete and create on the document type. Now when it comes to deleting the knowledge documents, so if you want to delete the knowledge document, then you have to call the method named delete on the document, and that's going to delete the knowledge document. Okay, then when it comes to listing, so if you want to create a list of all the knowledge document, then on the document type you can use the API called the like method list. So you can use that method list in order to create the same. See, we have now uploaded the knowledge document, that is FAQ Facebook. We can click on view detail and see the entire thing over here. See, once I click on this, so we now have the ability to display our knowledge document. So we can see the questions that are parsed, which are into the request, as well as the answers as well. Okay, you also have the status that is mentioned as enabled. Okay, now if I want to enable automated responses, we have to click on add responses and we can just click on save. So that's how we can actually do it and work on the same. All right, team. So this is how we can create the knowledge document. Now, when it comes to training, currently the training is happening by default. Now, if I want to execute the training or do some any settings for the Dialogflow machine learning model, so what we can do is we'll just click on the settings button on the Dialogflow agent that we have created. Now here on this page, click on the ML settings tab. Here under the ML settings tab, so we can actually set the threshold value, and we can also enable or disable automatic spell correction. We can also enable and disable the automatic training, and we can also have the agent validation enablement or not. So in this way, we can do all our settings as per our requirement. So if you want to execute the training by using an API, then we have to call the method named train on the agent type. Okay. On the left hand side, there is something called as training. So this is also known as the training tool. So with the help of the training tool, we can improve the training data. Now this is used to review the conversation with the end users, which our agent actually had. So with the help of this training tool, we can do some things like we can import the conversation data from the real conversation which you had actually planned or recorded. And with the help of the training tool, we can analyze the real conversation and the intents that were matched for every conversation turn. We can also attach the expression of the end user from the conversation to the training phrases of the formally matched intents, fallback intent, or even different intents as well. Now, if you want to use the training tool, then it must be that the logging is enabled, because training tool uses the history of the agent data to load the conversation. Now, the training tool only displays the expressions of the end user. With the help of more complete agent history, we can actually view the conversation data of both agent as well as the end user. Now here, this is a page of training. Now currently you can look into the conversation list. So this is nothing but the list of conversation. So this list contains all the recent conversation but in a reverse chronological order. Now in the list, each row over here gives us the summary of the conversation. Okay, it just gives us the summary of the conversation. And if I click on any request that I have got, so here it says the user says what is your hobby, and then it is giving me an option as intent. So that means the intent was not matched. It is asking me to assign an intent. So I'll say default fallback intent. I'll click on approve. See, that is how we can actually do it. So we can review what exactly has happened. So in this scenario, when the user says what is your name, the agent's intent has been identified as get agent name. So we can either approve, we can add this phrase, or we can actually modify it as per our requirement. Now in this example, the Russian has been identified as is.language. Now if I want, I can actually change that intent to another one. If I feel like this is a wrong one, then I can say set language custom. So now this Russian has been identified as a custom intent, okay, or the custom entity. And once that is done, we have to click on the approve. So in this way, we can actually review each and every conversation that has happened between agent and the user and how the agent has interpreted. And if you feel like something is wrong, we can also modify over here. So apart from that, we have something called as small talk. So small talk is a tool that has been shared to us. So it says your agent can learn how to support small talk without any extra development. And by default, it will respond with predefined phrases. And yes, So we can enable or disable the small talk as part of our requirement. And we also have some pre-built agents. So these are the pre-built agent. Instead of building everything from scratch, maybe you can make use of the pre-built agent that will help your development process, and it will increase the speed in which you will be delivering your chatbot. So with this, we come to the end of a learning journey of creation of chatbot using the Dialogflow. As we proceed in the upcoming learning journey, we will look into the deep dive into the components of a dialogue system. So we have implemented the Dialogflow chatbot, and let's have a deep dive and let's look into the technical aspect, how everything is actually working, which will prepare you to build your own chatbot using the RASA module. So I'll see you next time. So in this video, let's deep dive into the components of a dialogue system. So as we proceed in this video, we will look into the components of a dialogue system. We'll see what exactly it is about NLU task, and then we'll also talk about the response generation. So let's get started. Now, in the last section, you have seen how we can build a chatbot using the Dialogflow surveys from the Google Cloud platform, and how to add the various features to handle the complex entities, that is the custom entities, as well as the context as well, whenever we are getting the input from the user. Now, let's deep dive into the machine learning aspect as how exactly the internals of the dialogue system is going to work. Now, when we have discussed about the pipeline for a dialogue system, so it's all about understanding the context in the light of conversation history is one of the key important tasks of a particular dialogue system. That means on the basis of user input, identifying what exactly the user is conveying, understanding that component is very important from a chatbot perspective. Now, when I'm understanding the context, this understanding of the context can be broken down into understanding the user's intent and detecting the corresponding entities, and post that determining the context and the action. So this is what a dialogue system is made up of. So first it has to understand the intent, it has to classify the intent, and then it has to detect the corresponding entities. It should be able to extract the important parameters or the important input from the user. Then, yes, then it will determine the context and the action. So this is what the internal components of a dialogue system is made up of. Now, to help you understand this, let's take a look at this example. So this is the example conversation that we have got. Now here in this scenario, the user is currently looking out for a restaurant reservation. Now you can clearly observe what exactly it would look like. Here the user says, I'm looking for cheaper restaurant. So here one thing that we have to extract is this cheaper, which is nothing but the price. So the price is equal to cheap. That is something that we have actually annotated for the machine learning model. Okay, and then the bot is generating the response as sure, what kind of and where. That means the user has provided some input for the chatbot. My chatbot has understood this input, and then it is generating a response. Now the user clearly says South Indian food somewhere downtown. Now when this chatbot is actually processing the current user expression, at that time it has to remember the context, that is the context in which the user is asking. So it has to remember the price as cheap, food is South Indian, and the area is center. Now on the basis of this, the chatbot is saying as the A to B serves cheap South Indian food. Now when the user says where is it, then at that time it has to remember all the previous data along with the current data, that is this. The bot has to check out the location of this restaurant, and then it has to generate a response that says as the A to B is at 108 Santa Street. So what has happened in this scenario is, here in this scenario, when the conversation is happening, each time whenever it gets the user expression, it will perform the classification of that user expression to a specific intent,
and then it extracts the important entities, and it also remembers the context through the follow-up intent. So this is how the chatbot is going to work whenever a conversation is happening between a user and a chatbot. Now here, when we are creating a chatbot, we basically have two natural language understanding tasks. And here, the two natural language understanding tasks are dialogue act classification and the identification of the task. So these are the two common NLU tasks that my chatbot will always perform. Now, once it performs this activity, that means once it performs the classification and then once it identifies the task, then it will move on to the next step, that is generation of the response. Now here, when I say dialogue act classification, this dialogue act classification is a task to identify how the user expression plays a role in the context of a dialogue. This informs what act which my user is actually performing. For example, a simple example of dialogue acts would be identifying an yes or no question. If the user asks, "Are you going to college today?" then this would be classified as a yes or no question. On the other hand, if the user asks us, "What is the depth of the water?" or "What is the depth of a river?" then in such scenarios, this is not an yes or no based question. So we have actually seen that intents or dialogue acts are very important whenever we are creating a chatbot. So identifying the intent, that is identifying what exactly the user is trying to perform, helps understand what the user is asking for and take the actions accordingly. So here you can think of this as a classification problem. And the another one is called as identifying the task, sometimes is also known as identifying the slots as well. Now once we have extracted the intent, we have to move on to extracting the entities. The extracting the entities is also important for generating the correct and the appropriate response to the user's input. And we have seen in our previous hands-on section as how extraction of entities plays a very important role along with classifying the intent. So here in the previous example, when the user gave the input as "I'm looking for a cheaper restaurant," so this cheaper, that is a price as cheaper, extraction of this was very important for us, and that was one of the driving factor to select the A to B restaurant at a final stage. So here, once we identify the slot and once we have decided what is the intent of the user's input, next comes is the response generation. When it comes to responses, there are three types of responses: fixed response, template based response, and automatic generation. So when I say fixed response, so for the fixed responses, you can think of it as an FAQ chatbot. So these FAQ chatbot is generally used for fixed responses. So based on the intent and the value for the slots, a dictionary lookup will be made on the pool of responses and retrieves the best response. Okay, so that's the overall idea about this fixed response. And when it comes to template based response, here in order to make the response more dynamic, we'll create a template, and the system, whenever it is generating the response, it will use that template and have that value filled over there with the help of the entities that has been extracted. And there's an advanced generation that is called as the automatic generation. Now this is based on data driven and the deep learning approach. So we'll obtain the dialog state, and based on this dialog state, a conditional generative model will be built which takes the dialog state as an input and generates the next response for the agent. So this will basically be deep learning based agents. So this is how a core concept of dialogue system is going to work. So it will have something which will identify the intent, extract the entities, and then we will build a way to generate a response. So these are the core components of a dialogue system. So with this, we come to the end of this video. As we progress in the next video, we will look into a NLU task, that is dialogue act classification. So I'll see you next time. Alright, as we proceed in this video, we will look into the intent prediction. So let's understand what exactly is this intent prediction.
and how we are going to approach this intent prediction, and whenever we are working, how do we actually train our machine learning model. So that's the agenda of this video. So let's get started. Now when we talk about the intent prediction, so intent prediction is a task where the NLU component is going to identify for a given user input what exactly is the intent. So this is basically a classification task. Now, to give you an example, there's a very famous data set for this intent classification that is known as ATIS data set. Now, this ATIS data set is also known as Airline Travel Information Systems data set, and this actually consists of audio recordings and the corresponding manual transcripts about the humans asking for flight information on automated airline travel inquiry system. Okay, now this overall data set consists of 17 unique intent categories, and the original split contains 4478, 500 and 893 intent labeled reference utterances in train, development and test set respectively. So in training data, we've got 4478 rows, and in development data, that is in the test data, you can say. So we've got 500 rows, or you can also say it as a validation data. And on the test data, we've got 893 rows. Okay, so this is a task of multi-class classification, and the total number of unique classes that we have got is 17. So as we proceed in a learning journey in the next video, we'll go ahead and perform this task of the dialogue intent classification, which is this NLU task for this ATIS data set. So I'll see you in the next video where we will implement it in a hands-on manner. See you next time. In this video, let's go ahead and implement the dialogue intent prediction in a hands-on manner. So as we proceed, we'll look into the deep learning based approach for intent classification. So let's get started. Now here, in order to do the hands-on coding, I'll get back my Google Colab. Here, the data set that we'll be using is the ATIS data set. So this ATIS data set, as I mentioned earlier, this data set is mainly used for intent classification. So it stands for Airline Travel Information System, which is a standard benchmark data set for the intent detection task. Now, the first thing that we'll be doing is we'll just download the data set so that we can get started with working. So I'll just execute this cell. So this is going to download the data set from my Google Drive. Now, in case if you want to access this data set while running locally, what you can do is just copy this link and paste it in the browser. And from there, you can download the files from this particular Google site. Okay, that's how you can get started. So here we have downloaded the data set, that is atis.zip. Now once I have downloaded the data set, we'll just perform the unzipping because currently it is in the format of zip format. So atis.zip, and then I'll remove that zip file. So once this is done, we'll get started with the general imports. So I'll start by importing the OS module. I'll import my NumPy library. I'll import the random module. I'll import pandas library, and we'll import the TensorFlow library because, as I mentioned, we'll be using a deep learning based approach. Since it's a text data, we have to find a way to convert the text data into a numerical format. Now, the strategy that we'll be applying is we'll perform the tokenization. We'll ensure that every row has the equal number of words, and then we'll just go ahead and pre-process the data set, and this time we are going to make use of the word embeddings. So we'll implement everything with the help of neural network format, that is with the TensorFlow. So I'm going to say from tensorflow.keras.preprocessing.text module, we'll import tokenizer. Then here from tensorflow.keras.preprocessing.sequence, I'm going to import paired sequences. So this is a function which will help me to prepare the data where every row will have the same number of data or the features. Now to convert the categorical data into a required format, we'll make use of two categorical function. So this will help me to generate the data with the help of one hot representation. So from TensorFlow dot keras dot utils, I'm going to import to categorical. Then we'll be making use of some layers. So from TensorFlow.yes, I'll be importing a dense layer, input layer, global max pool 1D layer. So along with that, we'll also make use of con 1D layer, max pooling 2D layer, embedding layer, as well as the LSTM layer. So these are the layers that I'm currently importing right now. And along with that, we'll import the model as sequential. So from TensorFlow dot keras dot models, I'll be importing the model and sequential. Then let's import some initializer in case if we are going to use it. So we'll see and we'll utilize it as per our requirement as we proceed. Okay. Now lastly, in order to convert the data into a numerical format, I'll also make use of label encoder. From sklearn.preprocessing, I'm going to import the label encoder. So I have done all the necessary imports in the same cell so that we can directly get started by loading the data set. Now in this data set, we've been given with three CSV file. One is 80s intents.csv file, okay, and there is 80s intents underscore test.csv and train.csv. So let's load the data set. So I'm going to write it like this. So train df is equal to pd.read underscore csv, and the file name is 80s intents underscore train.csv. Okay, now this data set do not have any heading, so I'll say header is equal to none. Next, we'll display first few entries of this data frame. So if I display first few entries, this is how the first few entries would look like. Okay, so we've got the respective labels and this is the text data. Now, what we will do is we'll add this information and we'll specify the column names. So I'll say traindf.columns is equal to, the column names are intents and the text. So this will help me to pre-process the data in a much better way. So the intents is this is my output column and this is the text data. And I'll repeat the same thing for the test data as well, okay, for performing the testing. So what I'll do is I'll write it like this. I'll just copy everything and I'll paste it over here. Instead of train underscore df, we would say test underscore df. And the file name is 80s intents test.csv. Okay, so we have read the test data as well. So there are two data frame, train data. Now once we have read the data and created as a variables, the next thing that I'll be doing right now is the pre-processing. So let's go ahead and perform the pre-processing on the data set. Now this time, when we are performing the pre-processing, there are a variety of ways to take care of it. So one standard procedure that we generally follow is we'll define the variables first and we will set those constant variables in a cell and we will refer it as and when we are writing the code. So I'm going to write it like this. I'll say max sequence length. I'll just set it as 300. Maximum number of words, I'll set it as 20,000, and I'll say embedding dimension is 100, and I'll also specify my validation split as 0.3. So this is a constant values that I would maintain. Now I'll start by initializing my tokenizer object. So tokenizer is equal to tokenizer, and this time the number of words is equal to maximum number of words that I have described earlier. Okay, this will be the length of the overall vocabulary. Next, once I've defined the length of my vocabulary, we will have to learn the vocabulary. So in order to learn the vocabulary, I'll make use of the method fit on text, and we will call our training data frame and specify the column of text. Okay, so we'll just specify this column of text and we'll perform the fit on text. Now once this is done, I'm going to mention my trained sequences. So I'm going to write it as tokenizer dot text to sequences, and here I'm going to mention my train df and I'll specify the column of text. So what this will do is this will convert my text into a vector format. Okay, so I'm converting my text into a vector format, and this is the vector of word indices. And I'll do the same thing for the test data as well. So test sequences is equal to tokenizer dot text underscore sequences. This time it is test underscore df. Okay, now once this is done, we'll also get the word index as well. So word index is equal to tokenizer dot word underscore index, and then let's print the total number of unique words. I'll say length of unique words or tokens, okay, is, so this is the length of my word index. Okay, so let's apply it on the data set. Now we can see that from this overall data set there are 871 tokens. That means there are 871 unique words in the given data set. Now let's go ahead and describe the train sequences. If I display first few entries of the train sequences, see, you can clearly observe that I have performed the tokenization and represented my individual words in the format of a integer. Okay, so that is how we have performed this activity. Now let's go ahead and display back our train df. If I display back our train df, so we have performed some pre-processing on the text data. Now the other pre-processing that we have to do is on the intents. So let's go ahead and display the unique words that I've got in the intents column. The unique words that I've got in this intent column is, it is abbreviation, aircraft, airfare, airline, flight time, ground service, and quantity. So 1 2 3 4 5 6 7 8. Now in this given data set, which is a short version of this data set, I believe we've been given with the data set which belongs to 8 unique classes. So we will have to first convert these string values into a numerical format. For that, we can make use of label encoder. Then we can actually apply the to categorical to convert that integer values into a format which can be processed by my TensorFlow, that is the one hot encoding. So I'll start by initializing my label encoder. I'll say le is equal. Next, we will see le.fit and apply it on train df, and I'll apply it on the intents because I'm processing the output column. Now once I perform the fit, next I'm going to store it in the column of intents itself, df intents, and I'll say le.transform and I'll apply it on my train df intents, and I'll repeat the same activity on the test data as well. So test df, I'll perform the transformation on the test data as well. Now let's just display the first few entries of this training data frame. If I display first few entries, we can clearly observe that the intents has been converted into a numerical format. So this is looking good. So we have done some pre-processing. That means we have applied the tokenization on this text data. Now, before we apply any machine learning model, or in this scenario, the deep learning model, we have to ensure that every row has same number of features. Now, since we are dealing with text data, what does it mean? Which means every sentence should have equal number of words. Obviously, that's not possible because each and every sentence is unique. So, in order to prepare the data where we can apply it on this deep learning model, we will perform the activity of paired sequences. So here, while performing this patch sequences, we will use the maximum length as 1000, which we have defined earlier. Okay, so in this example, it is 300. Okay, so we can define this maximum length as 300, and based on this 300 value, we can go ahead and implement this. Okay, so we can actually look into those values and see wherever we would perform. So that's how we would actually perform this activity. Now, if you do not know as what is the value that you have to use, okay, what we can generally do is after we perform the tokenization, we can look into the maximum value. Okay, we can apply the length of these training sequences and then get the maximum out of it. From there, we can actually get the maximum number of sequence length that we have got. So to tell you what I mean, see this train sequences, if I describe the type of it, this is of the type list. So each list is containing the individual sequences. So I'll perform the list comprehension and I'll write it like this. I'll say for L in train underscore sequences. Okay. I'll say len of L. Now on the resulting value, what I'll do is I'll apply the maximum function. See, the maximum sequence length that I have got in this given data set is just 46 on my training data. If I do the same thing on my test data, so the maximum length that we have got on the test data is 30. So that means having 300 will ensure that, okay, we are able to process the input which is of the length 300 words after I perform the tokenization. So it really makes sense. It puts us in a better place even when we are getting a new data which is greater than 300 words or greater than, in this example, 46 words. We'll be able to use our neural network and perform the activity. So that's the overall idea behind implementing this scenario of maximum number of words or the sequence length that we have got. So let's go ahead and implement this activity. I'll say train valid data is equal to pad sequences. Okay. Now here I'm going to mention my train sequences and then we'll specify the maximum length as max sequence length that we have described earlier. In the same way, we'll mention our test data. So I'll say test underscore data and I'll mention my test sequences. Maximum length is equal to max sequence length. Let's observe it. Yeah, this is the variable that we are using right now. Okay, now once we do this activity, this will take care of the features. So what I'll do is I'll say train valid labels is equal to categorical and I'll apply it on this column of intents. Okay, so I'll do the same thing on the test as well. Test labels, test underscore df. Okay, now here while applying the to categorical, we can also ensure that we have converted the data into the array and we can just mention the number of classes. Let's just execute it and then we will perform any other pre-processing as we would require at a later stage. Okay, so we have done this activity of like test label as well as string label. Okay, now let's go ahead and split the data set. So here what I'll be doing right now is, in order to split the data, I'll make use of train test split. So from sklearn dot pre-processing, I'm going to import train test split function. Here I'll write it like this. Okay, xtrain xval ytrain yval. Okay, we'll call this function train test split, and here we will have to specify our training data set, that is our train valid data. Okay, this is the data for the x, and for the label it is my train valid labels, and I'll say test size is equal to the validation split variable that we have defined earlier, and random underscore state is equal to 42 to ensure the repeatability of the split. So this will split the data into two parts. Okay, escape model underscore selection. Okay, now once we split the data into the two parts, then we can go ahead and start implementing the further activities. So this time what I'll be doing is I'll be making use of embedding matrix. Okay, we will make use of word embeddings. So let's first go ahead and download the pre-trained glove embeddings. So I'll just go ahead and download my pre-trained word embeddings. Now once this is done, the next thing that I'll do is, so this would download my embedding matrix, and we have downloaded it. Currently I'm unzipping it and I've removed that zip file. Okay, so once we have done this activity, the next thing that we will do is we will have to prepare the embedding matrix. So in order to prepare the embedding matrix, this is how I would write the code. So here I'm reading that text file which has got my embedding matrix. Now once I've done that, I'm performing the split, which is a general level of split, converting into the array and download and loading all those coefficients. So once everything is done, I'm referring to each and every index that I have got in my vocabulary, and I'm replacing those values with the embedding vector. That's what I'm doing right now. And finally, I'm sending my embedding dimension, number of words, and for the embeddings initializer, I'm specifying the embedding matrix which we have created by getting the data from this glove pre-trained embedding vector values. So I'll just execute this. So this will help me to prepare the embedding matrix, and this glove embeddings actually having 400,000 word vectors. So using those 400,000 word vectors, we will prepare this embedding matrix. Now once that is done, we'll just go ahead and build the model. So here I'm going to mention my model as sequential. Once we define the model as sequential, we are going to add the various layer. I'll say model.add, and I'm going to first add my embedding layer. And once the embedding layer is complete, this time I'm going to add conv layer. Okay, let's see whether we have loaded this. Yeah, con1d layer. I've already loaded this. So con1d layer, and I'll mention the value like this. See, for con1d layer, first is filter. I'll specify the filters as 128. Okay, and I'll mention my kernel size as, let's say, 5, and we'll use the activation as relu. Okay, so this is how we will add the convolution layer. Now this is followed by max pooling layer. So model.add and max pooling 1D layer, and I'll mention the pool window as 5. Okay, now once that is done, I'll just go ahead and copy this and complete the activity. So I'll just repeat it 2 times, and here what I'll do is, let's go ahead and see whether this is correct. Max pooling 1D. So let's do that import. It looks like that has been missed out. Okay, we had to import max pooling 1D. Okay, now once that is fixed, so let's come down over here. So max pooling 1D layer. Now here at the end, what I will do is, instead of using max pooling 1D, this time I'm going to add global max pooling 1D, and this is followed by dense layer. Okay, so model dot add dense. I'll have it as 128 neurons, and we'll use the activation as relu. Okay, next what I'm going to do is I'm going to add the final dense layer. Now in this given data set, the number of labels that we have got, see the number of intents, the unique intents that we have got is 0, 1, 2, 3, 4, 5, 6, 7, 8. So we've got total 8. So let's go ahead and mention the same. We've got 8 neurons in the final layer, and this will have the activation as softmax. Okay, so this will perform the model building. Now once that is done, we'll just go ahead and proceed with the same. Okay, max pooling 1D, so I don't have to specify anything for the global max pooling 1D. Okay, so once the model has been built, we'll just go ahead and compile the model. So model.compile, and here we will use the loss as categorical cross entropy, and we will use the optimizer is equal to RMS prop, and then matrix is equal to accuracy. Okay, let's display the overall summary of the model and let's see how does the model is structured. So we've got an embedding layer and followed by con 1D, followed by max pooling, followed by con followed by max pooling. At the end we've got con 1D layer. Finally we are applying the global max pooling 1D connected to a dense layer, and at the end we have a final output layer which has got the softmax activation function. So this is how our model structure would look like. Now, let's go ahead and perform the fit on this given data set. So, I'm going to say model.fit, and we'll perform the fit on our x train, comma y train. Okay, and we'll use the batch size as 128, and I'll train it for, let's say, one epoch. Okay, and I'll mention my validation data is equal to xval, comma yval. Okay, so let me increase the number of epochs. Instead of 1, let's make it 5. Okay, next, once this is done, let's perform the evaluation on the test data. I'll say model dot evaluate. Okay, I'll say test data that we have got, comma test labels. Okay, so we'll execute this. Let's wait for the training to complete. Model dot evaluate. Yeah, let's wait for the training to complete and then we will look into the overall model performance. Okay, so we have the training completed and we can see that the overall accuracy that we see on the test data is 97.62% of accuracy for this given test data. That's great, team. So what we have done is we have seen how to perform the intent classification. So to perform the intent classification, so we have made use of the data set, trained our deep learning model and evaluated on the test data set. Now, apart from this CNN approach, you can also make use of LSTM approach, and you can also train the RNN and see how your model is actually working. All right. So with this, we come to the end of this video. So as part of a learning journey in this video, we have seen how to perform the intent classification using the deep learning based model. So I'll see you in the next video.
Hey everyone, welcome back to your learning journey in this practical natural language processing. Now, in this section, we'll be learning how to build a conversational AI, that is a chatbot using a RASA framework. So, as we proceed in this video, we will understand what exactly is this RASA chatbot and why do we prefer to work with RASA framework and the high-level architecture of this RASA framework. So, let's get started. Now, before we deep dive into the RASA chatbot, let's understand what are the key steps that we have to follow whenever we are building a chatbot. Now, when we think about building a chatbot, as you might have experienced in the previous section as well with the help of Dialogflow, so it all starts with defining a goal. So we'll start by finding out what are the various use cases where my business can actually utilize the chatbot. And using this chatbot, I can resolve the user's query. And then also think about the product around those use cases in order to define the exact goal of the bot. Now, once you define the goal, once you are sure what you have to do, next you will go ahead and decide the personality and the tonality of the chatbot. Now, the reason this is important because this is the one which defines as how my bot is going to interact with my end user, who is very important for me. And the third thing is you are going to define the task flow. So here you are going to list out the specific task that a user can actually perform with the help of the chatbot. Now in this step, you'll go ahead and you are going to create a script and you're going to build a prototype on the basis of the script, and then you'll go ahead and start implementing it. So that's the third step, that is creating the task flow. Then once you have implemented your chatbot, the last step is interaction with the help of bot. Now at this step, you are going to build your chatbot and you are going to deploy it on the development server. And this is where you're going to test out your chatbot and you're going to check whether the chatbot is working correctly or not, whether the responses that your chatbot is actually giving out for the end user, whether it is as per the expectation or not. So this is where you exactly find whether your chatbot is actually breaking, if it is breaking, at which point it is breaking, so that you can go ahead and fix the issues. Now, when we talk about this RASA framework, so RASA is an open source conversational AI platform. So this RASA helps us to understand and hold the conversations, as well as it will help us to connect to messaging channels as well as the third-party systems through the set of APIs. So this RASA, it provides the building blocks for creating the virtual assistants or the chatbot. It's an open source AI tool. Now, with the help of this RASA framework, I can build, deploy, and even host RASA in my internal server, as well as the environment which I would prefer to host it. Now, the reason that we prefer to work with RASA, because one, it's flexibility. We can deploy on premises or on our own private cloud. So the another best part about this RASA framework is we as a business, suppose if I'm a business who is implementing this chatbot with the help of RASA framework, I'll be the one who will be controlling my training data as well as the models. I will have the complete control over it. And the best part is, as I mentioned earlier, so RASA provides the multi-channel customer experience, and as per the documentation, it provides 10 built-in messaging channels as well as the endpoints for the custom channel with the help of API. So not only it supports 10 platforms officially, but also it will provide the API where I can integrate it with my own third party or the external system. So that's the level of flexibility that we have with the help of this RASA. Now here, when we talk about this RASA, it's very important that you understand the core architecture of the RASA. So here, this slide over here describes the core architecture of the RASA. So in this RASA, there are actually two primary components. They are NLU component, which is also known as natural language understanding component, and the another component we call it as a dialogue management. Now this NLU, that is the natural language understanding component, is the part that handles the intent classification, entity extraction, as well as the response retrieval. Now in this overall architecture, it is shown as NLU pipeline. Okay, the reason because it is going to process my user utterances using my NLU model, which is generated by the trained pipeline. Hence, I'm calling it as NLU pipeline over here. And we have the dialogue management component. So this dialogue management component decides the next action in a conversation on the basis of the context. So this is actually described as the dialogue policies in this diagram. So NLU pipeline and the dialogue policies, these are the two primary components of a RASA. Okay. Now, apart from this, so you can see the various components. We've got agents. So through input and output channel, we'll get the input for the agent, and then we will get started. So we have the file system through which we'll have our models or the training data, and we have the log store, which we are going to track it, and then we have got the tracker store, and we have got the RASA action server. So we are going to learn in depth as we progress in our upcoming learning journey in this section. Now, before we get started and learn more about this RASA, in the next video, let's understand how to install the RASA so that our system is ready in order to get started with our learning journey. So I'll see you in the next video. Hey everyone, welcome back to your learning journey. So in this video, as we progress, we are going to look into the prerequisites and the installation steps and the demo of the installation in this video. So let's get started. One of the main prerequisites in order to create the RASA chatbot, in order to follow along with me, is you need to have a Jupyter notebook installed with Anaconda distribution. Okay, so once you do the installation, then you just have to run the commands. So these are the installation commands that you have to run it. First, you are going to create a virtual environment. In this example, you're going to create a virtual environment as RASA chatbot. Then you're going to activate that virtual environment. This is followed by installing the RASA and installing the Spacey. And once you do the installation of both, next you're going to download a language model which will help us for our future activity. Now this is followed by RASA init. Now this will help me in order to initialize a RASA project to validate whether the RASA has been successfully installed or not. So these are the basic steps, and this is one of the very important step in order to follow along with me in a hands-on manner in this exciting journey of building the chatbot. So let's get started. So in order to do the installation, first thing is you need to install the Jupyter Notebook via Anaconda distribution. So you just have to follow the URL. So copy this link and go to your browser. And once you go to the browser, you'll be redirected to this screen here. Depending on your operating system, download the Anaconda distribution. In my scenario, it's Mac. So in case if you're working on Windows, select the Windows operating system version. And if it's a Mac, download the Mac version. If it's Linux, go ahead and follow the installation steps for the Linux operating system. Okay, now once the installation is complete, so the next thing that you're going to do is in the Windows operating system, you're going to run all these commands on the Anaconda prompt. And on Mac, so you just open up the terminal, and even on the Linux, you'll just open up the terminal and run these commands. Now, in my scenario, I already have a Jupyter notebook installed with Anaconda distribution. So now I'll directly show you as how do we perform the installation of the RASA. So since I'm using the Mac OS, so I'm going to start my terminal. Now on this terminal, I'll execute the command one by one. So first thing is I'll have to create the new virtual environment chatbot. So conda create hyphen name RASA chatbot and Python is equal to 3.9. Okay, this is the command that I'm going to enter, and I'll press the enter key. Now once I do the same, so this is going to create a new environment. Now it is asking me for a confirmation. I'll press as Y and I'll press the enter key. So this is going to configure my virtual environment. Once this virtual environment has been configured, so we just have to activate this virtual environment, which brings us to the next step, that is conda activate RASA hyphen chatbot. So conda activate RASA hyphen chatbot. Now I'll press the enter key. So I have activated a new virtual environment, that is RASA chatbot. Now being in this screen, so that is being in this virtual environment, we have to install the RASA. In order to do the installation, I'll just have to say pip install RASA. So this will go ahead and perform the installation for me. So this will download the necessary libraries and it will do the installation over here. So right now it is downloading the TensorFlow. Once the TensorFlow has been downloaded, it will do the TensorFlow installation of the same, and then it will proceed with every other libraries which are necessary for us in order to create the chatbot with the help of RASA. So I'll pause the video over here and then I'll see you again once the installation is complete. Okay, so this took a while to complete the installation. Now once the installation is complete, the command prompt is appearing for me. Now I'll just go ahead and do the next step. So the next step is we have to install the Spacey. So I'm going to run the command pip install Spacey. So I'll press the enter key. This is going to install the Spacey library for me. Now once the Spacey library has been installed, I just have to run this command pip-m Spacey download. I just have to mention that model name. So this is going to download the language model from the Spacey. Okay, this will take a while, and once it's done, we'll be good to get started. Okay, the language model is now complete. Now it says you can now load the package via spacey.load. So which means we have also downloaded the Spacey language model. Now which means everything is working fine. At least the installation steps are working fine. Now the next step is running the command RASA init. Now before we run this command RASA init, so I'm going to mention one more comment, that's one more step, where I'll write it as go to the required folder. The reason that I mention this because when we run this command RASA init, this is going to create an example project for me. So for the demonstration purpose, I'll go into the desktop. So I'll switch to my desktop folder, CD desktop. Now here in this CD desktop, I'm going to create a new folder. I'm going to say rasa-demo. Now I'll go inside the new folder that I've created. Now once I go into this folder of rasa-demo, I'm going to run the command rasa init and I'll press the enter key. So what this is going to do is this is going to validate whether my RASA has been successfully installed or not, and it is going to create an example project for me. Now currently it says welcome to RASA. To help you get started, an initial project will be created, and here it is giving us the information for the documentation page. So for now I'm not going to specify anything. It says enter the path where the project will be created. So by default it's a current directory. So I want to create in the current directory itself because my current directory is rasa-demo. Now before I execute this, let me just show you how exactly the folder would look like as of now. So this is a folder which is an empty folder that I have right now. Now I'll just press the enter key. So once I press the enter key, so now it has created the folder structure, that is the overall project structure for me. So you can clearly observe that some news files has been created for me. So these are the files which describes the default project structure when we are working with RASA. Then it says, do you want to train an initial model? I'll say Y and I'll press the enter key. So once I press as Y, it will automatically go ahead and start training the model. Now do remember, this will take a while. If you're working on a slow system, please wait for some time until the training is complete. See, now it is saying that configuration for pipeline and policy has been chosen automatically, and now it is training my RASA for this diet classifier. Okay, so this diet classifier is one of the model which has been created by RASA team, which will help us to identify the intents in a much more effective way. Then it is running the other things. Now it is actually looking into the intent policies, and then it is simply going ahead and performing the training. Now once the training is complete, it says your model is trained and it is saved at this specific location. That means inside this folder of models, it has saved a model. See this file, that is gz file that you see right here, this is a trained model file. So the model has been trained, which from one side, it confirms that I have completed the training and I have all the necessary installation in place. Now that's a great thing. Now it is asking me as, do you want to speak to the trained assistant on the command line? So let's go ahead and do that. Why not utilize this opportunity? So I'll say why. So I've mentioned as Y. Now it is saying that it is starting a RASA server on this specific URL. Okay. Then it is loading the trained model. Then it is giving us some warning message. We can simply ignore it for now. Then it says RASA server is up and running. Then it says bot has been loaded. Type a message and press the enter key. Now I'll type in the input. This time I'll mention it as hello. And when I press the enter key, the RASA chatbot is saying that, hey, how are you? I'll say, I am sad. So it says, wow. So the RASA chatbot is now giving me a response that here is something to cheer you up, and it is sharing an image URL. So let's see what does this URL would look like. So I'm going to say open link. So if I open that link, so this is the cute tiger that I've got as a response, that is the image. Okay. So it is saying that check out this URL, and now it says, did that help you? I'll say yes. Then it says great, carry on. So we have just seen like a demo as how does this chatbot would look like. So it is able to get my input in the natural language, that is my English language. It is somehow is able to understand my natural language, and it is able to generate the response appropriately. Now that is what a chatbot is all about. Now to come out of this chat window, I just have to say slash stop and I'll press the enter key. So this will come out of this chatbot screen. Okay, so I've just come out of this chatbot screen. So what we have done as part of this video is, as part of this video, we have installed the RASA framework into our local system. We have built an example project, and then at the end, we have also tested whether the RASA is correctly installed or not by launching an application. So that is what we have done in this video. Now, as we proceed in our upcoming video, we are going to understand the overall structure of a RASA project. So let's learn more about the RASA project structure and understand the key parts of a RASA project, which will help us to modify this project as per our requirement. So I'll see you next time. In the last video, we have installed the RASA framework into our local system, and then we have created an example bot that is a default bot from the RASA. Now, as we progress in this video, we will look into the project structure when we are creating a RASA chatbot. So let's go ahead and understand this project structure. Now, if you simply open up the project structure, if you open up the project folder where you have actually created a chatbot, so this is the overall structure of this project. So here, this folder contains all the NLU as well as rules, including the stories file. So you basically observe under the actions, you basically observe the init.py file as well as the actions.py file. And then you're going to observe a file that's called as configuration.yaml file, and there will be a file on credentials.yaml file. And under the data folder, you will observe the nlu.yaml file, stories.yaml file, and there will be domain.yaml file. So these are the various files and the folders that will be present when you create a RASA project. So let's understand each of these. So for the benefit of understanding, so I'll open up the Visual Studio Code. Now here, this is the same project which we have created in the last video. Okay. Now if I expand this data, so this is the folder contains all the NLU rules as well as my stories file. Now, if you look into the file extension is YAML. So YAML is one of the markup language that we use it in order to write the NLU file, rules file, stories file, and most of the files in RASA framework. Now, if you're new to YAML file format, don't worry, just be with me in this video. In the next video, there is a separate video dedicated for you to understand how to read this YAML file and how to create a YAML file. For now, just be with me and look into the various files that I have got over here. Okay, so let's start with NLU file. Now, NLU stands for Natural Language Understanding. Now, this file is a very simple file. Okay, it contains the natural language data on which my RASA is going to train. So here I've got the NLU, and inside it I've got something called as an intent. Okay, along with the intents, I have the examples of the text. So these are all my training data. So these are all the training data for the intent of greet. And if I come further below, these are all the examples for the training for training my intent of goodbye. And these are all the training examples for the intent affirm and so on. Okay, here under each intent, there are training examples which are actually our training data. Now, some of the key things that you have to keep in mind whenever you're creating the training data is add the augmentation to the examples which come under the each intent. Okay, and ensure that the examples should not be so different than your intent, because at that time it might get confused. To give you an example, here I've got an intent that's called as an goodbye. So for this goodbye, I have added as many augmentations as possible. Goodbye, bye, good night, see you later, goodbye, see you. So bye bye, see you later. You can look into this example. I have added as many augmentations as possible so that my training data has the effective data that is present with me to identify this intent of goodbye. Now, one key rule which is always suggested is add at least 5 examples under each intent. And this intent, the labeling of the intent that you would specify, so this intent should convey the feeling that users can ask from the chatbot, because not every question is considered as an intent, isn't it? And also, you can also add some wrong examples as well in each intent, because obviously no training data is perfect. So you can also add some wrong examples as well in case if you want to work around. Okay, so this is about my nlu.yaml file. So you can clearly observe I've got the intent and the intent name and the training examples. And then I've got a rules file. So if I open this rules file, this is how my rules file would look like. So we actually create these rules to handle this small specific conversation pattern. So you can think of them as a hard restriction or the hard coding that I'm actually specifying right here. So whenever the user like understands an intent, okay, let's say in this scenario, intent has been identified as goodbye. So here at that time, so what the rule it says is its action should be responding to the goodbye. Okay, its action should be responding to the goodbye. Or we can say that like whatever the responses that the machine learning model of RASA is actually giving to me, ignore everything, just follow this rule, which means with the help of this rules.yaml file, not only I have the ability to train my RASA, okay, but also I can create a rules-based system by specifying the rules specifically in this rules.yaml file. Okay, now once I have done this, so the next thing that we would normally do is we are going to specify the utters in the domain.yaml file. So there's a file that's called as domain.yaml file. So in this domain.yaml file, I have mentioned what are all the list of intents that I've got and what are all the responses that I've got. Now in this file, that is rules.yaml file, for this intent, I have mentioned what is the action, isn't it? Action is utter goodbye. So I have mentioned as what exactly is the text inside this domain.yaml file. So utter goodbye, the text is bye. Okay, that's the overall concept over here. Okay, now we have got the nlu.yaml file and we have seen the rules.yaml file, and there is another file that's called as stories.yaml file. Now in this stories.yaml file, we are going to mention how the user stories should happen. So in this stories.yaml file, so key thing that you have to remember is we define the story. Okay, so in this story, it can be a happy path or it can be a sad path. Okay, so a story is typically a representation of a conversation that happens between a user and an AI assistant. Okay, so what it says is if it is a happy path, okay, the steps are greet and utter greet, that will be the action from the bot, and the intent understanding from the user is mood greet, and then the action will be utter happy. So it will just convey the overall path, how the conversation flow will happen. So that's what you have to remember when we talk about this stories.yaml file. And then one important file, that is domain.yaml file. I have already described this domain.yaml file where when I talked about the utter. So I can say that this domain.yaml file, so this is the entire universe for the chatbot. Now this domain.yaml file, it contains everything. It contains all the intents, okay, and it contains all the utters, that is all the responses that I have got, and it contains the session configuration information, and it can contain the like actions, what are the action it has to perform. And I can also create multiple domain files as well if I'm working on a large project. Okay, so that's the overall idea. It's like the entire universe for my chatbot. And there's another file that's called as configuration.yaml file. Now this configuration.yaml file contains the actual information about the pipeline of my chatbot. So this is the pipeline that will be used in order to interpret my user's input, and after I interpret my user's input, I'll be able to predict the intent for the same. Now after that, once it identifies the intent, it is also going to help me to predict what will be the correct response for the input from the user. Now all these things will be happening with the help of the policies. And there is something called as action. So action is a folder, and this folder contains a very important file, that is actions.py file. Now this is where I'll be writing the custom actions. So as we progress in our learning journey, I'll show you how to write a custom action and how we can connect it to a third-party API. And if I want to write any custom response, I can control it from here. So all these things that I can control with the help of this actions.py file. And lastly, there are credentials.yaml file as well as this endpoints.yaml file. So credentials.yaml file contains the overall credentials. So I'll show you as we progress as how we maintain the credentials. So in our learning journey, I'll show you as how we can connect our chatbot and integrate it with the Slack channel. So there I'll talk about how we actually maintain the credentials over here in this credentials.yaml file. And then there's an endpoints.yaml file. So in this file of endpoints.yaml file, it contains the various endpoints which my bot, that is my chatbot, can use. Okay, so that's the overall project structure of this RASA chatbot. So now that you have a high level understanding of this RASA chatbot project structure, I'll stop the video over here. In the next video, we'll deep dive into this RASA project structure and continue further in the learning journey. In the last video, we had a high level understanding of the project structure whenever we are creating a chatbot with RASA framework. Now in this project structure, we have seen the various files. So we've got the NLU training file, and it contains the training data with the details like user input, entities, and the responses. And we have looked into the stories.yaml file. So this contains the sample interactions between the user and the bot. Here I'm going to describe the story path, and I'll mention how exactly the interaction would happen between the user and a bot. And then we've got a domain file. So this domain file is a universal file. It contains everything. It has got all the content like the intents, entities, actions, templates, and other information as well. And we've got a policy file. So in this policy file, this is going to decide what will happen at each step. Now, apart from these files, I want to give you a quick information about the command line interface that are supported by RASA. So we've got a command which we have seen already, that is RASA init. Now when I run this command in the command line, that is RASA init, this is going to create a new project with the example training data, actions, and the configuration file. Now apart from that, we have got a command that says RASA train. Now when I enter this command of RASA train, this is going to train a RASA model using the NLU data and the storage, and it is going to save the train model in the /models folder. Okay, and we have got a command that is called as RASA interactive. So this is going to start an interactive learning session in order to create a new training data by chatting to your assistant, or that is my chatbot. So here I can add the training data with the interaction itself. So that's the command of RASA interactive. Here we've got RASA shell. So RASA shell is going to load the trained model, and it will help us to talk to our assistant on the command line. And there's a command that's called as RASA run. So this is going to start a RASA server with the trained model that we have generated. And we have got a command that is RASA run action. So this will help us to start an action server using the RASA SDK. That is RASA Software Development Toolkit. And then we have got the RASA visualize. This is going to generate the visual representation of the stories that we have created. So these are all the commonly used RASA commands. So RASA init is what you have seen already. Now, if I want to train my model, let me just give you the demonstration of the same. So if I open my terminal and let me show you the important commands. So we have seen the RASA init, right? So when I say RASA train, this is going to again perform the training with the data that I have got over there with me. So this will trigger the retrain. Okay. Now it is going to trigger the retrain using all the data that is present inside my data folder. So it will refer to the nlu.yaml file, these.yaml file, domain.yaml file. It will use everything, and then once the training is complete, so it is going to add a new model instance over here. So it's going to add a new model instance. It says the RASA model has been saved at this specific location, and we can see that file, see the searing date. So this file that has been created right now, this is a new model file that has been generated. Okay. And we have got the RASA interactive. So we will look into it as we progress in the learning journey. And there is RASA shell. So RASA shell will help me to start the RASA, and I can start chatting with this RASA chatbot in the command line interface itself. So currently it is starting the RASA server and it is loading the latest model that has been trained. Next, it will help me to start chatting with this RASA chatbot. Now it says your input. When I say hi or simply say hello, it says how are you? I'll say it as good. It says bye. So this will help me to chat with my chatbot, okay, in the command line interface itself. And we have got RASA run and RASA run action. We are going to visualize it and learn more about this command as we progress in the learning journey. So when we start building our advanced application, that is when I'll be showing you as and when it is required. Okay. And there is a RASA visualize. Okay, so I'll just show you this visualization as of now, but we will look into it in detail as we progress in the learning journey. Now, when I run this RASA visualization, so it's going to generate the visualization for my user stories. It stays from start, hey there, utter greet, and not good, utter cheer up, did that help? If yes, so utter happy. So if we didn't like that, utter bye. So it just describes the overall conversation that happens between the user and a bot. Okay, these are all the most commonly used the command line interface commands that we'll be using whenever we are working with RASA. We'll discuss in detail as we progress in the further parts of our learning journey. Now with this, we come to the end of this video. In the next video, let's learn the basics of writing and reading a YAML file, because as you have seen earlier, YAML is one of the prerequisite to write this training file. So let's look into the basics of YAML file in the next video. In this video, let's learn about the basics of YAML file. So as we proceed in this video, we will understand the basics of creating a YAML file in a hands-on manner. So let's get started. Now in order to learn this YAML file, I'll launch my VS Code, that is my Visual Studio Code. And here I'll just create a new file over here in this path. So I'll just say it as learn.yaml. Okay, that's the new file that I'm going to create right now. This is a basic file, like this is a file where I'll be typing the code and then I'll be explaining you as how we normally create this YAML file. Now, first thing, let's understand what exactly is this YAML. So YAML is actually known as YAML ain't markup language. Okay, so it is also known as YAML ain't markup language. Now, this YAML is a serialization language. This has got a lot of popularity these days. Now, this YAML format is used basically for configuration file. Now, with its ease of use, so it has actually made it as a viable replacement for the languages like JSON. So as we progress, so we will learn about the various syntax that we have to follow whenever we are creating this YAML file. So this YAML acronym, it was actually started as yet another markup language. Then the maintainers, they actually renamed to YAML ain't markup language in order to place more emphasis on its data oriented features. Now, when I open a simple YAML file, so let me just open this nlu.yaml file. If I open this nlu.yaml file, this is how a structure of this nlu.yaml file would look like. So I've got something like this. At top there is a version and there is a value that is assigned. There is an NLU, and inside it there is something called as intent. For intent I have assigned something as greet, and below it there is an example. So this is how my structure would look like. Now, one thing that you normally observe whenever you're working with the YAML file is it will be composed of key value pair. Now, from the perspective of general learning of YAML file, whenever we are creating a YAML file, we are going to start a YAML file with 3 dashes. Okay, we'll begin to create a YAML file with 3 dashes. Now, these 3 dashes indicate the start of a YAML document. So by default, this YAML supports multiple documents, and whenever I've got a compliant parser, so it is going to recognize these 3 dashes as the start of a YAML document. Now, in every YAML file, as I mentioned earlier, you're going to observe a key value pair. Now, in this example, the version is actually a key, and the value 3.1 is actually a value that I have assigned. So the type of value that I have assigned right here, this is a string value. Okay, this is a string value. The reason that I'm saying it as a string value, because here the values are actually mentioned inside my double quotes. So I can mention something like this. I'll say course as a key, okay, and NLP. So this is the string value that I have assigned. Now, when we talk about this YAML file, YAML supports more than string values as well. So whenever we are working with this file, okay, so in this example file, I've got the set of key value pair, okay. So if I come below, let's see if I've got some more examples over here. Let me come to this domain.yaml file. So if I come to this domain.yaml file, so I have assigned the session expiration time and have assigned the integer value as 60. See, this is a demonstration. And for the carryover slots to new session, I have assigned a Boolean value. So I can assign the integer value, I can assign a Boolean value, I can also assign a floating point number as well. So I'll give you an example. I'll write it as duration. I'll write it as 25. Okay. Let's say percentage. I'll mention it as 95.5, and valid, I'll mention it as true. So here, this key course contains a string value assigned. This key duration contains the integer value assigned, and the percentage contains the floating point value assigned, and then valid contains the Boolean value assigned. Okay, so in this way we can assign the values. Now, one key call out I want to make over here is whenever I'm assigning the string, okay, so I can assign the string in the single quotes as well, or I don't have to assign anything at all. Okay, so I have referred as double quotes only for our understanding purpose, but I can assign it in single quotes, or even I can assign it without any quotations at all. Okay, so in this way, so we can actually go ahead and assign the values. And what it means is whenever the YAML comes across any numerical values, and if it is present in unquoted format, it will be identified as either integers or a floating point number. Okay, now apart from having these individual values, this YAML also supports an array. Okay, this YAML also supports an array. For example, I'm going to mention it like this. I'll say curriculum. Okay, so this is a key that I would mention. For this key, I'm going to assign the set of values. I'll say NLP, and I'll write it as, let's say, pre-processing, pipeline, word embedding. So this curriculum is a key value. Okay, this is basically a key value Now under these key values, I have actually assigned 4 elements inside it. And each of these elements are actually denoted by an opening dash. Now that is what I have done right here. Okay, so this is an example of an array. So this is an example of an array which contains the multiple values assigned to a single key. Now apart from this, whenever we are working with the YAML file, YAML supports the nesting as well. If I want to perform the nesting, then I have to follow the indentation. So when I come to this example, that is the domain.yaml file, this is a clear demonstration of nesting. So I've got the responses. Inside this responses, I've got the 1, 2, 3, 4, 5, 6. Okay, I've got 6 elements which are present inside this responses. So this is how we can actually specify the nesting. So I've got one key, and inside that key I can have multiple subkeys. Now whenever we are representing these kind of hierarchical or the nesting like structure, we are going to make use of the indentation. So we have seen the basic data types, the integer, string values, the floating point number, boolean values, as well as the array type. Now let's go ahead and look into this indentation and white spaces. Now when we are working with the YAML, so white space is actually part of the YAML formatting. So whenever we are working with the YAML file, so whenever I've got a new line, so the new line is going to indicate the end of the field. Now we are going to structure a YAML document with the help of this indentation. So this indentation level can be 1 or it can be more than 1 spaces as well, and we can actually use it as per our requirement. And when we are working with YAML file, the usage of tab is actually forbidden because the tools will treat differently when we are working with the tab. Hence, it is recommended that we use the spacing. Now the items inside this, let me just give you an example. Okay, let me just say I'll say it as food. Okay, and I'll say dosa. Okay, then I'm going to mention something like this. I'll say millet. I'll just specify some key value like this, and then in the same indentation level, maybe I'll say grain. I'll just mention some more value like this. Okay, rice 5, wheat 7. So I've mentioned some values like this. Okay, I've just mentioned some random values. Now here, if you observe, apart from this grain, okay, I have also made use of the white spaces. So what it actually mentions is, so this millet and the grain that I have got, so this is nested inside my food. So this is the overall way in which that we can actually specify the multiple elements as per our requirement with the help of the indentation. Now let's come back to our nlu.yaml file and let's understand the various symbols, because this is what we are mostly interested in. So this version 3.1, this is a key value pair, and there is a key over here. Inside this, we have got the elements. So inside this array, okay, I've got the complex objects. So here I've got the intent greet, and then alo along with this intent grid, I also have the multiple values as well. I've got the examples, and here I have made use of pipe symbol. So I have actually made use of this pipe symbol. So what exactly it would mean? So we use this pipe symbol whenever I want to specify the multiple lines. So here, if I don't specify the pipe symbol and use it as a single line, that means if I simply specify a single value, then at that time, the YAML interprets it as a single line. So if I have to treat it as an individual line, that is, if I want to treat the data exactly as it is, I'll make use of this pipe symbol. Okay, I'll say examples, pipe symbol, and I can mention these examples. So I have followed the same thing in the entire document of nlu.yaml file. Now I'll open this rules.yaml file. Here also you can observe the key value pair we are mentioned as rules, and there is a rule over here. And inside the rule, like for this rule, I have assigned the same, and the same level of rule, there are some steps, and inside the steps, it's a kind of a list, which is a key value pair. Okay, this is the structure of my rules.yaml file. If I open the stories.yaml file, we've got the key value pair, we've got the stories over here, and I've got the individual story and the path. So just remember, these are all the key value pair that we are going to have, and we'll make use of the indentation, and remember the format. Just follow the same format which is present in this example file whenever you're creating your own file. Apart from that, we've got configuration.yaml file. Even this follows the indentation, and whatever the values that I mentioned has hash, okay, these will be the comments. So these will be treated as comments. We've got credentials.yaml file. Currently everything is commented out. We can uncomment this as per our requirement. And there's a domain.yaml file. So even this is a key value pair. We've got endpoints. So this is how the overall YAML file structure would look like. So the key takeaway is, when we are working with the YAML file, we are going to have the key value pairs, and I can have the values belonging to the various data type. It can be string, integer, floating point, and any other data type that I have got. And we've got the indentation. So YAML follows the indentation. So we generally use double spaces for the indentation purpose. So this was about a basic quick idea about the YAML file. This is more than enough for you to get started in this learning journey of RASA. So with this, we come to the end of this video. So in the next video, we will proceed ahead and we will build a chatbot and add the intents and the response for the chatbot that we are going to create. So I'll see you in the next video. In this video, let's go ahead and implement our own intents and the responses for the RASA chatbot. So as we progress, we'll look into it in a hands-on manner. So let's start coding. I'll open up my RASA chatbot project. So this is the RASA chatbot project. Now, the requirement is I have to create my own intent, and for that intent, I have to generate my own custom responses. So you already know the basics about the YAML file. Now, in order to create our own intent, so first thing that we have to do is we have to add this intent related information into our nlu.yaml file, because nlu.yaml file is our training data. So let's go ahead and add an intent. So for the demonstration purpose, I'll just copy the existing intent, and I'm going to mention my own intent this time. So I'm going to mention it as intent who underscore creator. That means I'm going to get an intent that's a new intent creation that is called as the who underscore creator. Now here the examples for the training examples for this are, okay, I'll say who is your creator. Okay, the another response is who owns you. Okay, and maybe like who are your parents. Okay, so like I'm just adding few more information. Okay, so who is creator. Okay, and I'll add one more information. Let's say creator, owner. Okay, so these are all the training examples. So for the intent who underscore creator, I'm adding the examples. So the examples for my training data are who is your creator, who owns you, who are your parents, who is your creator, and the owner. So I have added as many augmentations possible for the intent identification. Now, once I add this intent over here in this nlu.yaml file, the next thing that I have to do is I have to list down this intents in this domain.yaml file. Now, why is it required? Because domain.yaml file is what my RASA chatbot is going to refer. So I have to ensure that under the intents, okay, so I'm going to mention my intent. So I'll mention the intent something like this. Let's say who underscore who creator. So I have to mention my intents over here in this domain.yaml file. Now, once the intent has been identified as who underscore creator, what should be the response? Now this time I want to generate the response, which will be a text response. So let me go ahead and generate that response. So I can mention about my response under this action and I can actually mention it under the story path. So here I'm going to mention a new story path. So I'll say hyphen story. I'm going to mention as creator path. It is just a path that I'm going to mention. Okay. So what are the steps that are involved in this creator path? I'll say steps here. If I identify the intent as who underscore creator, okay, if I identify the path as who I intend as who underscore creator, now I am expecting an action. So what is the action? I want to generate a text action. That is I am expecting a text response. So every text response is actually mentioned with the help of utter. So utter refers to a text response. So I'm going to say utter creator. That's the response that I would expect. That is the action that has to perform that my RASA has to do. So when the RASA identifies the incoming intent as who underscore creator, it has to take the action as utter underscore creator. Now that is what it says. The utter underscore creator should be the next action. Now what is this action? This is actually a text response. Now how do I mention this text response? What it actually means? So I'll come back over here in my domain.yaml file. Now in this domain.yaml file, I can go ahead and mention how does my text response will be. I'll say utter creator. Here I'll write it as text. My owner is a data scientist. Now, if I want to give each response at each time, so what I can do is I can mention multiple text like this. So text, and I would say that I am created by a learner in data science, okay, of manifold AI learning, okay, and I'll mention one more text response that says I am a student of manifold AI learning. So my owner is a data scientist of manifold AI learning. So I'll just mention my own responses. So what I'm doing right now is, so observe the order in which that I have modified the data. First, I have defined my intent in this nlu.yaml file. Now for this intent, once I have created, I have mentioned this intent in this domain.yaml file because domain.yaml file is a universal data, like it contains everything. So whatever I add in my nlu.yaml file, I have to mention it under this intents as well. Next, under the stories, I have mentioned if I identify this as an intent, what will be the action that I have to take? So I have mentioned the action as utter. Okay, now what does this utter creator would mean? So I have mentioned its meaning in the domain.yaml file under the responses section. So under this responses section, I have mentioned as utter creator, and for this I have mentioned some text data as an example. So in this way, I'm specifying the responses. Now, once I create it in this way, let's validate by going through the other files. So we have got the configuration file. We'll not worry about it as of now. There's a credentials, okay. Endpoints.yaml file, will not worry about it as of now. So I think everything is looking good. So what we can do is we can go ahead and retrain our model with the new data, and let's see whether it is working as per the expectation or not. So I'm going to launch my terminal. I'll activate my chatbot. So RASA chatbot. So once I've activated this, I'll go to the folder where I have got this project file. In my example, it's actually present in the desktop. So cd desktop and then cd rasa-demo. Now inside this, in order to train the model, so as we have learned in the last video, the command line interface is the command that I have to run is rasa train. So this is going to retrain my model. So it has started the training. So it goes through my entire data. So it first goes to my configuration.yaml file and looks into my current configuration that is present right here. And then it goes through my training data that I have got over here. Now it has started the training. Now once the training is complete, then it will give me the option to start the testing. Now what we can do is, let's wait for the training to complete, and once that is done, we'll go ahead and start chatting with the chatbot. Now it says the model has been trained and it is saved at a specific location. Now let's go ahead and test it. So I'll say RASA shell. So that's the command line interface command that we specified in order to start chatting with the chatbot in this command line interface. It is loading the model from the model location. Okay, now it says bot has been loaded. I'll say hi. Now this time I want you to observe how everything is happening. I'll mention it as hi. Now, what does this hi would refer to? So let's go ahead and look into our nlu.yaml file. When I press the hi and mention the enter key, so go through this nlu.yaml file and let me know what is the intent that is being actually checking. That's correct. So for the word hi, the intent that will be identified is the greet. So that is how the system is going to identify the intent. Now, once the system identifies the intent as greet, what should be the response? So the response will be decided from the stories.yaml file. So if the intent is greet, okay, then the action will be utter greet. So you can observe there are various story path irrespective of the story path. So when the intent is greet, we will have the action as utter greet. Okay, so that will be the steps that would happen. So greet, utter greet, which means right now when I press the enter key, the intent will be identified as greet and the action has been identified as utter greet. So what does the utter greet would refer to? So to get this information, we'll have to refer this domain.yaml file. So utter greet means, hey, how are you? So let's test it. Let's test our theory. And this time I'll press the enter key. Once I press the enter key, I've got the response as, hey, how are you? So which means this is working as per our understanding. So this is getting identified from the training examples and it determines the intent. Once the intent has been identified, then it will refer to the storyline and checks what exactly is the next action it has to take. Once it identifies the action, the system comes over here and generates a response. Now I'll say, I am sad. Now let's have a look into the example and understand what will be the intent that will be identified when I input as I am sad. So if I come over here for my nlu.yaml file, so let's identify what is the intent that will be identified when we mention it as I am sad. Okay, so I am sad. So the intent that will be identified is mood unhappy. So for this mood unhappy, what will be the response? Yes, let's go over here and let's look into the stories.yaml file. So the mood unhappy is present in the sad path. So from this, it gets the confirmation that it is currently in the sad path. So when the mood is unhappy, the action will be utter cheer up. So what will be the utter cheer up mean? So utter cheer up means if I come over here in my domain.yaml file, so utter cheer up means this is the text. So text here is something to cheer you up and there's an image that we are getting. So since it's a command line interface, I'm getting this link over here. But in reality, if we have actually deployed it on any website at that time, we might get an image itself will be loaded depending on the third party interface that we are using. So now if I press the enter key, I should get the response as here is something to cheer you up and it is giving me the image. And then, okay, then it is giving me one more message as did that help you? Well, that's strange, isn't it? So we have just seen utter cheer up. How did this system came up with this new message? Well, to answer that, let's come over here in the stories.yaml file. It says there are two action actually. One action is utter cheer up. Post that, there's one more action that is triggering that asks me as did that help? That is utter did that help. So utter did that help means here it says did that help you? And that is the reason that I've got two outputs right here. So this is from one response and this is from another response. Now once that is done, Next, if you look into the stories.yaml file, it is asking for the intent. Now, if I say yes, okay, if I say yes, so yes will be identified as firm. Okay, yes will be identified at the intent as affirm. So if it is affirm, the intent is affirm. So I'll get the action as utter happy. So what is utter happy? Let's come over here in this domain.yaml file. So in this domain.yaml file, it says great, carry on. So I'll press the enter key. So it says great, carry on. So whenever a user provides an input for the chatbot, this user input will be matched with my training example, and it identifies what is the intent of the user input. Then to generate the response, the system is going to refer to this stories.yaml file, and with this stories.yaml file, it will decide what should be the next action. Now, once it decides the next action, how does the exact action will be? So it will be decided by this domain.yaml file. So we have just seen how to specify the utter. Utter is nothing but the text response. So whenever I'm providing any text response, I can just mention the text inside this utter and it will generate the text response for me. So this is the overall flow whenever we are working with the chatbot. Now we have configured our own intent. So the intent that we have configured in this video is this intent who underscore creator. Now let me go ahead and provide the input. This time I'll say who is your creator, and I'll press the enter key. Now who is your creator is the text data that is matching my training records of this intent of who underscore creator. Now for this who underscore creator, from the stories I'll get to know what will be the action it has to specify. Here the action step is utter creator. So utter creator would mean under the domain.yaml file I have configured such that it will give me a response as one of the text responses that you see right here. So this time when I press the enter key, I've got the response that says as I am a student of manifold AI learning. So this is a text response, which is one of the text response that I have got right here from this command. Now let's suppose if I say who is creator, it says I'm created by a learner in data science of manifold AI learning. So each time when I provide an input, it is generating the responses in a random way. It is picking up a random text from the available responses that I've got with me. So this will give me a kind of dynamicity so that every time when the user asks me something, so I'll be randomly going through with the set of lists that I'll have with me. Okay, so this is how we can create our intent as well as we can ensure that we are getting the response as per the expectation. All right, team. So we have created our own intent and we have also tested whether it is working correctly or not. Now, in the next video, we'll go ahead and we are going to take a step further and we are going to see how we can extract the entities from the user input. Now, in all these examples, we have just created the intent, isn't it? And we have generated the response. Now, to have a chatbot, I should be able to get the important information from the user, and using that important information, I should be able to store it somewhere. Sometimes I should be required to process it at a later point. So in order to do all those things, we will be requiring to extract the entities. So let's see how we can extract the entities from the user's input and how we can use the same at a later point. So we'll discuss everything in detail in the next video. Hey everyone, and welcome back to your learning journey. Now in this video, let's learn how we can extract the entities from the user input. So let's get started. So in order to do this in a hands-on manner, so let's start coding. Now, before we directly do the coding, let's learn some of the best practices whenever we are working with the training data. Now, this is the official documentation page of the RASA. So here in the RASA, we've got various versions. There is a RASA open source, which is an open source, and there is a RASA Pro and the RASA Enterprise, which are the paid versions. So you can check out their documentation. Now here, I'm in the documentation page for RASA open source. Here, we'll just have a quick glance on the training data format. So RASA uses the YAML as a unified and then extendable way to manage all our training data, including the NLU data, stories, and the rules. So which we are aware of it already. And they are going to specify some more information like we can split the training data over number of YAML files, and each file can contain any combination of NLU data, stories, and rules. And here, most importantly, so just come over here. So under the high level structure, they have mentioned something like this. So here it says there are multiple keys. So the important keys that you would observe, the high level structure in a file is training data file is you will observe the version, you will observe the NLU, you will look into the stories, and you'll also look into the rules. Okay. So that's what we would observe whenever we are working with the file. Now in this example, so here they have actually mentioned every training data in a single file. Now in this approach, we can create everything in a single file, but in our scenario, we are splitting it up and we are creating separately. So let's come little below and let's look into the NLU training data. Now this we are aware of it already. Now, whenever we are creating the training data under the NLU, so it will be grouped under the user intent. Okay. And here, while specifying the intent, especially while specifying the example, we can also perform the annotation for the entities. This is what we are interested in. So here in this example, it says, what's my credit balance? Now here the credit has been identified for the entity of account. So credit is the value and this value is identified for the entity that's called as a account. So in this way, we can annotate our training example to extract the entities. So we can perform it in this way. Optionally, we can mention the annotation in this way as well. Okay, whatever the value that I want to link to, we'll generally include it inside the square brackets, and the entity that we want to assign, we can include it either inside the parenthesis or inside the flower brackets in this way. Now we use the flower brackets whenever we are working with a specific syntax. If I come little below, this describes the complete syntax. Okay, this describes the complete syntax for annotating an entity. So entity text, we enclose it inside the square brackets and we mention the entity and specify the entity name. We can also add the additional information like role, group, and the value to provide more information about the entities. So the straightforward way is we can just mention the entity text and the entity that it corresponds to. And these entities are nothing but the structured pieces of information which we can extract it from the user's input. Now, it's very important that we annotate it in our training data so that it can be extracted in an easier manner. Now, while specifying these entities, I can either mention it in the training data like this, or I can also make use of regular expression. You can check out the documentation for the complete information of the regular expression. Now, in this example, we'll take up the straightforward approach, that is how we can assign the entity text for the entity that I want to assign to, which is one of the major way in which that we assign the entities in every project that I have worked. Apart from that, we can also describe the synonyms, and yes, here this is an example for regular expression, and we can also have some kind of a lookup table. So all these things that we can mention inside this for the entities. Now, once we have described the entities, and especially once we have done the annotation, we have to ensure that this entities that we extract, we have to store it. Now, the way that we store it is with the help of slots, and we actually mention all these entities inside our domain.yaml file. Now, if I come over here in this domain documentation page, so this describes how does an domain.yaml file would look like. Here it says we've got the intents, okay, we've got the entities, we've got the slots. So intents that you're aware of it already. Now, in this example, we have got the entities. For the entities, we have mentioned as name, which means whatever the entity that we have annotated in the training data. So we name all those entities under the entity section. And apart from that, there is something called as slots. So let's understand what are these slots. So here the slots are the bot's memory. So they actually act as a key value store, which we can use it to store the information which my user has provided for me. For example, it can be the home city or it can be their name. So whatever the information that you want to gather from the user, you will gather it and store it inside this memory location, that is the slots. Okay, so here when we are defining the slot, so we define the slots under the slots section. So apart from entities, we also have to have one more section that is called as slots, and the syntax that we follow is we will mention the slot name. Okay, so we'll specify the slot name, and then we are going to specify the type. In majority of scenario, we'll use the text type. Okay, and then we are going to specify the slot mapping as from entity. That means this slot will get filled from the entity that I'm extracting from the user input, which means not only I have to list down my entity over here under the slot section, I have to specify how the user's input are actually being I mean how we actually get those information from the user input when we extract those entities. Okay, so that is how we can mention. Now apart from getting the data, linking it to the entities, we can also create our own mappings as well. That means we can also create our own custom slots as well as per our requirement. So as I mentioned in the beginning of a learning journey, domain.yaml file contains everything. So which means if I'm including the user's entities and if I'm defining the slot, we also have to mention it in this domain.yaml file as well. Okay, so these are the key things that we have to keep in mind whenever we want to extract the entities and store it and use it for the future response. Now that we have the best practices idea from the RASA documentation, let's go ahead and let's get the input from the user. From there, we are going to extract an entity, and using that extracted entities, we are going to go ahead and include it in the response. So let's go ahead and do that. Now, what I'm going to do is I'm going to create an intent. Okay, the intent that I'm going to do right now is I'll copy the previous intent and I'll modify it. So this time I'll say get name. So get name is the intent that I'm going to get, or I'm going to specify, or I'll say it as get username. Okay, that's the intent that I'm going to define. Now for this username, I'm going to mention some examples. So I'll write it like this. So my name is, and here I'll mention as Murthy. So I'll specify this text inside the square brackets to describe my entity text, and then I'll be assigning it to the entity of person. Okay, then I'll say my name is Kavya. Okay, and I'll mention this as an entity text example, and this is also belonging to the entity of person. Okay, so I'll do this kind of an encoding like this. Then I'll say my name is Raj, and this belongs to the entity of person. My name is, let's say, Paul. Okay, this belongs to the entity of person. And let me give some more example. Jack. Okay, so this belongs to the entity of person. So I'm Sam. So in this way, we are going to create this nlu.yaml file. Next, I would go ahead and modify the stories.yaml file. Now in the stories.yaml file, I'm going to create a new story path. So this time I'm going to mention something like this. I'll say user identification. That's the story path. So here the intent is nothing but the get username. So for the intent of get username, the action that I'm interested to perform is utter welcome. Okay, so this is the action that I want to perform. So what does the action would represent? That is utter welcome. So let's go ahead and modify this domain.yaml file, which will be the next step. So in my YAML file, I have added my intent and the relevant response. So I'll go to my domain.yaml file. Under this intents, I'm going to mention the intent that we have just created. Now, once this is done, the next thing that I have to do is I have to mention the domain. In the domain, I have to mention the response. So response that I mentioned is utter welcome. So let's go ahead and do that. I'll come over here. Now I'll just copy the previous action. Now this time I'm going to paste the same over here. So it is utter welcome. Okay. Now for this utter welcome, what I'll be doing this time is I'm going to provide a response such that whatever the data that I have read earlier, I'm going to mention it in the response. So this time I'm going to simply mention like this. I'm going to write it as welcome dear, maybe this. Okay, so what I'm saying is welcome my dear, the person name. So I'll just mention one more something like this. That's a very nice name. And I'll mention it as a person as an entity. Okay, and I'll say nice to meet you. Next, I'm going to mention something like this. I'll say, okay, I'll say wow, good to know you. I'll mention the person name. So what I'm doing right now is whenever I have identified the intent, that the intent is get username. So assuming that I have read this entity, that's the person name, then in the response, that is the utter welcome response. So I'm saying that welcome dear Murthy, that's a very nice name, Kavya, nice to meet you. Wow, good to know you, Jack. So that's the kind of response that I'm expecting in this scenario for the utter welcome. Okay, so I have defined my action and I've also defined the intent. Now this time we are dealing with the entities. So since we have created a new entity, so what we have to do is we have to mention this entity in the domain.yaml file as well. So I'm going to add it as an entities. Okay, now under this entities, I'm going to describe the person. So this is the entity that I have defined in my training data. Now, along with that, I have to save this entity in a slot, which is my memory location, so that when I'm giving the response, that is when I'm generating the response, I can generate it by referring to that slot. I'll mention it as slots. Okay. And for the person slot, I'm going to mention the type as text. That's the type it would belong to. Next, for the mappings, now under the mappings, here I'll mention the type as from entity because this time we are getting it from the entity itself. Then I'm going to mention my entity. What is the entity that I'm referring to? I'm referring to the entity of person. So this is how we will refer to the slots. So we will create the entity and after that we are going to specify the slot. This time the slot has been mentioned as person. So if I have a training data where I'm getting the extraction, that means I'm getting the entity extracted from the user input. So I'll specify the entity name and I have to mention the annotation in my training data in this format. Now once the annotation has been mentioned, then in my stories.yaml file, we will specify the action. Now in my domain.yaml file, we will specifically declare what are the entities that is being used in the training data and the slot, which are the memory location where I have to actually store these entities, which I can refer it at a later point, especially during the response or if any third party action that I'm performing at a later point. Okay, So this completes the configuration of this project structure. Now I'll go to my terminal. So this time I'll just go ahead and say RASA train. Now once I press the enter key, okay, so I just have to activate it. It looks like away from the same. So RASA-demo. Now I'll say RASA train. So this is going to again initialize the training for me. So it's going to do the training. Now it says we are having an error in the domain.yaml file, and it says at a specific line we've got an error. Okay, let's go ahead and fix it in domain.yaml file. So it says at this point there is an error. So let's go ahead and fix it. So the type is text. I think this is looking fine. The slot is the under the slots we have got the person. Okay, there is a colon missing. That was the issue. Okay, now let's go ahead and retrain it. Okay, now everything seems to be working fine, and currently it has begun the training with my existing data. Okay, so the model training has been completed and we have got the saved model in the slash models location. That's great. Now let's go ahead and test the chatbot. I'm going to say RASA. Okay, now you can observe that it clearly says there's a RASA server running over here at this location. So what it says is there is a RASA server that is running. Let's suppose if you visit this localhost 5005 port, you're going to get a confirmation that says hello from RASA, which confirms that the RASA server is actually running. Now this is a RASA server which actually going to take the input from the user. Okay, so that's what it does. It's actually my NLU server. So here we've got the RASA and now it says the bot has been loaded. So let's go ahead and start having the conversation with the bot. So this time, let's not waste any more time. Let's go ahead and test the new training data. So I'm going to mention something like this. I'll say my name is Murthy and I'll press the enter key. Now once I press the enter key, okay, it has got the input from me, but it has not generated the output. So let's go ahead and let's check what exactly is the issue. So it says my name is Murthy. Okay, let's go ahead and mention it in this way. My name is Murthy. Okay, it looks like we are not getting any output. Let's go ahead and fix the issue. The reason that is not like we are not seeing any output because it looks like the stories.yaml file which I have got, I have not saved it. There are some unsaved changes are present. So I have to save it so that the RASA can understand what should be the action it has to perform. So let me just go ahead and stop the conversation and I'll again begin the retraining of this model. So I'll do the RASA train and then I'm going to initialize the chatbot. So I'll see you once it's completed. So this has again performed the training. I'm going to call the RASA shell. Great. Now the model has been loaded. So this time I'm going to say my name is Murthy. Now I've got a response. It says, wow, good to know you, Murthy. Now this time I'll say my name is Kavya. It says, wow, good to know you, Kavya. That's great. Now I'll say I am Diksha. It says, good to know you, Diksha. It looks like the Diksha is not identified. So maybe I'll have to come up with some sort of more data which will help it to understand the same. I'll say I'm Jack. Okay, it says welcome dear Jack. That is great. And did you observe the cool thing? This time, instead of saying I apostrophe M, I have mentioned as I comma M Jack. And it was able to understand this is exactly the name that I've got, and it is able to extract it from my given data set. Okay, so let's assume I'll take one more example. So it looks like it's not very well trained yet. We'll have to come up with some sort of a way to train this model with more amount of data so that it can understand and look into the various scenarios. So at least what we are able to validate is that from this nlu.yaml file. So if I mention the data in the format, so it is able to extract the data, and then using the slots it is able to save it over there, and whenever it is generating the response, it is generating the response by storing the value, by showing us the value which is stored in that slot. So this is how we can extract the entities, and after we have extracted the entities, we can actually use it for further processing. Now in this example, I have just made use of that entities to display the same as an output. Now, what we are going to do in the next video is, in the next video, we are going to take a step ahead. Now, when I say taking a stepping ahead, it means I'm going to get the input from the user. And once I get the input from the user, this input will be processed. And it is going to call a third-party system to respond the same. So the activity that I'll be performing right now is I'm going to get the input from the user. Now, once I get the input from the user, I'm going to visit to the New York Times website. And once I visit this New York Times website, from there, I'm going to extract the news articles from the New York Times website, and I'm going to generate as a response to my end user. Now, in order to do that, we should be able to write this actions.py file. So we will learn how to create all those actions in the next video. So I'll see you next time, where in the next video, we'll go ahead and have a deep dive into the same. And more importantly, we'll do a prerequisite which is required for us to build this action server, that is creating the API from New York Times website. So I'll see you next time. Now in this video, I'm going to show you how you can create your developer account in the New York Times website, which we will further use this account's permission to read the data from the New York Times site. So as we proceed in this video, we will see how we can create a developer account, and we are going to note down the API key. And at the end, I'll also show you the basic hands-on that we generally perform with the help of the API key. Now, this will serve as a foundation for you when you start coding it for your chatbot application. So let's get started. So as part of the step 1 of this video, you'll have to create a developer account with the New York Times site. So the URL is developer.thenytimes.com. So let me just go ahead and show you the same. So I'll directly go to this site. I'll copy this URL and I'll paste it in my search bar. Okay, now once I'm in this site, I'll go ahead and perform the activity of sign up. Now, if you're logging in for the first time, just go ahead and click on the sign in button. And in this screen, you'll have an option to create an account. So since I'm already having an account, I'll just go ahead and log in to the same account. If you do not have an account, click on the create an account, specify your first name, last name, email ID, and the password. Once that is done, you're going to receive an email communication requesting for the confirmation. Once you do that process, you'll have an account ready. Now, once the account has been completed, go ahead and log in with your email ID that you have just created. So let me do the same. Now, once you're logged in, here you'll have to go ahead and click on your account. In my scenario, I have logged in with my email ID. Next, from here, I'll click on the application. Now, in order to generate a new thing, that is new API for you, click on new application. Now, in this scenario, just specify the app name. I'll say RASA Chatbot NLP. That's the app name that I'm going to specify. And you can mention any description as you would prefer. Then here, you can go ahead and enable all the APIs that you would require. So for the demonstration purpose, I'm going to enable all the APIs. So you can go ahead and learn more about the same from this developer's website. So for now, I'm going to enable everything. And once I enable everything, I'll click on save. So this is going to create a new app for us. Now here, this has generated an API key. So you have to note down this API key. Now in my scenario, I'll just go ahead and note down my API key. Okay, so I'll just copy and I'll note down over here. And it also describes a secret. I'll just copy the same. Okay, so go ahead and do that for your scenario as well. Now, in case if you lost it, just revoke this key API key that you have generated, and you can create a new API key as well as per your preference. Once everything is done, just click on the save button. Okay, in this way, you have to create an app and you have to note down the API key as well as the API key secret. Now I'll show you how you can further use it and test everything. Okay, now the next thing that I'm going to do right now is we'll go ahead and test it whether we are able to access it or not. So in order to do this testing, so I'm going to start a new Google Colab notebook. Now in this new Google Colab notebook interface, I'll say create new notebook. You can also test the same using the Jupyter notebook as well. So here I'm going to say URL test ny times. Okay, in order to run this URL testing, I'll make use of import request and I'll also import JSON. Now here, to read the data from the New York Times website, I have mentioned the code in this format. So I have mentioned the URL. Here the URL is nothing but the API that from which I can fetch the data. So this API information, I have actually got it from the documentation page of this New York Times site. So this is the official documentation page of this New York Times developer site. Now we are interested in the Times Newswire API. Now this is the API. So with this Newswire API, it says we can actually get the links and the metadata for the Times articles as soon as they are actually published on this NewYorkTimes.com. So it provides an up to the minute stream of the published articles. So we can actually perform the filtering, and these are all some of the example calls. So from this example calls, so we have actually been inspired and have written a code in this way. So what we are going to do is, for the demonstration purpose, I'm going to select the category as technology. So in place of category, a technology will be filled. So this is the same API that I've seen earlier. Now along with that, I have mentioned the API key, and for this API key, I have mentioned the API key which I have noted down earlier. So this is my API key. Next, in order to get the data, I'm making use of request module get method. We'll specify the URL along with the parameters, and from there I'm extracting the text, which is a property. Next, I'm converting the outcome into the JSON format using the JSON module. So I'm saying that JSON.loads response result. Now, once I execute this code, and if I now display my JSON data, so this is how the process data would look like. So I've got the various information, I've got the slug name, I've got the section, in which section the specific news article has been published, and the title is 2022 Good Tech Awards, and it also sees the URL. Let me get the URL. If I click on that URL, it takes me to the New York Times page. So currently it is asking me to subscribe, but if you have the subscription, you can also go ahead and read the complete article, and it mentions everything over here. Okay, we have got the multimedia, so we've got the complete information of the news article. So likewise, we have got a top 5 news. The reason I'm saying it as top 5 news because we have mentioned the limit as 5. So in this way, we can get the response from the New York Times site. So this confirms that the API that we have that we are actually calling, it is working, and the key that we have generated for this purpose, it is also working as expected. Now with this system in place, we will go ahead and implement the action server for the chatbot, where I'll get the input from the user, and this input will be in the format of the category, that is a news category. And then using this news category, so I'm going to generate the top 5 news headlines in that specific category. So we'll implement everything in detail in the next video. So see you next time. In this, we mention it inside this actions.py, and they have also mentioned some guide on how to implementing these action. So let's go over there into the official documentation. From there, I'm going to explain you the important parts, and then I'm going to uncomment this actions.py file. we are going to ensure that this action will be called whenever an intent has been identified. So we'll include it in our training data set, we'll include it in our stories.yaml file, we'll then include it in our domain.yaml file. We are going to test it whether the action is getting called or not. So let's go ahead and I'll open the official documentation page. So this is the official documentation page of RASA. Here, when I say action, so it says after each user's response, the model is going to predict an action that an assistant should actually perform the next. So we've been already dealing with these kind of action. So actions are nothing but what exactly the bot has to do. Now the actions can be of two types. One, it can be a response, and the other one is a custom action. Now apart from this, we also have forms, default action, and slot validation action, which we use it as per our business requirement, but these two are the most commonly used actions. Responses are nothing but the text response, which is the response that my bot will send for my end user. Here, this is what we have implemented in our scenarios till now. So if I open back my project structure, inside my domain.yaml file, we have specified how does the responses would look like. Okay, so this is what we have done already. Now we are interested in custom action. Now, when I say custom action, a custom action is an action which can run any code that we wanted. So here using this, we can also make an API call, or if required, I can query a database, or I can post some data to the other data. So I can do all those things with the help of custom action. Okay, now while implementing this custom action, so we'll be using a dispatcher. Our dispatcher is an instance of the collecting dispatcher class, and we use it to generate the responses back to the user. So whenever I perform a third-party action, that means, let's say I'll get the input from the user. The input can be information about the hotel booking, the date and time, and how many number of people who are actually coming. Based on those details, I have to call to my third party server, which could be my booking server. Now the booking server is going to generate me a response saying that booking completed. Now in order to give that response back to the end user, I'll be using this collecting dispatcher. So in this collecting dispatcher, it has got a method that's called as utter message, and we use it to send the message. It can be a text message or it can be an image, so we can specify as per our requirement. The entire thing is available inside this documentation page. Now, once I create this actions.py file, it clearly explains that we have to run this actions file. In order to run the actions file, I have to go ahead and run the actions separately. Okay, so I can simply say RASA run actions. So this is going to run the actions over there. So this would ensure that the action server will be running and it will be connected to the RASA server. So you'll see everything in detail as we progress in the learning journey. Now that you have the basic understanding of this RASA actions, I'll open up the project structure, and we are going to work with this example actions.py file that has been shared to us. Now this is an example which is going to utter hello world when I call this custom action. So I'm going to uncomment this entire code. So once I do this uncomment, so let's have a look into this example. So from typing, I'm importing this any text, dict, and list. From RASA SDK, I'm going to import the action class, tracker class. Along with that, I'm going to import the collecting dispatcher, which I've explained just now. Now, once the import has been completed, in order to implement the RASA over here, especially whenever we want to implement the custom action, we implement the custom action with the help of a class. And this class will inherit from the action class. So here in this example, we are creating a class called action hello world, and then this is inheriting from the action class. So here this is inheriting from the action class. Now once I inherit the same, I have to override two methods. One is a name method and the other one is a run method. Run is something which will be called where we'll be writing the code about the action that I want to perform, and name is a method where we are going to define the action name. Okay, here in this example, def name self, that means only object will be sent as an input, and this is going to return the text, which is the action hello world. Okay, so this is returning me the action hello world. Here under the name method, we have to specify the action name, and you might have clearly observed the way that we are going to define the action. In case of just message, we are going to use the terminology of utter. Now whenever a custom action is being performed, we will specify with the terminology called as action underscore and then specify the action name. Here the action name according to this class is action hello world. So are you with me? Excellent. Now observe the run method. Now in this run method, so this takes the self and collecting dispatcher, and it also takes the tracker and the domain. Now here inside this run method, so I'm making use of dispatcher and I'm sending a text message that says as hello world. That means when I call this action hello world, the custom action, at that time I'll be just generating the output as hello world. So this is a very simple implementation of this action. So utter message, I'm just uttering the text message that is hello world. Okay, so that's a very simple thing. Now I'm going to save this file. Now once I save this file, we'll have to include this action into our stories. Now what I'm going to do is, in order to generate this action, so I'm going to create one more intent. So I'm going to mention the intent like this. I'll copy the previously created intent, and this time I'm going to say get action. Okay, that's the intent that I'm going to specify. And for the training example, I'll specify a training example that says as run test action. I'm going to say example action. And I'll give you a few more examples which says run the test. So I'll just mention these three examples as a training examples. I'm going to save this intent.yaml file. Next, for this intent, I have to specify the action, that is my test action that we have created earlier. So I'll mention it inside a story. So I'll copy this story and I'll specify my new story. I'm going to say run example action. That's the story name that I'm going to specify. And for the intent, get action. And for the action name, so we have defined the action name as action hello world. So we have modified and we have mentioned it inside this stories.yaml file as well. Now this doesn't end here. We also have to update the domain.yaml file, which means I'll have to come to this domain.yaml file. So let's go to the documentation page so that you are in sync. So here, if I come to this page of domain.yaml file, there's a new section that's called as action, and under this we can specify the actions. So I'll copy this and I'll paste it in my screen. Okay, and I'll just modify the action name. So in my example, the action name is action hello world. Okay, so I'll have to define my action, that is my action hello world, in this format. Okay, so let's go ahead and perform the training. I'll say RASA train. Okay, now once I perform the training, okay, in parallel we also have to change something. That means we have to run the RASA action server. It looks like there is an error at line number 43. Let's go over here and it says line number 43. It has got an error. Let's validate it. Okay. So I have just validated over here in this yamlchecker.com. So it looks like there were the additional spaces. So let me show you how I have actually fixed it, and it will come in handy for you as well. I've just copied it and have pasted over here in this YAML checker, and it says there's an issue over here with the indentation. So what I did was I just added spaces over here, and once I added the spaces, it just sorted itself automatically without any issue. So I'll just copy it right now and then I'll paste it in my stories.yaml file and I'll save it. Okay, now let's go ahead and run the testing again. So RASA train. So I hope this gets completed.
Okay, so this has started the training, and now I'm getting an error that says key story was not defined. So let me fix once and for all, and I'll show you the complete fixes that I have done. So now it has resumed the training, and the issue was there was additional spaces, like it was not starting at the end. So there was some additional spaces at the start. Hence we had an issue earlier. Okay. Now that it's sorted, the system is currently performing the training. So let's wait for the training to complete. And in the meantime, I'm going to open one more terminal here. I'll go inside the specific folder. First, I'm going to activate the same. So once I activated my RASA chatbot, next thing that I'll do is I'll go inside that folder. Now here, being in this folder, in order to run the action server, I'll say RASA actions. Okay, so RASA run actions. So this is going to start the action server. And now here, now once I specify the same, I'm able to run the action server. That is looking good, and the action server is currently made available on the port 5055. Now that is great, but it looks like there's another error that I have got while training. Now let me show you what is the error. It says, the error says it is unable to find the get action in the list. The reason is, if you observe, I have created an intent called get action, and it is unable to find it in this domain.yaml file, which we have missed to add it. So I'll save this. Now everything is looking good, I hope. Let me retrain it again. I hope this is giving you the overall information as what are the things that you have to avoid and what can go wrong. And trust me guys, especially when you're building very big production project, you will definitely come across all these kind of issues. Ensure that you practice a lot. Take up a use case with the business that you're working with and try implementing your own chatbot. That will expose you to a lot of technicalities that are available in the RASA module. And if you are stuck somewhere, do let me know in the question section. I'll do my best to help you and guide you as much as I can in your learning journey. All right. So now it says the model has been trained. So that's great. Now I'll say RASA shell. So once I mention this RASA shell, so it's going to initialize my bot and I can chat with my bot. Okay, now I'll say, hi, my name is Jack. Okay, that's a very nice name, Jack. Nice to meet you. That means the entity part is working as expected. Now let's see whether we are able to generate the action. Now to generate the action, so let's have a look into our nlu.yaml file. It says test action. Let me just give that command right here. Run test action. Now once I press the enter key, so it says it has encountered an error. It says encountered an error while running the action. Okay, action hello world. The bot will continue the action. That means the system has got an error while running this action hello world. Let's have a look into our scenario. So action hello world, this is described correctly in the action hello world. And let's have a look over here. And we have the action hello world, which is clearly mentioned correctly. Okay, and let's have a final check in the domain.yaml file. So we have got the action hello world. So this time we are getting the different error. So if you look into this error, it says it has failed to execute the custom action because no endpoint is configured to run this custom action. So this time it's a different error. Now that's a good thing. Now this error brings us to the next important file whenever we are working with RASA, that is the configuration of the endpoints. Now here in the endpoints, so I have mentioned that the RASA action server is running in the port of 5055. Now how do I let my NLU know, that is my natural language unit know, understanding unit know that there's an action server that is available for it? Well, I have to specify it under the endpoints.yaml file. If you look into this scenario, there are various endpoints that are available. Now in this scenario, I'm going to uncomment this action endpoint. Here, the action endpoint is available in the port of 5055. Okay, I'm just going to uncomment this so that my action endpoint can be used. Okay, now I'll just go ahead and I'll stop this scenario. Now once I stop this RASA, then I'm going to say RASA shell. Okay, that means I'm reinitializing my RASA again. I'm hoping that this doesn't require the retraining. This time I'll mention the input as run test action. I'll press the enter key. Wow, this time we have got the response from the action server and the output says hello world. And if I go over there to the command window of the RASA action server, which is currently running, so there's no log over here. I think it clearly means that we have not configured anything for the action server. Okay, so let's assume, just for the fun purpose, I'll show you here. Instead, along with dispatching, I'm going to say, so I'll say I have got a request from NLU. So I'm going to print a simple message that says as I've got a request from NLU. I'll modify this actions.python file. I'll come over here. I'm going to stop this, Control C. Okay. Then I'll simply run the same command, rasa run actions. Now it is available right now at this endpoint. Next, I'll just go ahead and run the same rasa test run test action. I've got the output as hello world, and if you look it over here, I've got a text message that says as I've got a request from NLU. Now, no, each time when I get an intent, and this intent, whenever it is calling the custom action, I'm able to see a text message over here appearing over here. It says I've got a request from NLU. So this confirms that my NLU server, that is my RASA server, is able to interact with this custom action server, and it is able to get the response back from this custom action server. In order to enable this, so we have to enable the endpoint in this endpoint.yaml file under the action endpoint, and then we have to ensure that our domain.yaml file contains the action mentioned over here. And in our scenario, there were a few minor mistakes. That means we have created the intention, but it was not mentioned in the domain.yaml file. So those things will definitely happen when we are writing the complex project, but I hope you have learned by my mistakes, and you're going to correct it and ensure that you don't do those mistakes while you are implementing at your end. All right, folks. So this was about creating the custom actions as per our requirement with the help of RASA. Now with this, we come to the end of this video. Now in the next video, we are going to combine the learning that we had from the previous video, that is usage of New York Times site, and the action server that you have learned today. We'll combine everything. We'll get the input from the user. We'll extract the entities, and then we are going to call the New York Times site, get the response from the New York Times site with the help of the action server, and display it in the interface for us. So that's what we'll be doing it in the next video. So I hope to see you next time. In this video, we will go ahead and build our own custom action file. So as we proceed in this video, we will see how we can build our own custom action. Now this time, the custom action will be able to get the category information from the user, and using that category information from the user, we are going to call the New York Times API, and we'll get the response and we'll display that response to the end user. So we'll have the intent identification, entity extraction, then calling the custom server, and once we receive the response from the custom server, we are going to send it as a response for the end user. So this will help you to connect back all the things that we have learned till now. So let's go ahead and let's begin this exciting journey. I'll open up my project directory. Now in order to work with the same, so as I have mentioned earlier, we are now displaying the custom action. So let's go ahead and come back to our actions.py file. So that's where I'll be starting my implementation. Now for this actions.py file, I'll copy the existing class over here and we'll modify it so that it's easier for me. So the name over here I'll say is ny times action. Okay, that's the class name that I'm going to create, and this is going to create action get news. Okay, that's the action that I'm going to create, action get news. Okay, and here this is a run. I'll keep it as it is. Now what I'm going to do right now is,
for the tracker, that is from the tracker, I'm going to get the current slot. So I'm interested in getting the slot, which is my category. I'll say category is equal to tracker dot get underscore slot. Now here for the slot value, I'm interested in getting the category. Now what exactly it is category? So I'll create a separate entity itself as a news category. I'll get that news category over here. Okay, so this I haven't defined it, so I'm going to describe it at a later. I'll define a new slot as news category, which will connect to my entity that I'll be extracting from the user input. Next, for the confirmation, I'm going to print the same. I'll say identified news. I'm just going to describe the category value that has been identified from the user input. Next, what I'll be doing is I'll be using the same code that I have used earlier. I'll just copy this code over here and I'll paste it here. I'll adjust the indentation. Okay, so we are calling the API URL and format category is equal to, this time instead of a specific value, I'll say category is equal to category. That's it. And we'll specify the API key, request parameter, it will stay as it is. It will get the JSON data. And once I get the JSON data, I'm going to create a for loop. So I'll say for I in range. Okay, so let's do it in this specific way. Okay, for I in range, instead of I in range, I'm going to initialize it in this specific way. I'll say counter is equal to 0 for each news in JSON underscore data. Okay, so what I'm going to do is I'm going to increment the value of by 1. Next, I'm going to say message, which is nothing but my output message, is equal to, here I'm going to specify in this way. I'll say string. I'll convert this counter. So this is just for the formatting purpose. I'll say dot. Okay, and for the data, that is my each news, I'm going to extract the title. So why exactly is a title? See, let me just show you how the output would look like. So this JSON data contains everything. It contains title, it contains abstract URL, and it contains everything. So currently I'm describing the value and the title, and we'll also include the section as well. Just for the fun, we'll include the section, and we'll also include the publish date. So we'll get all this information and we will mention it over there. Okay, so I'll say each news under the section, and here to get the section, I'll say each news, instead of title I'll get the section. Then I'm going to add some more message. I'll say, okay, it was published on, and I'll say each news, okay, published date. Let's validate it since we are doing the experimentation. So this is the published date. Yes, the key is looking good. Okay, so I'm just saying that for each and every news, I'm saying the news headline. After that, I'll mention some sort of a symbol. Under the section, I'll mention the section name. Okay, and I'm also mentioning its published date. So for each and every string data that I'm getting over here, I'm going to dispatch this to my end user. Dispatcher.utter message for text is equal to, I'll mention this output underscore message. Okay, so in this way, I'll be generating the output. Next, this will complete my actions.py. So one thing is for sure that we have to keep in mind that there's a new slot that I have to create, which is my news category. So let me just go ahead and create it right away so that we can refer it at a later point. So I'll go to my domain.yaml file. I'll copy this person that we have created earlier. And instead of person, this time it's actually the name is news category. Okay, so news category type is text from entity and the entity name is news category, which brings us to the next thing, that is definition of my news category. So since we are talking about this entity, I'll define this entity over here to avoid any issues. So I have defined my entities and I've also defined the slots. Now this is looking great. Now let's go ahead and get the intents, and here while specifying the training examples, we'll also extract the data for the entities. That means we will help the model to extract the entities by creating the data. So here for the intent, this time I'm going to specify the intent as get news. Okay, that's the intent. Now let's go ahead and create some training example and annotate it for the entities as well. So I'm going to say share some news around the world. Okay, and this belongs to the entity name of news category. Let's validate it. Yes, news category, that's my entity name. So this is my news category. Then I'll say what is cooking in food. Okay, this belongs to the news category. In the same way, I'll mention one more example. Let's say who is winning in sports. Okay, so sports, and it's also a news category. Okay, and who is profiting in business. Here also I've assigned a category. So we've got word, food, sports, business, and let me ask what is trending in fashion. So here I'll get the details from the fashion category. So I have also created my training data with the annotation. So the new intent that is created is get news. So let's go ahead and add it to our domain.yaml file. So get news, the new intent has been added. Now let's go ahead and add it in our stories as well. So here for the story, okay, and for the story, I'll write it like this: get news from NY Times. Okay, now under this story, we'll have the steps. So the first one is the intent. What is the intent? It's the get news, and the action it has to take. The action is get news. So we have mentioned the action as action get news. Now once this is done, let's come to this domain.yaml file and let's validate. So under the intent, we have mentioned the newly created intent. Under the entities, we have the newly created entity. Under the slots, we have defined the slot. Under the action, yes, here I'll have to mention my custom action that we have defined earlier, action get news. So we have got the responses. So now everything is looking good. So let's do one thing. I'll stop the video over here. In the next video, let's go ahead and perform the training and let's test it whether it is working as per the expectation or not, whether it is working, whether it is able to call that New York Times server, and how the output would look like. So I'll see you next time. In this video, let's go ahead and test the action server and let's see whether we have configured everything correctly or not. So in order to do that, let's go ahead and open up our terminal, start our project, and let's see whether it's working expected or not. So I'm going to stop my previous instances right now, and then I'm going to retrain my model. So before that, let me validate whether I have saved all the files or not. So I have saved this, saved this, saved this, saved this, saved this. Yes, everything is saved. So let's come over here. So here, in case if you require, okay, you can actually run both the servers in the same command prompt. The reason that I'm running separately because
I want to see how exactly it is working. So I should be able to demonstrate you so that you should be able to see that, okay, there is an NLU server which is separate and there is an action server which is separate, and there is a connection that is happening between two. So in order to show you the demonstration, I'm actually doing separately. RASA train. Okay, this will do the retrain. I'll say RASA run actions. This is going to start my RASA action server. Okay, now it says it has registered the function for action hello world and action get news, and the action endpoint is up and running at this location. Now let's wait for the model to finish the training, and once it has completed the model training, we'll go ahead and we'll start interacting with this model. The model training has been completed. I'm going to start the RASA. So RASA shell. So the RASA server is currently running. It is loading the model. So everything is looking great as of now. Okay, now the bot has been loaded and it is asking me to enter the input. Let's go to the nlu.yaml file and let me just provide some inputs over here by referring over here since I am interested in checking. So I'll write it as what is trending in fashion. I'll press the enter key. So it says it has encountered an error that while running the action get news. Okay, what's the error this time? The error is, so it's an internal server error. Okay, so it looks to be the fashion category is not available. I mean, that could be a reason. Okay, let's go ahead and check with other category. Okay, let's see if that is going to help us or not. Okay, so along with that, if I check over here, it says request is not defined. Okay, it's not exactly the fashion. It's because of the request module. The name request is not defined, which means we have done an error in this actions.py file. So we are actually making use of request module and the JSON module, right? But I'm not importing it. So import request. Okay, and along with that, we also have to import the JSON. And apart from these two, okay, you also have to ensure that you have both the modules present in your local system. So that's another thing that we have missed. So I'm going to stop the action server because that is where the issue lies. So here I'm going to install it first. So I'll say pip install request to validate that whether I've got the modules present. So it says it's already present. Pip install JSON. Okay, it's fine. Let's go ahead and run the action server. So now the action server is pointing. So I'll mention the similar output this time. I'll say what is latest in fashion. I'll press the enter key. Now it says identify the news category as fashion. Now this is an ultimate thing, guys. So just observe right now. I've got the output. It says 8 important moments responsible fashion this year, and this has been published under the fashion, and it was published on this. Okay, so we are seeing the output as per the expectation. Now, isn't this an amazing thing? Now I'll say what is cooking in cooking. Okay, so it looks like it was unable to identify what exactly was the category name. Okay, and we could see the same. It says it has identified the news category as fashion. So let's go to the nlu.yaml file. I'll say what's cooking in food. Okay, that is how I have to mention. So I'll say what is cooking in food. Now I've got top 5 news in the food category. So which means I'm able to identify the intent, and this intent is actually understanding as what is the next action it has to trigger. And in my scenario, the next action is the custom action which has been found by running this custom action server, and this custom action server has called the New York Times server, got the response, and I'm seeing the output for my chatbot. All right, folks. So this is the complete end-to-end implementation of this RASA chatbot. Now, before we get started and take a step ahead into the deployment, so I want to take some time and I want to give you a quick walkthrough on the RASA pipeline file, which is working in backend to ensure that the text is getting processed in a required manner. So let's discuss about the RASA pipeline file in the next video. In this video, let's explore about the configuration.yaml file. So as we progress in this video, let's learn in detail about the configuration and the pipeline that is being used in RASA framework. So let's get started. In order to learn more about the same, let's open up our configuration.yaml file in the RASA project structure. And from there, I'm going to explain the important parts of this RASA file and how it is actually helpful for us and what is the core principle behind the same. Now, this configuration.yaml file. So this basically contains two things. It contains my pipeline as well as the policies. Okay, so this is a basic example of this configuration.yaml file, and you can observe most of the values over here are actually commented, but these are all the default values that is being used whenever we are training our NLP model, that is our RASA model. Okay, so at the top I've got the language. Okay, and this is followed by a pipeline. Now here we have got some various things. We've got white space tokenizer, we've got regular expression featureizer, lexical syntactic featureizer, count vectors featureizer, and we have got character WB and minimum n-gram to maximum n-gram, that is 4, and we have got the diet classifier, and followed by we have got entity synonym mapper, response selector, and we've got various things which has been set as default. And under the policies, so we have the mention like memorization policy, rule policy, unexpected intent policy, and we've got TED policy. So these are all the various values that we have got in this configuration.yaml file. So let's understand each of these. So let's start with pipeline. So here, when we talk about this pipeline, there are various types of components which you can actually find in this pipeline. The main ones that you would find are tokenizer, featureizer, and then you'll also observe something called as an intent classifier as well as the entity extractor. So these are the four things that you would observe in this pipeline. Now let's talk about this tokenizer. Now in order to explore this tokenizer, I'll open up my OneNote and let me explain this scenario. Now, when we talk about this tokenizer, so what is a tokenizer? A tokenizer is something which will help me to split the text into components. So this is the first step in my RASA pipeline. So it is going to split my utterance. Okay, this is going to split my utterance into smaller chunks of text. And this is what we known as a token. So this has to happen before I perform the feature engineering. Okay, hence you will observe the tokenizer being at the start of the pipeline. Now to give you an example, if I've got a message that says as hi, my name is John, then when I apply my tokenizer, it will be applied like this. As you can clearly see in this example, so I have splitted my entire text into individual tokens. So this is what we call it as a tokenization step. And this you are aware of it already. Now once this step is complete, you are going to make use of featureizer. Now featureizer is nothing but once I have the tokens, I can start adding the numerical values so that I can apply the machine learning model. Now the role of this featureization is to convert these tokens into a numerical format. Now here when it comes to representing these features into numerical format, we've got various methods. We've got the count vectorization method, and this is a sparse representation. So these are called as a sparse features. And you are aware about this already as why do we call this sparse feature. And apart from that, we've got the dense feature representation. In this dense feature representation, you can think of it as usage of word embedding model. Now it can be a word embedding model from the Spacey library, or it can be a language model featureizer from the Hugging Face library. So I can use all those representations and convert my text data into a numerical format. So whenever we are working, so we have to ensure that whatever the tokenizer that we are performing, that we are actually using, that should be in sync with my featureizer. The reason is, if I'm using a featureizer which is specifically from Hugging Face library, then at that time ensure that you mention your tokenizer so that you can effectively apply the featureizer. And whenever we are working with RASA, so RASA applied these featureizers to all the tokens, but along with that, it also generates the features for the entire sentence. And this is commonly referred to as CLS features or the sentence features. Now, historically, the token features were actually used to extract the entities. Now, these sentence features were used to detect the intent. Now, with the help of this diet algorithm, which is a latest algorithm from RASA, so this has actually changed in reality, but it's good to know. Okay. And apart from this featureizer, you're going to observe the intent classifier. Now, intent classifier is the one which is responsible for classifying my intent. So once I've generated these features, that is in the numerical format for all the tokens and even for the entire sentence, I'm going to pass it to my intent classification model. And here for the intent classification model, RASA recommends using the diet classifier. Now, this is the diet classifier model from the RASA library itself, and this can actually handle both intent classification as well as the entity extraction in a much better way. And the best part is it is also able to learn from both the token as well as the sentence features. So I'm going to send these features into my diet model. Okay, so I'm going to send these features into my diet model, and this will help me to extract both intents as well as my entities. Then apart from this intent classifier, you'll also observe something related to my entities that we call it as an entity extractors. Now, even though this diet model that we have got, it is capable of learning how to detect the entities, it's not always recommended using this for every type of entity out there. For example, if you have got an entity which follows a structured pattern, then RASA recommends that instead of using the machine learning based model, go ahead and implement the regular expression. So at that time, you can make use of regular expression entity extractor. So this will be computationally much faster and you will not be dependent on the machine learning model to perform a simple task. And apart from that, you can also check the documentation regarding the duckling entity extractor, or you can also consider using the Spacey entity extractor as well. So you can check out based on your use case, you can check out the documentation for all these methods and use the one which is suitable for your use case. Okay, so what we have got right now is we've got the text data. Using my tokenizer, I've generated my tokens. Using the featureizer, I've generated the features. Now these features that I've generated for both words as well as sentence, and using the respective classifiers, I have made use of the intent classifier to identify the intent, and I have made use of the entity extractor for extracting the entity. Okay, so that is what we have done. Now once we have done all these things, okay, we are going to generate an output. So the pipeline in RASA is a system that can turn an occurrence like book a flight from Berlin to Bangalore into a structured data. Now if I want to give you an example output, so the example output would look something like this. So this is the output from the RASA pipeline. We have got the text that says book a flight from Berlin to San Francisco, and the intent that has been identified is book flight. Okay, and these are the entities that has been identified. See, From this text, it has extracted the entities as well as the intents. Now, from this text, we have extracted the intents as well as the entities. Now that we have our intents and the entities, the next thing is how can we predict the next action? And that is where the policy comes into picture. So we have just learned that this pipeline is actually used to identifying the intent as well as extraction of the entities. Now, in order to do that, we'll perform the tokenization, we'll perform the featureization, then this is followed by intent classification and the entity extraction. Now, once I've got everything, this is going to generate an output which says what is the intent has been extracted and what is the entity that has been extracted. Now, this is followed by predicting the action. Now, what action it has to trigger, that will be decided by the policies. Now, whenever the system is actually predicting the action, it doesn't just look into the current intents and the entities. What it does is it will also look into the conversations that has happened so far. So it is not just going to simply just for each and every question, it will not just answer independently. It will remember what has happened in the past so that the user can get a correct flow as per the design of this overall chatbot. Okay, that's the cool thing about this RASA framework. Now, this RASA, it uses the policies to decide which action to take at each step in a conversation. And there are three main policies, and these policies are the rule policy, memorization policy, and the TED policy. Now, starting with rule policy. Now, this rule policy is going to handle the conversation which matches the predefined rule patterns. Now, in this scenario, it makes use of the predictions which are based on any rules that I have mentioned in this rules.yaml file. Now, if you look into this example, I have mentioned some rules. The rule says that if the intent is goodbye, it has to perform the action utter goodbye. So this is a predefined rule pattern. Okay, this is the one that it is going to follow the rules. If I specify any rule, so that will be the first preference over here. And that is what my rule policy says. And I've got a memorization policy. The memorization policy checks if the current conversation matches any of the stories in our training data. Now, if that is a scenario, it will predict the next action from the matching stories. So when the conversation is happening, each time the system is going to check my stories and it says, okay, it identifies to which story path it has to follow. Now, let me just give you an example. Here we've got two paths. One is sad path 1 and sad path 2. So till this step, okay, till these four actions, that is greet, utter greet, mood unhappy, utter cheer up. So these four steps are same. Now, depending on the user's intent, okay, till these steps, okay, so till these steps, utter did that help, till these steps, the actions are same. At that time, the system might still be confused as which is the path it has to follow. When the users provides the intent that it's an affirm, the system decides, okay, it follows the sad path, else it will progress with the sad path too. In this way, the system comes and checks in which story path it is going to follow, and based on that, it is going to decide what is the action it has to take. And apart from that, we have mentioned the TED policy. The TED policy uses the machine learning in order to predict the next best action. Now, these policies, they all make a prediction on the next action in parallel. And the policy which has got the highest confidence, that is the one determines the next action. Now, let's suppose if I've got two policies which has the equal confidence. Now, that can also be a scenario being it's a system design. Then in such scenarios, the RASA has a priority mechanism. The policy priority defines how assistant makes the decision whenever we have got the multiple policies, predicts the next action with the same level of accuracy. The default priority that we have got in RASA is, so we have the policy We have got for rule policy, we have got the priority as 6. Okay. And for memorization policy, we have it as 3. And for the TED policy, we have it as 1. Okay. The reason that we have got the rule policy and the memorization policy has the higher priority compared to my TED policy, because they are actually designed based on the input from the designer or the person who has created it. The rules and the stories which have been actually added are meant to be seen as the examples as how my overall conversation should go. The TED policy, it's a machine learning based one. So here it is going to try to generalize it so that we can handle the conversation which are not defined in our stories.yaml file as well as the rules.yaml file. Even though it's a great ability to have the ability to go beyond our own rules, but we normally trust our domain knowledge better than the statistical approximation that we generally get from a machine learning system. Okay, so this is the overall idea whenever we are working with this configuration.yaml file. So this was an in-depth explanation about this configuration.yaml file. I hope this has helped you. Now, if you want to modify something, you can just go to this documentation page. Let me just show you. So if I open the documentation page of this tuning your model, so here we'll get some information as well. So this is an example where a pipeline has been created for the French language. Here they have mentioned the language, okay, for French, and they have used the pipeline as spacey NLP, tokenizer, featureizer, and all these things that they have mentioned right here. So this is a diet classifier that they have used, and you can check out this official documentation page to understand how it actually works. Okay, so this was about the in-depth understanding of the various policies and the pipeline that we specify over here in this configuration.yaml file. I hope this has helped you. Now, as we progress in our learning journey, in the next video, we will see how we can deploy the RASA chatbot on a Slack channel. So it's an exciting learning journey, and I look forward to seeing you next time. Hey everyone, in this video, let's prepare a system so that we can deploy our chatbot and integrate it with the Slack channel. Now, in order to do this, there are some prerequisites that we have to do. One is we have to create a Slack account. And the another thing that we have to do is we have to install the ngrok. So let's get started, and let's start by creating a Slack account. Now, in order to create a Slack account, first you have to visit the URL. Let me open the URL directly. So the page that you need to use it to get started with the Slack account is this slack.com. Go to this slack.com, and here in this page, click on sign in. Now in this page, click on the create a new account in case if you do not have it. Now in my scenario, I already have it. So I'm going to mention my user ID, that is my email ID right here. So I'll sign in with my email ID, and it has sent me an OTP. So I'll just log in with my OTP. That's my one-time password, which the Slack has sent me. Okay, I have mentioned the code, and now it says it looks like you are new to Slack. That's great. So here I'm going to mention, I'll click on this button which says create a workspace. So through here, I'm going to create a workspace. So I'll say create a workspace. Now this is going to help me to create a workspace. Now it's asking me for the name of your company or the team. I'll say Manifold Layer Learning. I'll keep the default settings as it is, and I'll press the next button. And teammates ID, I'm going to skip this step for now. Okay. Next, what's your team working on right now? I'll say RASA chatbot. You can mention anything as per your preference. So this is what I'm going to mention right now, and I'll click on next button. So this has created a workspace for me. Okay, so this is the first thing. So we should be able to create a workspace. Now, once you have created your workspace, then we will be creating an application, and for that application, we are going to connect the RASA chatbot. So those things we'll be taking it up in the next video. For now, ensure that you create a workspace, and you should be able to see a screen that would look like this. Okay. The another installation which you are required to do is the ngrok. Okay, in order to install this, you have to visit this website, ngrok.com/download. So let's go directly over there. I'll do a Google search, ngrok download. So from here, I'm going to download the ngrok. So since I'm using the Mac OS, I'm going to follow the installation steps that is mentioned right here. It says brew install ngrok/ngrok. I'm going to launch my terminal. So here I'm going to install the ngrok via homebrew. So I'll copy this command and I'll paste it in my terminal. So this is going to install the ngrok for me. Ngrok was successfully installed. So what we have done as part of this video is we have actually created our own account in Slack, and we have ensured that we have the ngrok present in our local system. All right. So with this, we come to the end of this video. We'll take our deployment journey in the next video, where we will see what are the settings that we have to perform in order to integrate our chatbot and deploy the chatbot which is present in our local system and integrate it with the Slack channel. So I'll see you in the next video. In this video, let's see how we can run the ngrok with RASA chatbot. Okay, let's see how we can run this in Grok with the RASA chatbot. So in order to do this, so the main intention of running this ngrok with the RASA chatbot, because currently the chatbot that I have got, it is exposed and it is present only in my local system. Now, if I want to expose this chatbot to the public system or to a specific URL at that time, then we'll be using this ngrok. So that's the main intention of doing this. So it is like deploying to a URL. So if you check out the documentation page of RASA, here we've got the information as how you can connect the RASA. Okay, it says how you can connect the RASA to a specific channel. It says if you're running the RASA server on the local host, so most external channel won't be able to find your server URL. That's true, isn't it? Now let me just go ahead and tell you what exactly that they're trying to mean. So here, if I say RASA shell, so currently this RASA shell, okay, so it will be running only in my current local server, the local server of 5005. Okay, it is actually hosted in this local server of 5005. So once it is deployed, I can access that RASA which is running on the port 5005. That means it is available only from the local perspective. So the person, that is you as a user, if you try to enter that URL, you'll not be able to access my chatbot. Now that's the problem that we have got. So if you want to make the port on our local machine to be publicly available on the internet, we use this ngrok, which we have seen in our last video. So let's go ahead and see how we can go ahead and run the same. So in order to run the same, we just have to run the command ngrok http 50 rasa run. So I'll just copy this command and I'm going to specify the same right now in my command line interval, that is in my command line interface. So ngrok http 500 run. So once I press the enter key, so I've got the output, and now it says the session starts. Okay, right now it is available, and this is the web interface, and it is forwarding to this URL. Okay, and whatever it is running right now in my local host, the 5005 port, so that, like, if someone enters this URL, okay, if I enter this URL in my web browser, so it will be able to connect to my RASA server which is running over here. Now currently I'm getting an error because the RASA is not actually running. So to show you what it is happening, I'm going to open a new tab over here. I'm going to say I'll go ahead and activate my Conda environment. Conda activate RASA chatbot. I'll go to my project folder. Now RASA shell. So this is going to start my RASA server, and this RASA server will be started on the port 5005. So what it actually does is this ngrok, whatever the request that I get from this URL, okay, it will be forwarding that request to my local host of 5005. That's it. That is what it is going to do. So we got an error because
there is no service running at the port 5005. Now that was the issue, and we are able to see right here it says connection refused because there is no service. The ngrok agent is working, but the service is not working. So let's wait for the service to come up, that is our RASA chatbot. Now we can see that the service is up in the localhost 5005. Now that is great. Now if I refresh this, so I've got a response right here. It says hello from RASA. Isn't this amazing? So if you look into this ngrok here, I've got the status as 200. Okay, that means there was a request that actually came from my device. Okay, and it is able to generate the response to that request. Hence, we've got the status as 200. Okay, if I refresh it, so this means whatever the RASA server that we have got in the localhost 5005, it has been able to access through this URL. Okay, now that's the best part of using this ngrok. Now with this ngrok setup in place, you are now ready to connect the Slack channel. So I'll stop the video over here. So I want you to ensure that your system is also ready in order to do this activity. So ensure that you set up your system so that in the next video, I'll show you the next steps as how we can connect this ngrok to the Slack. So I'll see you next time. In this video, let's see what are the settings that we have to do in the Slack so that we can have an active connection between my RASA chatbot and the Slack application. So let's go ahead and do the same. Let's set up the Slack application so that it is able to connect to my RASA chatbot. Now, in order to do this activity, so we'll refer to the official documentation page from RASA. So here we've got the information under the channel connectors RASA. It says connecting a bot to Slack requires you to configure it so that it can send the messages using the API credentials, and it also has the ability to receive the messages using a webhook. Okay, so to receive the data, we would require a webhook, and to send the data, we will be requiring the API credentials. So which means when we are building and configuring the Slack, we need all these things. So in order to send the messages, the expectation is we have to create a new file, that is credentials.yaml file. In our scenario, we already have this credentials.yaml file present. Okay, so since we have used the demo project, we have it already present. We just have to uncomment this. Next, what they are saying is, so if you have used the RASA init, the file should already exist, then that's okay. So we have to mention these things in this credentials.yaml file. Here we'll have to mention the Slack channel ID. So remember, this is not the Slack channel name. So the Slack channel ID is nothing but the channel that you have created. If you don't want to use this channel, maybe you'll create a new channel. For the demo purpose, I'm going to show it to you. So I'll say create new channel, and the channel name is RASA bot. That's the channel name that I'm going to create right now in front of you, and I'll say it as create. Okay, I'll skip for now. So this has created a new channel for me. So the channel ID is the last ID that you see right here, that is C04 in this example. That's the channel ID. So in this credentials.yaml file, you'll have to mention your channel ID over here for the Slack channel. Okay, that's the first thing that you have to do. Next, we have got the Slack token and the Slack signing secret. So Slack token is the token which is obtained in the further step, and also secret is something which we'll be obtaining as we progress in this video. So let's go ahead and work out on the same. So here they have given some more information. The Slack channel can be a channel or an individual person. So it's something that we have got over here. Okay, now let's go ahead and we'll have to create a Slack app in order to get the Slack token and the Slack signing secret. Now here, in order to create a application, I'll just click on the link. So the link is api.slack.com/apps. Okay. Now from this page, we are going to create a new application. I'm going to say create an app. See, they are specifying the same. We are going to create a new app right now. Now here it says create from scratch. and I'll specify the app name. I'm going to say RASA bot. Okay, that's the application name that I'm going to create. And the workspace is the default workspace that I already have, which is the manifold layer learning, which I've created in the previous video. I'll click on create application. Now, this is the page for the Slack application configuration. Next, I'll proceed with the other steps. The next steps it is actually saying is, it is asking me to go to OAuth and permission, and I'll have to scroll down to scopes, and I have to give all these scopes for me. Okay, so let's go ahead and do that activity. I'll go to OAuth and permissions, and here under the scopes, so we have to provide the scopes. So we'll have to mention these scopes under the bot token scopes. So under my bot token scopes, I'm going to add a scope right here. So I'll mention the auth scope like this. I'll say app mentions read, and I'm going to add channels history. And I'll do the same thing. I'll add everything as per the documentation page. Okay, I have added the bot token scopes by referring to my official documentation. So app mentions read, channels history, chat write, groups history, IM history, MPIM history, and the reactions write. Next, I'll have to install this app into my workspace. I'll come over here and I'll click this button that says as I'll have to install this app to my workspace. Now in this page, I'll click on allow. Okay, so this will be installed to my workspace. Now once it is done, okay, so this is going to show me the bot user OAuth token. Okay, so this is something which is very important to us. We'll copy this OAuth token and we are going to paste it under the Slack token. Okay, this is where you will specify your Slack token. Now, once this is done, okay, so once this is done, you will go ahead and you are going to gather your signing secret. So signing secret is available under the basic information, and from here you can get the signing secret, which is this. Okay, I'll click on show. I'll copy this signing secret and I'll paste it in my Slack signing secret. Okay, so this is how I'll be specifying the credentials. So this setup will allow the bot to send the messages. Now, in order to receive the messages and reacting to those messages, now the next step is we'll go to the app home over here by clicking on this left hand side of the screen. And in this page, we have to select this checkbox which says allow user to send slash commands and the messages from the messages tab. So we have to ensure that we select this checkbox. Okay. Now, once this is done, in case if you have your app open, you just have to restart it. Now, once this is done, okay, so what you have to do is you have to configure the webhook by going to the event subscriptions, and we have to enable the events. Now, in the screen of enable events, that is event subscription, we have to enable the events. Now, once we enable the events, it is asking me for a request URL. Now, the request URL by referring to the documentation will be something like this. So this is the request URL. So ngrok id /webhook /slack/webhook. Now, in order to be able to serve this request, so since we have configured the ngrok in the last session and we have just configured all the credentials right now to be able to communicate with my RASA system, I should be able to run this. That means I should rerun the same. So what I'll do is, in order to rerun, I'm going to run the command as RASA run. Okay, so till now we have been using the command as RASA shell. So RASA shell, we generally use it in order to interact with the chatbot and deploy it on a local system. Now, if I simply say RASA run, it will just go ahead and deploy the RASA chatbot server at the port 5005 localhost. Okay, it will not allow me to interact through this command line interface. It is just going to start the RASA server.
So now it is starting the RASA server again. Okay, now once it's done, let's validate it with the ngrok, and post that we will specify the request URL as per the official documentation page. Okay, now it has been confirmed that the RASA server is up and running. So let's refresh the ngrok ID, that is a URL. So we are able to receive the response. Now this is good. Now what I have to do is I'll have to say ngrok ID slash webhook slash slack slash webhook. So request URL is slash webhook slash slack slash webhook, and I'll press the enter key. So currently it is going to validate it, and now it says it did not respond. Let's revalidate it again. ngrok ID slash webhooks hooks. Okay, webhooks slash slack. Now it has been verified. So let's go to our ngrok and let's see what is the message that we are seeing. So we've got, I think it's not updated, but it looks like it has been verified. That is important for us. So that means we have configured the same. Now, once we have configured this, we'll have to go ahead and do some other activity. So the next thing that I'm going to do is I'm going to subscribe to bot events. I'm going to add a bot event by referring to my official documentation page. Okay, once everything is done, we are going to click this button, Save Changes. So our bot is now ready to go, and it is going to receive the webhook notification whenever a new message arrives. Now the last and the very important part. So what I'm going to do is I'll visit the Slack channel, that is the Slack channel which we are interested, that is RASA chatbot. Now here I just have to say @ and I'll have to call this application into this channel, and I'll press the enter key. So what it says is, do you want this person instead? So it's RASA bot yet, you can add them. So we are going to add to the channel. Okay. So what we have done is we have actually added the same. Now, once we have added it, it says, hey, how are you? Now I'll say, I am fine. So that means we have actually added it. Now, once we have added that app, that is the bot, now I'm seeing the response from the bot that says as great, carry on. Now I'll say my name is Rajat, and once I press the enter key, so it says welcome dear Rajat. Okay, wow guys, so can you clearly see what is happening right now? I'm able to start conversing with my chatbot. My chatbot has been deployed on my local system, which has been connected with the help of the ngrok. Now, one final thing that we have to test is whether it is able to perform the third party action. That means whether it can get the news and whether it can respond me with the same. Now, before I do that activity, okay, so I'll have to start my action server. So I'm going to start a new tab. Okay, now in this new tab, I'm going to say conda activate rasa chatbot, and I'm going to say RASA run actions. So this is going to start my action server. So now the action server is ready and it is running on this endpoint. Now this is great. Now I'm going to write something like this. I'll say, get me top news on business. So let's see what is the output that we get. So let's have a look into our action. So we have got a message right here. Okay, there seems to be an error in the action server. Okay, so it has identified the news category as business. Now that is great. And we are getting an error. That's fine. So let's do one thing. Let's specify our data correctly. So I'm going to mention like this, who is profiting in business. So let's go ahead and mention it that way, because that's the category that we are interested in. Wow, guys. So we can see a response. It says deal making thrived, then hit a road bump under the section business. then it was published over here. So we can clearly observe that the action server is also working. So this is a clear end-to-end implementation of the RASA chatbot. So what we have done is we have created the chatbot in our local system. We have ensured that it is able to access it from the URL with the help of ngrok, and we have set up the endpoint and the webhooks as well as the Slack channel details over here in this credentials.yaml file. And once we have configured everything, and we have actually configured our Slack application as well. Now once the application has been added, that is configured, so main thing which everyone makes a mistake is, so you have to add that application into the channel in which that you want to have a chat. Then once you add it, you can start having a chat with your chatbot. So you can go ahead and test the same. So this time I'm going to say run test action. So that's the message that I'm going to mention. Run test action. So it says hello world. Well, the bot is working exactly as per the configuration. All right, team. So I want you to go ahead and try out this activity and think about the use cases that you can implement for your project. It will be an amazing activity, team. So I recommend that you also do all these things for your project. Now in the next video, we are going to see an example project which has been shared to us from the RASA team. So I'll see you next time. Hey everyone, welcome back to your learning journey. Now in this video, let's have a look into the Concert bot, which is an example project shared to us from the RASA team. So this is the GitHub repository link. I'll be sharing you this in the description of this video. So we'll go through this example file so that you'll get a quick recap and a summary of all the activities that we have done till now. So what is present in this example? This is a Concert bot. So this is an example bot that contains only story data. Okay, we've got stories.md. So here they have actually described the stories in the MD format because this is little old version. So currently, as per the latest methodology, we have to follow the YAML format. Okay, let's have a go inside the stories. Yes, so we've got the stories.yaml file. So I think they have not updated this first page. Oh, now let's have a look into the stories.yaml file. Now in the stories.yaml file, if you look into this stories.yaml file and compare to our example files, see, we've got the user stories and the various steps that are involved. Along with that, we also have few things which are related to slots, which definitely makes you think about these slots and learn more from the official documentation. I highly recommend you to do that. Then there's a story on search concert. You can see the intent, action, and they have also used slots in the stories as well. So that's how the overall stories are described. There are slots, there are some actions. So which means we definitely have to check out the actions.py file. So overall, in this stories.yaml file, we will define the story path. Now, based on the story path, we will define what will be the intent and the action, which is nothing but this is going to derive the conversation flow between my user and the chatbot. Okay, that's the overall importance of this stories.yaml file. We've got nlu.yaml file, which is the core training data. Here we have got the intents. There are various intents and the respective examples. There's an intent called search concert. So the intent examples are find me good concert, show me concert, search concert, search venue. There's one more intent, compare reviews, how to get started, affirm, intent. So intent deny. So these are the various intents that we have got in this nlu.yaml file. Next, we also have the rules.yaml file. The rules.yaml file is like the first preference that we will have. It's like the specific rule that we would define. So for this intent, what should be the action? So this is being described in this rules.yaml file. So this is about my concert bot data folder. And if I open this configuration.yaml file, we can observe how they have actually configured the overall pipeline. So we have got the pipeline for this processing. They are making use of the white space tokenizer, regular expression featureizer, lexical syntactic featureizer, count vectorizer, as well as the character WB, that is word as well as the character grams. So 1 to 4 n-grams that I'm specifying. We are making use of diet classifier for intent classification as well as the entity extraction. We also have the fallback classifier, and then we have the policies defined for determining the action. We have got the TED policy, memorization policy, and the rule policy. Okay, that is how we have configured this configuration.yaml file. Now if I close this, there's endpoints.yaml file. Here in the endpoints, they have just described only one action endpoint. So localhost 5055/webhook. That's where the action endpoint will be used. I mean, this is the URL through which the RASA NLU server is going to interact with my action server. Okay, now if you're working on a production based application, you can also mention that URL over there instead of this localhost. Okay, now clearly you can observe that. So there's no something related to Slack, but in our hands-on project, we have actually implemented the Slack ID and all those information so that our chatbot can have an integration with the Slack channel as well. And lastly, we've got domain.yaml file. This contains everything. This contains intents, entities, slots, responses, actions. So all these things will be added in this domain.yaml file. Then we have got the actions. So I'll go inside the actions folder. There's an actions.py. Here we can define the custom action. Every action that we would define, that it will be in the format of class, where we will be inheriting the action class, and we have to override a name method to specify our own method, and under the run method we will describe how does the action should perform. Okay, so here we can actually write the custom action which will do it as per our requirement. Now in our example that we have implemented, we have ensured that the custom action was to call the New York Times API and get the response from the New York Times API server. So this is about the RASA chatbot. So we have gone through with an example that has been shared to us from the RASA team, and we have successfully been able to implement it for our own application. And I hope by completing the overall activity, this gave you an confidence and this made you feel as how easy it is to work with the RASA framework and create a chatbot on your own. The opportunities and the applications are limitless. So it's all up to you as how you are going to implement it. It is all up to your creative ability to take it to the production level. I really wish you all the very best for your upcoming project activity in your own domain. So thank you so much for being with me till this section, and I look forward to seeing you with another concept in the next video. So take care everyone.